Okay, so this is going to kind of be an all-encompassing review here for everything related to the course Quantitative Math Literacy. So what we're going to do here is we're going to get started going through all these different example problems, and then towards the end you'll hear me reference throughout the video, seeing the extension videos at the end. So what I'm going to do is sync together a bunch of like topic-specific videos, so whether it be like a linear algebra concepts, or whether it comes from factoring or some of these different special right triangle theorems we have to deal with in here. That way everything kind of goes in depth later on to those more consistent or a little bit deeper in topics. Okay, so for the first thing we have here is what is the slope of a line that is perpendicular to 3x plus 1? So key idea here, whenever we're working with equations that are of this form, so this is our linear equation. Here, m is representative of the slope, and b is what's known as our y-intercept. So it's where it crosses the y-axis at. In terms of a graph. The only two variables in here are going to be our x and our y. What those are is the things that we input in the equation. So when we're talking about perpendicular, the definition of perpendicular deals with the slope. So if we look at that equation, y is equal to 3x plus 1, and we want to deal with the perpendicular, first thing what we're going to do is identify as the slope. So the slope here, m, is just 3. Now, when we think about slope, we always want to think in terms of fractions. So if I think about any whole number, so if it's positive, negative 3, negative 7, doesn't matter. What I can always divide those by is positive 1. To avoid actually changing the number, we're just making it into a fraction. Now, if I would like to go ahead and get perpendicular, so perpendicular slopes are opposite and reciprocal. So opposite just refers to the positive or negative here. So as I move over to get my perpendicular slope, I'm going to change it to a negative because my initial slope was positive. Next, reciprocal means we flip it over. So I flip this fraction over. So instead of 3 over 1, it becomes 1 over 3. So that's how we arrived at our answer there for the perpendicular. Okay, here we have the coordinates of the y-intercept of the equation. 5x minus 3y is equal to 2. So first bit of information here is when we're looking at y-intercepts, so kind of from a visual standpoint here, there's two intercepts we're really concerned of. So there's two types, if they hit our x-axis or our y-axis. So an x-intercept would be any point that crosses this line. So any of these red points here, they all have the form of some number, comma, 0. So an x-intercept is when the y is equal to 0. Again, because our points are x, comma, y. Similarly, if we think about y-intercepts, whether they're above or below that axis, all of these points have the form 0, comma, some number. So it's when x is equal to 0. So with that in mind, to solve for the y-intercept, we're just going to plug in 0 for x. So you'll see me do a lot of this by hand. Really, there's not a whole lot on here. Maybe some of the quadratic stuff we'll model in a calculator, but it's not going to be a whole lot of complicated calculations. I'll write everything as best I can in calculator notation. So here I have 5 times 0, 0, minus 3y is equal to 2. Well, 0 minus 3y, that's still just going to be that minus 3y there. And then lastly, if I divide both sides by negative 3, that gives me y is equal to negative 2 over 3. Depending on the calculator you have, if you're not positive of how to get a fraction for that, just go ahead and ask me and I can look up the manual for that on you as well. Lastly here, so just having that in mind here, like we talked about with y-intercepts, our x value that we plugged in was 0. So for the final answer here, we're actually looking for 0, comma, negative 2 over 3. All right, as we're moving on, we have what is the equation of a line that passes through the points 2, 4 and negative 2, 6. So when we're given 2 points and we need to write that equation, we're going to start with our slope-intercept formula. So let me go ahead and label these. If we're looking at these points here, so just typical labeling order, we have x1 and y1, and then x2 and y2. So as we're finding our slope here, first thing we want to do, our kind of slope formula here is m is equal to y1 minus y2, so the change in the y's over the change in the x's. Now, if you Googled this formula, chances are you see it written the other way. I have no idea why math teachers do it that way. It gets you the same answer, and this is easier to me. It reads left to right. So if we're plugging in here, I have y1 is positive 4. Actually, what I'm going to do here real quick is just kind of, this part of the formula is actually just like a skeleton, I guess you could say. So what I'm filling in here in red. So you'll see me kind of fill in around that. So it just makes plugging in a bit easier. So I have y1 is 4, my y2 is 6, my x1 is 2, and then my x2 there is a negative 2. So the reason why I do this is pretty much all scientific calculators are capable of understanding this bottom. So what I would do when simplifying this is I would simplify the top. So in the calculator I do 4 minus 6 and get negative 2. Then in the bottom I would do 2 minus negative 2 and arrive at positive 4. However you're using your calculator, it should simplify this for you to end up at negative 1 over 2. So that's going to be our slope. So again, anytime we write a linear equation, so linear just means it's 2 points. It's anytime they say the word line, basically, we're going to get to something that looks like this. Okay, so we have our m. So this is our m here. Now the next thing we need to do is find our b. So what we could do here is pick either one of these points. So I'm just going to choose the first one here. Again, it does not matter which one you pick. So I'm going to use the information of m, and then that x and y that I'm going to plug in here, because we don't know what b is going to be 2 and 4. So in here, I'm going to plug in my y of 4. Here's going to be my x of 2. And then we're going to go ahead and plug that m into here. I'm just going to show the work down here. So I have 4 is equal to negative 1/2 times 2 plus b. So order of operations, first thing we want to do here is multiply. So in your calculator, I would do negative 1/2 times 2, and that would arrive at negative 1, then our plus b. Now to get b by itself, I need to move that negative 1 over. So the opposite of a negative is a positive, so I would add 1 to both sides. That would give me 5 is equal to b. So now that I have those two pieces of information, I can go ahead and write my equation. So the equation is going to be y is equal to m, x, and then it's a positive 5, so I'd put plus 5. If b were negative, I'd put a minus symbol here. And that'll be our answer there. Okay, so here we want an equation line that is parallel and goes through a point. So a little bit more about definitions here. So by now we should be able to see the slope here. So looking at this equation, I know my slope is negative 4. Now for perpendicular lines, we did that opposite reciprocal. However, when it comes to parallel lines, we actually just keep the slope the same. So when I'm going into my parallel slope, it's still just going to be negative 4. And then it tells me that's my m, and I want to use the point negative 4 comma 9 is my x and my y. So really it's just like step 2 of this equation up here where we plug in. So if I'm plugging into that function, I got to solve for b because it's the only piece of information I don't have. So I'd have 9 is equal to negative 4 times negative 4 plus b. So again, here's my m, here's my x. They both just happen to be negative 4. Multiplying on the right side, negative 4 times negative 4 is 16. Subtracting 16 because it's positive and I need to get it away from my b. That'll give me negative 7 is equal to b. So for our equation, I'd have y is equal to m and my x, and then b, since it's a negative, it's going to say minus 7. Okay, solving a system of equations. So again, this is one of those topics. I'm definitely going to throw in a bunch of videos on here at the end, but I wanted to get all your questions first and then give you those resources at the end. So let's go ahead here and we're going to write this out. Okay, so the videos will expand on this further. When you're solving systems of equations, meaning we have more than one equation, and we just solve them together, there's a lot of different options. For the sake of time, I'm going to try to keep this kind of short and to the point with these, and if you understand the way I taught it, great. If not, like I said, those extension videos at the end are going to show you multitudes of ways to do these problems. And they're all created by me. You'll notice it's still my voice. I just thought I'd try to idea in mind. I'm going to show you the shortest method, and then if you want some expansion, some different stuff, I'll include those videos at the end and kind of title them as well. So this is a systems of equation problem. So first thing we're going to do here is look to eliminate. So the idea behind elimination is that we get a positive and negative coefficient, so the number in front of the same variable. So I always like to just cancel the x's. So if I look at these two, I need to find a way to multiply one or both of these numbers to make them match. So I always start with looking at the smaller number. So I'm thinking, what can I multiply 2 by to make it equal to 4? If we think about that, right? So if I think, well, 2 times 2 gives me 4. So if I multiply this entire bottom equation by 2, you always want to multiply by whole numbers. You can do it by fractions. It just tends to get less nice looking then, I guess. Now the other thing here, so if we think about these leading terms, if I had some number x, so if we have that some number here times x, and then another number times x, ideally we want these two to be the exact same number except one positive, one negative. So if I think about this, well, 2 times 2 will give me 4. So if I want to get a negative 4, I'm going to multiply it by a negative up front. Now, we multiply this, we're going to go ahead and distribute it out. So I'm going to just go ahead and rewrite this here. All right, so our top equation we're going to keep the same. So I'm just going to bring that on over here. Because we're not doing anything to that. We don't need to for this problem. Now, this bottom one, when I go ahead and multiply, so negative 2 times positive 2x will give me negative 4x. Negative 2 times positive 2 gives me negative 4y. And then negative 2 times positive 4 gives me negative 8. Now, when we're going to solve this, once we've set this up, notice the x's are lined up vertically, the y's are lined up vertically. We can just add down, so add vertically. 4 plus negative 4 gives me a 0x, and 0 times anything is just 0. So here, the idea of elimination is that these cancel. Adding down, negative 3 plus negative 4, and again, in a calculator, I would just type it like this. That'll give me negative 7y, and it's equal to 1 plus negative 8. So 1 plus negative 8 gives me negative 7. Now, to get just y, we need to do the opposite, right? So the opposite of multiplying by negative 7 would be dividing both sides. So I'd get y is equal to positive 1. Lastly, to get our x value, we can use any of the equations we have. So I'm just going to use this one here. And again, it doesn't matter. Basically, I'm going to plug in that y and then solve it for x. So if I have 4x minus 3, and then I'm substituting my y of 1 here, is equal to 1. So when I do your negative 3 times 1 is minus 3. I'd add this 3 over here to get the 4x by itself. So 1 plus 3 is 4. I'd divide both sides by 4 and get x is equal to 1. So my answer, 1, 1. All right. Over here, we have in the equation 5 over 2 times x plus 1. For every 10 units up on the slope, the point will move how many units horizontally? So here, we got to think about what the slope means. So we're talking about the slope, so that's this number here. Now, basically, here's our breakdown of a slope. If it's positive on the top, we're thinking about moving up. If it's negative, we think about moving down. For the bottom, if it's positive, I'm down here on the positive side, sorry, just reading my own handwriting there. On the bottom, if it's positive, we move to the right, and if it's negative, we move to the left. So if we think here, we have a positive and a positive. So what this slope represents is going up 5 and right 2. So it's saying for every 10 units up on the slope. So if I think about that, 10 units, well, that's doing the slope 2 times. So that's how I get to that 10. Now to see how far we'd go on the bottom, if we multiplied 5 by 2 to get to 10, we'd multiply it on the bottom as well. So that gives me a 4 on the bottom. So that's where they're getting this answer from here, because it's a positive 4, so we're thinking about going right 4. Right. There we go. Okay, here we have which equation corresponds to the following graph. All right, with this one here, again, I'm going to include some videos on this, so getting the equation from a graph for both equations and inequalities. Essentially, we want to think about these things. So let's start if it was just an equation, right? So y is equal to mx plus b. This b is represented by a point on the graph where we said it's the y-intercept. So this is always going to be my y-axis. This is always my x. If I'm looking here where it goes through, so if we look, we see it's going through between 2 and 3. or between 2 and 4, I should say. So that's telling me that the y-intercept here, the b, is equal to 3. Now, in order to find the next point here, we need to kind of look on the grid lines and see where it goes through here. So when we use these grid lines, if I'm looking at this scale, so I went up 1, 2, 3, and that's representative of the number 2. And I go up 1, 2, 3, that's represented by 4. So for every 3 spaces that I move, it's equal to 2 units. Don't ask me who programmed this problem. It's really not their best work. That doesn't really make a whole lot of sense, but again, we're going to make it work. So if we think about it here, what we want to look for is how we can get our slope. So the slope is saying how does it change from one point to another. So if we look at this here, we want to find where another good point is going to be. So we want to think about where it crosses those grid lines. So if I'm looking here, it's going to be somewhere here, right? So that's where it's kind of crossing on those grid lines at. So if we count our slope, we want to think of it as being the rise or the up and down over the run. So when we read a graph, we read it just like we read a book. We start on the left and we go to the right. So if I'm looking here, I'm going up 1. Sorry, not my best highlighting there. We go up 1, 2, 3, 4, 5, 6. So I went up 6 units, and we said, well, 3 spaces is equal to 2 units. So it's like I'm going up 4 total. So since I went up, it's a positive 4. Now, from there, it looks like I'm going right 1, 2, 3. And we said that 3 spaces equal to 2 units. So that's saying I moved 2 units to the right. So if we simplify that, 4 divided by 2 is just 2. So if this were a linear equations, they don't have shading. If it were linear, it would look like y is equal to 2x plus 3. Now, if we're thinking about this here, so you'll notice your choices here. They have greater than, less than, or less than or equal to. Essentially what we're looking for here is how to figure out what it is. So if it's a dashed line, it's either going to be this or this. If this were a solid line with shading, then it would be either this or this. So we have greater than or equal to, greater than, less than or equal to, less than. Right? How we figure out what our final answer is going to look like. So all that's going to change, this equal sign is going to become something else. Essentially, if it's shaded above the line, it's a greater than. If it's shaded below the line, it's a less than. So since we're below this line, if I basically pick a point, if you go down, that's the below. If you go up, that's the above. We know we're going to be a less than. Now, why it's just the less than? Essentially, if it's a dashed line, then there's no line underneath. If this were a solid line, then it would get the line underneath there. Let's make sure I'm not skipping any here. Slope-intercept form from standard form. So standard form basically just means that x and y are on the same side. Slope-intercept form is the one you've seen me reference throughout this video. It's the most common. Essentially here we want to get y by itself. So if I'm going to take this equation here, and we want to get y by itself. First bit of advice, whenever you have just a variable like just x, just y, just whatever, there's always like a 1 in front of it. So in this case, this negative x is actually like saying negative 1x. So if I want to get that y by itself, the first thing I'm going to do is I need to move this x over. I need to get it away from my y. So the opposite of a negative 1x is adding 1x to both sides. So that gives me 2y. Now, since these are not like terms, one has an x, one's just a number, we can't combine them. So typically, we just go ahead and write the x term first. Lastly here, I need to get just y. So I'm going to divide every single term here by 2. So that'd give me y is equal to, I have 1 over 2. Again, your calculator uses the fraction function. It doesn't reduce, so it's just 1 over 2. X, and then negative 8 divided by 2 reduces to negative 4. Okay, on to a word problem here. We have Tony's tires has shown growth over the last month that follows the equation. Sales is equal to 4 times, so the parentheses mean, day of the month plus 16. On what day of the month will Tony's tires double its first day sales? Two-part question here. So it's saying double its first day sales. Well, first that means we need to figure out what the sales will be here on the first day. So if it's the first day, that's just like saying we're plugging in 1 for that day of the month. So I'm going to plug in a 1 there. That'll give me 4 times 1 is 4, plus 16 gives me 20. So those first day sales are equal to 20. And then it's saying what day of the month. So I'm just going to call this day of the month X, right? So for this term here, I'm just going to call it X because I don't know what it is. And it's saying, will it be double those first days? So double the first day tells me that that's timesing it by 2. So my sales are 40. And now I want to solve this equation for X, the day of the month when that'll occur. So first thing I'm going to do is go ahead and subtract here 16 from both sides. So that'll give me 24 is equal to 4x. And then when I divide both sides by 4, 24 divided by 4 gives me 6. So that's actually how we arrived at that one there. So let's move on a bit here. Okay, we have for the equation y is equal to 6x minus 8. When x is equal to 3, y equals. Okay, so when we're looking at this one here, it's basically it's telling us to plug in 3 for x. Excuse me. So we get y is equal to 10. So again, just a plug in equation. Whenever they give you one number, you can just go ahead and plug it in. Okay, which quadrants on a Cartesian plane will the graph of y is equal to x minus 3 be located? Okay, so let's start off with what are the quadrants? So this is going to be really weird. First off, they use Roman numerals. Don't ask me why. They're labeled in this fashion. So they go 1, 2, 3, 4. Now, let's get into the graphing. So what I'm going to do is just throw some lines in here. I apologize. As a math teacher and statistician, that doesn't always mean we have the best handwriting. And again, the videos I use later on will have some stuff like implemented in here where it's a little neater. So let's get started with this. Oh, sorry, forgot my circle here. All right, that's also not necessary. Sorry, I'm just a bit of pet peeve there. Okay, so we talked about when we have just a variable, we throw that like placeholder of a 1 in front of it. So for this x here, I'm just going to put a 1 in front, right? Now, the two things we need when we're graphing are going to be our m and our b, so our slope and our y-intercept. So my b, if we think about that, y is equal to mx plus b. My b here, since it's minus 3, is going to be equal to negative 3. So first I'm going to plot that b. So it's on my y-axis, and I go down to negative 3 and make a nice point. Now, the next thing I need here is my m. So right here, I just have my m as 1. Now, whenever we think about slope, like I said, we want to think about it as a fraction. So since we have a whole number, we're just going to go ahead and divide it by 1. Now, if we go ahead and graph this, think about that 1 over 1. So what I want to do is move from my b. So since it's positive, I'm moving up. Since it's positive, I'm moving right. So from here, I'm going to go up 1, right 1. Up 1, right 1. Up 1, right 1. And if we go ahead and draw that line in there. So answering which quadrants, I can see it's going through quadrant 1, because again, lines go on forever in both directions. Quadrant 4 and quadrant 3. So since it's straight, it's never actually going to hit quadrant 2. Okay. All right, so first off, this website doesn't have the best input notation. Maybe they'll hire me someday to kind of increase that for them. But let's go ahead and take a look here. So what this equation is looking like, what they're saying, it's saying y is equal to x up to the 4th power plus 18. So when they're asking us here when x is equal to 2, so we're going to go ahead and substitute in. So what that means is I'm just plugging in here. So for my x, I'm going to go ahead and plug in with some parentheses there. More on that later. To the 4th power. So I'm trying to color coordinate this good here. Plus 18. Now, what's nice about their notation actually is that's how you type in the calculator. So in the calculator, what this would look like is I would type 2, the upward caret. I always put parentheses around my exponents. And same thing with the base. If you put parentheses around them, if it's ever a negative number, it won't mess it up. So when you evaluate that in the calculator, what that's saying is 2 times 2 times 2 times 2. So times itself 4 times. So that's going to give us 16 plus 18. And then when we add those, we'll get 34. Okay, which of the following is the correct equation for a line with a slope of 2 that passes through the point 6, 2? So our slope is our m, right? And then we know our point is our x, y. So let's go ahead and plug into our y equals mx plus b to get that equation. So my y here is 2, my m is also 2, my x is 6, and I need to solve for my b. So 2 times 6 gives me 12. Then when I subtract this 12 from both sides to get b by itself, I'll end up with negative 10 is equal to b. So my equation would be y is equal to 2x minus 10. Okay, inequalities. Really, really similar to when we have that equal sign, just one little like kind of trick in there. So let's start off here. We got 3x plus 12 is greater than 24. All right, so first thing when we're solving, right, we always want to do our adding or subtracting first here since there's no parentheses. So I'm going to go ahead and subtract my 12 from both sides. That gives me 3x is greater than 12. Lastly, to get just x, I'm going to divide both sides by 3. And I'd end up with x is greater than 4. Now, the only trick with inequalities is if you divide or multiply both sides by a negative, this sign switches. So if I had something like negative 5x was greater than 10, when I would divide everything by that negative 5, that would cause this sign here to flip. So that means it would go this way, and I'd get x is less than negative 2. So that's kind of the only like one little trick there is there with inequalities. Okay, so here it's saying which of the following satisfy the inequality. So if I want to simplify this a bit here, we'll just go ahead and divide both sides by 5. And I'd get x is greater than 2. So if I'm checking, the only one of these where both of the x's are greater than 2 was that choice here. Okay. What is the inverse function of 4x plus 16? Inverse function is a little bit of a, it's kind of like a vocab thing. So what inverse basically means is think of like the opposite. So to find the opposite, all I'm going to do is switch the location of the x and y and then solve for y. So step 1, we switch the locations. So I'd have x is equal to 4y plus 16. And then now the step 2 is I need to get y by itself again. So to get y by itself, I want to move the 16 away. So I'm going to subtract it. So I'd have x minus 16 is equal to 4y. Again, anytime I have a variable, just put a 1 in front. It makes it easier at the end. And then now I need to divide everything by 4. Because again, I want to get just y. So over here, I'd get y. Well, let's see. So 1 over 4, that doesn't reduce. So it's just going to be 1 over 4x. And then negative 16 divided by 4 is minus 4. So we can see our answer there. Okay. Here we have some compositions of functions. So a little bit all around, but we're going to get to it. We got this. So here's our, so it's going to look like x squared, and this is x to the third. And it's saying f of g of x. So what that's basically saying is take g of x, which is here, and then plug it in for x there. So let's go ahead and start with what f of x is equal to. So we said that f of x is equal to x squared. And now we want to go ahead and plug that in. So I'm going to take that term, and instead of x, I'm going to replace it with that g of x, which is x up to the third. Now we need to simplify. So some rules with exponents. If we had something like this, if I had say x squared times x to the third, that rule, if we're multiplying with the same base here, then we would add the exponents. So that'd be x to the fifth. When we're multiplying here, so let me just go ahead and write these like as general rules. That'd probably be better. So if this was to the a and this was to the b, this would be a plus b. And the same holds if these are negatives, so it'd be like a positive plus a negative type thing. If we have something like this, then we actually multiply those. So again, those are just some rules type thing. So here, x to the third to the 2. Well, 3 times 2 just gives me 6. And then lastly, they're saying when it's actually equal to 2. So a lot of parts here. Basically, it's saying plug in 2. So that would give me 2 to the 6th power. So in the calculator, this would be the notation I would utilize. Parentheses aren't totally essential here, but they'll be useful later on. And that'll give us that 64. Position here, right? So I'm going to go ahead. We have f of g of x. So I'm taking that g of x function and I'm plugging it in for x there. Okay, so if we're working through this, right? So I'm going to take my f of x and then I'm going to plug in g of x. So in our place, I want to use parentheses. And looks like we're done with this one. There's typically some ways you can expand that, but it looks like here we at the first step we had the answer they wanted. So we are actually good to go there. Composition again, right? So we're going to start with our composition, then we'll worry about the rest of this. So if we've gotten used to that pattern, I'm just plugging in. So my composition here is for parenthesis x minus 2, and it's saying find z when x, so this is what it's saying, f or z is actually equal to that composition, and then we're going to plug in x as 1. So I'd have z is equal to 4 times 1 minus 2, and this you can just type into a calculator just how it looks, and we'll get negative 4. Okay, compound inequality. Okay, kind of surprised they have these in here. All right, sorry, I don't know why it keeps doing that. Just maybe if I start writing. Okay, so we got negative 4. It's less than 2x plus 6. It's less than 22. Okay, so compound inequality is basically like a double equation, right? So if we do it on one side, we got to do it on both sides. So if I'm moving this, I'm going to subtract 6 first. So if I do it here, I got to do it everywhere. So it'll cancel. I'll have just 2x in the middle. Negative 4 minus 6 is negative 10. And then 22 minus 6 gives me, was it 16? Lastly, I'm going to divide everything by 2. And I'll end up with negative 5 is less than x is less than 8. And again, the same rule applies here. Should we have to divide by a negative, just like with the single inequality, then both of these are actually going to kind of flip order. All right. Okay, another inequality. So we have negative 1/2 x plus 8 is greater than 24. All right, so first step, we want to subtract 8 from both sides. Now, when we have a fraction like this, so dividing by a fraction, okay, so let's say I want to divide both sides by negative 1/2. I'll show you that way first. That would look like this in a calculator. And there, those parentheses are really important. If you do that correctly, you should get negative 32. If you're comfortable with that way, awesome. The other way here is multiplying by what's known as the reciprocal. So to get rid of division, we multiply, so the reciprocal, so it'd be negative 2 over 1. So whichever way you prefer, they're going to get you the same spot. Regardless here, we'd have this being negative 32. And this is that example I spoke of earlier. Since I'm either multiplying or dividing both sides by negative, the inequality changes direction. So that's where they got that answer there. Okay, we got g of f of 4 if g of x and f of x are those equations respectively. So here it looks like we got f on the inside, right? So this is going in here. So for my composition, I'm going to go ahead and have square root of x plus 1. And then it's saying when f is 4. So I'm going to go ahead and plug in 4. So I got the square root of 4 plus 1. Your calculator should be able to simplify that for you. So the square root of 4 is 2, and 2 plus 1 gives us that 3. Okay, which of the following equations represent a line that goes through those points? So we've seen this earlier, right? So first thing we want to do is get our slope. So x1, y1, x2, and y2. So I have y1 minus, oops, sorry. So my y1 here is 3, my y2 is 1. On the bottom, I have x1 minus x2. So I'd get 2 over 1, which is just 2. And then let's say I want to use, let's use this point. So I'm going to plug in now and find my b. So I'd have 3 is equal to 2 times 2. So mx. Get 3 is equal to 4 plus b. Subtracting 4 from both sides, I get negative 1 is equal to b. So my equation is y is equal to 2x minus 1. Okay, which of the following is a point on the function y is equal to 3x minus 2? Okay, easiest way to do this is process of elimination. So what I would do, I'll show you one of the wrong points. Basically what you want to do is plug in these x, y's and see which one gives us a true statement. So let's say I tried this point, or the one you tried, right? You could use any of them. Again, it's just if you get it right the first time, great. If not, just keep plugging through. So we want to plug that in. So here my y is negative 1 and my x is 2. So when I simplify that right, so I have 6 minus 2 gives me 4. So since this is false, that's not going to be an answer. You'll find the same thing for these two. They'll just give you false statements, like two numbers that aren't equivalent. And then when you try this one, you'd have negative 8. So when I simplify this right side, that's negative 6 minus 2, that gives me negative 8. So there it gives me a true statement. And again, these numbers are irrelevant. It doesn't matter what they are. But as long as they're exactly the same on both sides, then that's a point of the function. So it's a true statement. Sorry, that was false. Okay, so let me see here if we're getting into our quadratics. So I'm pretty sure they were all grouped together. I just wanted to make sure that we had them all in here. Okay, let me see if we got it good. Sorry, I'm just kind of previewing here to make sure I have everything ordered the way I want it to. Okay. All right, so what I'm going to actually do here is I'm going to go through all the problems that aren't quadratic, and then towards the end of the video I'll come back and circle through all those, just because that's kind of its own topic. Okay, so let's do, I think this one quadratic, right? Yep, okay. Let's go ahead and do this one here. So we have a colony of bacteria. Starts with 9 bacteria at noon. If the number of bacteria triples every 20 minutes, how many bacteria will be present at 2:40 p.m.? Okay, so what this is an exponential function. So an exponential function looks something like y is equal to, I'm going to call it a here for our initial value, times b, whatever our base is, and then we're going to go up to the x, or up to the t, you may have seen in some places. Okay, so first thing here, a is like that initial value. It's how much we start with. So it says it starts with 9 bacteria at noon. So I know I'm going to have a 9 here. Let me just sketch out some stuff here. So these things basically always stay in the same spot. Okay. Next now, it's saying the vocab. So to get the base, it's basically how often the cycle completes itself. So you can have things like doubles, triples, quadruples, halves, thirds, quarters, right? So it's basically taking those words into math. So tripling would be it's 3 times, right? So that means my base is 3. And then our x here, we're just going to leave as x for now. Okay, now it's saying how many are going to be present at 2:40. So let's figure out if I'm going from noon to 2:40, right? So I think about minutes, so that's 2 hours, 2 hours, and then 40 minutes. So let's just get that all into minutes, right? It helps when you just combine it. So 2 hours, that's 120. So if I add those two, that's 160 minutes, right? Now the key here is to see how many times this cycle is going to go through. So I'm saying every 20 minutes is 1x, or one of these cycles. So if I think about that, well, it goes into there 8 times. So if I do 160 divided by 20, that gives me 8. So what we want to go ahead and do there is plug in 8 for our 3. So what it would look like, I'm going to kind of use the calculator notation here. I would type this in. So your multiply symbol probably looks like that. It'd be 3 up to the 8th. And when you type that in correctly, you will get this answer. Here, again, working on those exponentials, right? So a laptop loses 2/3 of its value each year. So let's use that same equation. It says we have a $600 laptop, and how much is it worth after 15 years? So here, our initial value is 600, and then that base, so losing 2/3, we'll put 2/3 in there. And it wants us after 15 years. Notation, you'd be typing in this, sorry, multiply symbol. And then you'll arrive here. Well, actually, it's a little longer if you look here. So I wasn't able to get your calculator to emulate, but here's a similar one, right? So that's my notation there. And then we get to that same answer around it. Okay. All right, logarithms. So this is another thing. I'll include a video expansion at the end here. I'm just going to kind of do my best here to summarize. Then again, that video at the end will go more in depth. So again, I'm really just trying to focus on these topics that are kind of more broad and then give you access to that as well, right? Okay, so I have e to the 2x is equal to 40. E is a special logarithm, and the opposite of e, this is kind of rule here. To undo e, I'm going to take the natural log of both sides. So natural log, think of like it's just an operator basically. It's like think of like a special division. So when I do that, these go away and the top just comes down. And then the natural log of any number is literally, it's just like a really weird looking number. Lastly, I need to divide both sides by 2. So I get x is equal to the natural log of 40 over 2. Depending on your calculator, if you can't find it, just let me know. It should say ln, but to give you an idea what this number is going to look like, it'll be something along those lines of how you're going to type it in. So that's how they got their answer there. And again, your calculator is probably all different. This is just the only one I was able to create an emulator for on this time frame. But if you need help finding it again, just shoot me a message. I'd be happy to look that up if you can't find it. Okay, here we have what is the diameter d of the lens in millimeters that is required by a telescope to see a stars of magnitude 17 using this logarithmic equation. So it's saying we have m is 17, so we're going to plug that in. Okay, so again, there'll be much more on this in the expansion towards the end, but once you get to that, you'll see that anytime we have a logarithm without a base, there's a 10 on the bottom. So solving this, first thing we're going to do is subtract 2 from both sides, so I get 15 is equal to 5 log base 10 of d. Then I would divide both sides by 5. Kind of right to the side here, so I'd get 3 is equal to log base 10 of d. And then lastly, again, the expansion video will touch more on this. To get rid of a logarithm, we think of doing the what I would call doing the base up. So the base is the small part of a logarithm here, it's a 10. So I'm going to make both of these sides 10 up. So doing like a base 10 and then putting the whole equation in the exponent. So these here will actually cancel. So I get just d. And then over here I have 10 up to the 3. So in a calculator, 10 to the 3rd power will give you that 1,000. And again, this higher math stuff, so the logarithms and the quadratics, when we get to them, if you check out those expansion videos at the end, they'll do a really good job of kind of expanding on those ideas. Okay, so we have 14 over 3 divided by 12 over 3. So let's go ahead and write these out as giant fractions. So 14 over 3 divided by 12 over 3. So when we divide it by a fraction, we actually multiply by the reciprocal. So the top is going to stay the same. And then I'm just going to flip this over. So I'm going to utilize the reciprocal. Now again, pending the capabilities of your individual calculator, Here would be how, if I wanted to type this in all at once, this is what I would type. So I'm going to show you the by hand way. This is just the straighten the calculator way, and we'll get to the same answer. So depending on your calculator, it might get you to that. Some calculators, they would get you to 7/6. I'm just going to show you the by hand. So here we multiply across first. So that would give me 42/36. Then you can reduce that in a calculator, and that'll get you that 7/6. And then the mixed number is just saying, so how many times can the bottom go to the top without going over? So 6 goes into 7 one whole time. And if I think about it, I have that one extra one, so that's where that 1/6 comes from. Okay, that's another quadratic, another quadratic. This one we don't need quadratics. We can solve this one now. Okay, so I have x plus 1 divided by x plus 3 is equal to 2/3. Okay, so let's get rid of the fraction. So I'm actually going to multiply both sides of this by x plus 3. Now notice here when I'm working with fractions, I'm only going to multiply on the top. So these cancel. So I'd get x plus 1 is equal to 2/3 x plus 3. Now let's go ahead and distribute over here. So I'd have x plus 1 is equal to 2/3 x plus, when I do 2/3 times 3 in a calculator, I'll end up with just 2. And then if I want to get, let's get my x's on one side. So let's say I want to subtract that 2/3 from both sides. So again, we have a 1 out front of our x. So I'll do 1 minus 2/3. You should end up with 1/3. So if I subtracted that over, I get 1/3 x plus 1 is equal to 2. I'd subtract 1 from both sides. And then lastly there, so again, we either divide both sides by 1/3 or do that reciprocal, multiplying by 3/1. And we'll end up with x is equal to positive 3. So that's where they got that 3 only from. And we can go ahead and do this one. Okay, so let's write this out a bit nicer. Okay, so here we just have a bunch of adding and subtracting. So what we're looking for is like terms. So I'm going to start off with my just whatever comes first, right? So if I'm looking here, my biggest exponent is to the third. So if I'm looking at my terms to the third power, so since we're not going across an equal signs, we just combine them as they are. So 4 plus 5 would just give me 9x to the third. And we're adding them. We just add the coefficients, those numbers out front. The exponent stays the same. Next, I have squared, so I'm just going downwards. So I have a positive 3 and then a negative 4. Well, 3 minus 4 would be negative 1 or just negative x squared. So you have the 1 there, not. Let's see, I have just an x here and here. So negative 2 minus 3 gives me negative 5x. And then lastly, my constant, so 1 plus 2 would just give me 3. Right, just enough colors. That's our answer there. Okay, some subtraction here. So we got 4x squared Okay, so the one extra step here, when we have a subtraction, it's like having a negative 1 and distributing it. So basically when we multiply anything by negative 1, it just changes those signs. So I have nothing out front here, so these terms are just going to look exactly the same. And then, like I said here, I'm just going to switch those terms. So this positive turns into a negative. Same thing here. And then that negative at the end turns to a positive. Now we can just go ahead and combine, just like we did in the previous problem. So I have 4x squared minus 2x squared gives me positive 2x squared, negative 3x, you got negative 6x, then 4 and 1 just give me 5. Okay, so it wants us to simplify, then it's asking us about a coefficient. So a coefficient, if I have some number in front of a variable, it doesn't matter what your exponent is, 1, 5, 10, anything. That's the coefficient, just the number out front. Could be positive, negative, fraction, whole number. All right, so let's simplify first. Okay, so when we simplify, and then they're saying the coefficient associated with the highest order exponent. Well, the highest order exponent we have here is to the third power. So it's just saying that coefficient out front. So that's where the answer just 3 comes from. We're going to come back to this one. This one's going to involve some factoring later with quadratics. Same thing here and here. All right, here's one that said x is equal to 1, so we'd just be plugging in. So if I do my parentheses, again, this is a calculator question. If you can type that in and get to the same answer I get to, you're good there. I would literally type it just like this. Okay. I'm going to this one right now. So working on some polynomials. Okay, so let's rewrite this first. Okay, so what they want us to do here is expand. So let's go ahead and expand. So I'm going to start by multiplying my 3 to both things here. So that gives me 3x plus 6. And I didn't do anything with the rest of this, so I'm just going to bring it on down. Now, this is where we have to pay attention. So these arrows help. I know they're not the most exciting thing, but they work. So I'm going to do my first term times this term, because when we distribute, we have to distribute both these terms. So I'm going to start here. So I have 3x times x, that's 3x squared. 3x times negative 2 is minus 6x. Now I have to also do this other term to both terms. So 6 times x is plus 6x. And then 6 times negative 2 is minus 12. I'm just going to go ahead and bring the rest of this down. Now, before we distribute again, let's go ahead and combine what we can here. So I just have one thing to the squared. These two, they both have x, so I can combine them. And this is one of those cases where it actually cancels. So negative 6 plus 6 is 0x. So that just goes away, because 0 times anything is 0. And then if we go ahead and distribute here, so that'd be 3x cubed, because there's the 1 in front, right? And then plus 15x squared minus 12x, and then minus 60. You can see that's our answer there. And we'll save that for later as well. Also factoring. Here's another one we could just simplify. So again, we've seen that big fraction earlier, so let's just do 6 over 5 times the reciprocal. All right, so flip that bottom, multiply across gives me 12 over 15. And again, your calculator should be able to reduce that for you. Again, if you're having trouble with that, feel free to reach out and ask, and you'll get 4 over 5. Again, if I was typing this in the calculator all at once, I would try this. There's like a 90% chance your calculator can handle this. You should be able to get right to that 4 over 5. or it might go to 0.8, then you might have to convert to a fraction. Again, if you're having trouble on that part, just ask. Okay, so this one here, the calculator can't do. So let's go ahead and do our reciprocal again. So if I flip my bottom, multiply across, x times x is going to be x squared, and then y times y is y squared for their answer there. I'm going to save that one for tomorrow, or not tomorrow, sorry, the second portion of the video, I should say. Same thing there. Sorry, I'm trying to get all these quadratics for one day. More quadratics, more quadratics. Okay, let's do a little bit of conversion here. So we have Alright, so looking at some conversions here. So we want to go from grams per milliliter over to pounds per liter. So if we think about our little hint here, we're talking about pounds and kilograms. So if we want to go from grams to kilograms, vocab, that's dividing by 1,000. So if I divide that by 1,000 in the calculator, I'd get 0.0136. So that's how many grams I have per milliliter. So that gets me to the kilograms. Now, next thing I want to do is I want to move over here. I want to get from, so I'm just going to worry about my top right now, right? So I have grams to kilograms. Now I want to go from kilograms to pounds. So it's saying for every 1 pound, that's how many kilograms I get. So to convert, I would divide. I may have typed that in a second ago. Nope. So 0.0136. Divided by 0.54 or 454. And there's my answer. So 0.02995. And then lastly, we want to go back to grams, or sorry, liters here. So to go from milliliters to liters, we'd actually multiply by 1,000. So that's going to give me 29.95, which we'll see our closest answer is going to be 30. Okay, reflecting the 0.23 over the y-axis and translating it, up 1 and left 3. So let's think about how this looks. So let's go ahead and graph this out. Let's get some points in here. So I have the point 2, 3. Now, reflecting it over the y-axis, that means I translate it over this, right? So instead of going up 3, I'm going to go down 1, 2, 3. Oops, sorry. Oops. So I made a common mistake there. This is the x-axis, this is the y-axis. So over the y-axis would mean I'd go this in the opposite direction. So I'd be at the same height, with 2 in here. And then it says I want to go up 1. So I'd go up 1 and left 3. So up 1, left 1, 2, 3. So the coordinates of that point would be -5, +4. Let's see what we got here. Okay, translations. So essentially the ways they're read, if it's positive, we're going to go adding 2, and then negative, we're going to subtract 2. So essentially here we want to, since it is -1, we're going to add 1 to my x coordinate. So from that +2 there, this gives me a 5, and the subtracting 1 from the y also gives me 5. So translations, we just kind of add or subtract as it's written. Okay, the perimeter of a right triangle is 12 inches. Oops, let me get rid of that weird little thing there. Given that one of the legs is 4, calculate the length of the hypotenuse. Okay, so let's think about this here. So if I know the distance around the triangle is going to be 12 inches, and I know that one of the legs, so refers on the shorter side, so just say this is 4, right? And we want to figure out the hypotenuse. Okay, so if I take away that side that's 4, so if I do that, I know that these two sides, let's say I call them A and C. I know that A plus C is equal to 12 minus 4, which is 8. Kind of process of elimination here. You're going to narrow it down, so assuming they're going to give you whole numbers for this, the only way it's going to work
we can see that 11.3 is going to be way too big here. I'm not sure what the other multiple choice ones here were. There's a variety of ways here, like memorizing right triangles. There's one that's a 3, 4, 5. There's a couple other ones there are for the hypotenuse, which is just the longest side here. So it's always longer than both of the legs. I would have needed a better screenshot of this one to go more in depth. I have included a video with everything to do about right triangles at the end there. What I'll do is kind of summarize that video for you as well. But it's like hours and hours of footage kind of covering all the big topics on this. So outside of this review itself, what I did, like I said, I've also included additional more in-depth kind of whole units focused on these concepts. So overall, you should be getting about 10 plus hours of video here. Which again, I'm not going to charge you the full thing because a lot of it was just editing and get everything in order. But this would be comprehensive studying for pretty much anything this test can throw at you. Okay, so again, there will be, as I mentioned, a nice video about this. But with these right triangles, so in a 45, 45, 90 triangle, this would be the relationship we'd be dealing with. And again, the video will go more in depth on that. I believe it's the last one I put on there, so it's towards the end of the very, very large video, but it'll be in there. So it says we have a hypotenuse equal to 8. So if we think about the triangle they're giving us, that's kind of like the formula for these triangles. Here's what they're telling us. So I know that my hypotenuse is equal to 8. So to figure out this value, x, that's our variable that tells me the legs here, they're the same in this type of triangle. I'm just going to go ahead and set 8 equal to x root 2. And then if I go and solve that, so in your calculator it should look similar. So I divide both sides by square root of 2. And we see I get our answer there. So the x, being my leg, is equal to 5.66 if we round. Okay, so I'm going to get my skeleton here for a 30, 60, 90 right triangle. And this is the 30, and this is the 60 angle. Okay, and again, more on that in the video later on here. This is kind of the shortcutting solving here. So we have the short leg is 3. So we're being told that this is equal to 3, and we're going to find out the hypotenuse in the long leg. So our hypotenuse is always across my right angle. So for my hypotenuse here, 2 times 3 would just give me 6. And then this one here is going to be 3 root 3. So hypotenuse being 6, so we're either here or here. And then that 3 root 3 right for our leg. And I kind of go through the more complex version of these problems again in that video as well. Okay, so we have a jogger runs 200 feet north and then 250 feet west. Shortest distance to get back. So let's see, if I run 200 feet north, so I'm just going to think of a compass here. So north, east, south, west. So if I'm going 200 feet this way, that means I'm going up 200 feet. So let's think of this as my starting point, right? And then I went 200 feet west. So I'm just going to write this 200 on the other side, so it's outside my triangle. Go this way, 250. And then we want the shortest distance to get back. So the shortest distance there would be a nice straight line, right? So if we think about it, that right triangle is our hypotenuse. So if we square the two sides and add them together, that's your formula you've seen of a squared plus b squared is equal to c squared, where c squared is just that hypotenuse. So I'm just going to call it h squared equal to c squared, so that matters. So I have 250 squared plus 200, and then there's the other way to type that as well. If your calculator doesn't have that squared key like I used here, this means the same thing. And then we need the square root of that number. We can see our answer at 320.2 if we round. Okay, so it looks like all we have left is the quadratics. So let me scroll around a bit here to find where I started those. Again, this is the kind of last huge higher level math concept here. So again, there's an abundance of videos on these as well here. Where did these start? I think we were here. Okay, so I'm going to teach you a couple of different ways to solve these. There's, again, the videos are going to cover factoring, quadratic form, everything. So I'm just going to kind of pick the best method for each of these for solving. So I have this equation here. So again, those videos at the end, like I said, in terms of those, I think I got about 8 or so hours of those that I'm going to give you access to. Those kind of go through the actual notes, step by step, going through. At this point, I'm just kind of really trying to give you the kind of best method, I guess you could say, to get to the answers here. So this is a problem. I would use factoring. If you want to use quadratic formula, you'd get to the exact same thing. Key idea here is we're looking at the answer sets for y. So we're finding those answers there. So using the factoring method, I want to multiply to -8 and add to 2. So through some calculation, some guess and check, I could find +2 and -4. And setting each of these items equal to 0, so I get x is equal to -2, and then y is equal to +4. Sorry. So again, we're looking for y. Oh, whoops. My bad. I actually threw those in there backwards. So this should be, sorry, let me just redo that for you. We want them to add to a +2. So this would be my negative, and this would be my positive there. So I'd have x -2 and then x +4. So when I set both of those equal to 0 and solve, I get x is equal to 2 and x is equal to -4 to get our correct answer. Okay, so let's see if we can use factoring here. So factoring is set equal to 0, so I could try factoring this. Let's say I want to get to -30. Okay. So if we factored this one, and again, basically to factor, solve, you need to set equal to 0, so we're good there. It's the same thing as basically saying y is equal to if it was 0. If it was a number here, I'd want to subtract or add it over again, getting it equal to 0. So if we go ahead and set up our factoring here, so multiplying at -30, bottom I have 13. Through some guessing and checking, we get 15/2. And then again, at the video at the end, when I go through the factoring, it really kind of hones in on this, where we use this little shortcut method here, dividing both sides by that value of a. So that gives me x plus, oh sorry, and then this would also be a -2 there, sorry. So adding to that +13. So I'd have x plus 15 over -3, and then x minus 2 over -3. So first thing we simplify, right? So this would give me x minus 5 when I simplify there. And then over here I'd have x plus 2 over 3. So since we can't simplify that one, we're actually just good there, right? So if I want to go ahead and solve these, so I'd add 5 here, so I get this one is equal to 5, so it's kind of simple there. For this one, we'd subtract 2/3 from each side, so I'd get x is equal to -2/3. So those would be my two answers. Okay, so we want to rewrite here in standard form. So standard form for a quadratic is ax squared plus bx plus c is equal to 0. So let's do some expanding first. I'm just going to rewrite this. So let's multiply out first. And again, to get being equal to 0 here, I want to move that negative x squared over, so I'm going to add it. So it's like adding a 1 x squared, and I'm going to combine it with my like term. We're good there. Alright, solving. So, to solve these, if we can factor first, that's always going to be great. So again, we want to solve, we want to get it set equal to 0. So I'm going to subtract x over first. Then I'm going to subtract 12 over. And again, I highly encourage you, the more time you spend on that factoring video, it will save you some time. Factoring is quick if you get good at it. If not, we'll see quadratic formula later on. Is a method that works for all of these types of quadratics. So quadratic just means just squared variable is the highest term. So with our factoring here, if you factor correctly, you'll end up with this. And then if we set each of these terms equal to 0, we'll end up with x is equal to 4 and then negative 3. So that's where we're getting the answer from there. Okay, finding the roots. So it doesn't look like a quadratic, so let's make it look like one. So if I distribute it first here, that should be a 3 there, sorry. Let's see, can there's factor. So I want to get to 24. Okay, so I can't think of those factors off the top of my head, so let's go ahead and solve this using the quadratic formula. And if you Google memorizing this thing, there's 1,000 different songs out there. I'm sure when you were in high school they had you memorize it. I don't know why. If it were up to me, we would just Google it, but I'm not the one proctoring this exam. So let's go ahead and plug in here. And again, the video kind of goes through this in much more detail towards the end. So at this point, I'm just going to kind of make sure you have the work so you could reference it. Alright, so step 1, as I've referenced in that video, is we type in this whole portion in the calculator here without the square root. So, let's go ahead and do that. Okay, so you're at 121. As I mentioned at about 12, always check those square roots, see if they come out to a whole number. A lot of times they will. If they don't, again, we'll see in the examples here as well as in the extension videos. But this one does, it comes out to just 11, so that kind of saves us some time. So you have 5 plus or minus 11 over 12. Okay, so this plus or minus, the way it splits up is here's where my two answers come from. So I have to simplify 5 plus 11 over 12. And then 5 minus 11 over 12. So here, that gives me 16 over 12, which reduces to 4 over 3. And then here, I'd get negative 6 over 12, which reduces to negative 1/2. So those would be our answers there. As we can see, where did I cross myself? Oh, that was supposed to be a opposite of B. So opposite of positive 5 is negative 5. So that'll actually switch things around. So this will be negative 16, and this would be positive 6. Sorry, I'm crossing myself up here. So that's going to be negative 4 over 3, and this will be positive 1, which makes more sense now than I did, right? Good catch there, my bad. Okay, completing the square. So again, video references here for this bit. But as we complete the squares, probably one of those topics that may be one question in this exam, so I wouldn't stress too much over it. Oh, so that blank number here that we're finding is going to be the b, so the thing with the x, divided by 2 squared. So if I take negative 6 over 2 and square it, so that gives me negative 3, and then negative 3 squared is 9. So if I add 9 into both portions here, what we're looking at is going to be, just kind of setting that up there. So going ahead and solving. Whoops, and one thing I forgot to do here. So when we think about this, we want to think about adding and subtracting the number, this the b over 2 squared there, because that way we're not changing the equation. So since I'm adding it here, I actually want to go ahead and subtract it there. So this portion here, we have 8 minus 9, so that gives us a minus 1. And then if we go ahead and factor this, we'll find that these are both negative 3. So that would be x minus 3 times x minus 3. Which again, if you look back in that video, we talked about how we have the exact same thing here. We basically can just rewrite that in this form. Just saying that term squared minus 1. And again, the factoring videos kind of covered that as well as the complete square there. I wouldn't worry too much about that problem. Like I said, there might be 1 on there. Okay, so some more quadratic formula here. So we see we're already in our form of ax squared plus bx plus c, so I can go right into my formula. So I'm just going to go ahead and start simplifying. So again, typing just this into the calculator without the square root, just as it looks. So it would be 9 plus 8. And that's actually as simple as we're going to get that one. Because I checked the square root of 17, it doesn't break down, it's also a prime number. And I see that I match up with an option, so we're good to go there with the multiple choice. Okay, finding the roots, that's the same thing as saying find the zeros. So we can see here that we're already in that form. Or the y or the 0 by itself. So my a here would be negative 1, b is negative 7, and then c is negative 2. You could try factoring this, you're going to see you're not going to be able to. So that's when you go to quadratic formula. Again, make sure since that b is negative 7, we're inside of those parentheses there. As again, if you kind of I don't want to say reverse order the video, but again, if you get stuck on one of these questions, definitely go scroll through the end of this video. That's where that's 8 hours of video resources there that kind of cover any topic that you're going to see on this exam. But if you're feeling comfortable from doing these examples, then I guess that's just extra resources for you there. Okay, so 7. Alright, simplifying, we have 49 minus 8, so I get 41 over a negative 2. 41's not going to break down, we can check it, but it's prime, doesn't simplify. And again, we had a nice multiple choice option already, so we're good to go there. Okay, factoring. Alright, so we got 2x squared minus 8x plus 6. So as always with factoring, we're going to check for a common factor. So it's something that divides all the numbers. So they don't have an x in common because 6 is missing one. But these numbers all are divisible by 2. So if I factor out my 2, it's dividing each of these terms by 2. And this one, obviously. And then we can go ahead and try to factor, right? So factoring this up here. So 1, so it's 3. Through some checking, we'll find -1 and -3. And we're good to go there. Okay, vertex form. That's basically a fancy way of saying complete the square, so I guess there is 2 of these there that want you to do that. So, alright, so with this one, a little more complicated because we don't have a 1 in front of that x squared. So what we're going to do first is try to factor out that GCF. So we're going to factor out that 3. I'm going to throw that plus blank in there to get our terms, right? I got a minus 18, and then when I do the minus the blank here, so kind of how we talked about subtracting things, whatever that blank is, since I'm pulling out a 3 here, I want to multiply whatever I get there by 3. Okay, so finding that number, so here's my b, right? Oops, sorry. Since I factored out that 3, this would actually be a 2 now. Sorry about that, because I did divide it by 3, right? Okay, so here I would have 2 divided by 2, or -2 divided by 2 squared. So we get 1, so just 1. So for our simplified form here, 3, and then with some factoring here, we get x minus 1 squared, so similar to how we did above there. And then simplifying this side of it, we'd have -18 minus 3 to get negative. Again, I believe you were saying that it wasn't again, we're just looking to pass this exam, so again, like the whole completing the square, the vertex form, I wouldn't stress too much on those concepts. So we got 3 of those overall. When you see there's a lot of other questions that have much more bulk than this. Okay, so finding that value. So we want to rewrite this portion. Shows a 1 out front, right? So I'm just trying to do b over 2 squared. So if I had that b there, sorry, it would be 12. That's going to give me 36, right? So on this other side, if I want to add it over here, I got to subtract it over here. So again, adding it on both sides, whatever we do on one side, we got to do on the other. So over here, I'd get plus 37. Oops, sorry. This isn't there, so that should just be y plus 1. The reason why it is y plus 1 in this one is they're just saying to find that c. So since we're solving for that missing value, we don't actually need to do it on both sides. So again, when we factor this out, I'd find that I would get, multiplying the 36, adding the 12, we'd get 6 and 6. So if we rewrote that, we could, since they're the same, it would just be x plus 6 squared. I'd subtract that 1 over it, and end up with x plus 6 squared minus 1. Alright, solve it again here. So for this one, if we do our checking with factoring, right, so we're going to multiply 12, add the 7. We can go ahead and check there and get 4 and 3. And then solving each of these terms, so it's that each one equal to 0. Subtracting 4, subtracting 3, we get our answer. That one, right there, good there. Okay, let's go ahead and solve this one. Let's get x squared minus 25 is equal to x plus 5. Okay, so when we have squares mixed into equations like this, we want to get it set equal to 0. So first I would subtract x from both sides. I have nothing to combine it with, so I'm going to go ahead and write in that typical order of x squared, x, and then our constant. Then I would subtract 5 from both sides. So I get x squared minus x minus 30 is equal to 0. Now, as we go ahead and solve, okay, so we could factor this one. So I get negative 6 and positive 5. We get 6 and negative 5, and we can see in our multiple choice, they didn't actually give us any of those other options, so it would just be 6 and then negative 5 there. So just 6, since they didn't give us that other one as an option. Okay, here we have x squared minus 9 is equal to 0. Since this one's missing the x term, you can kind of just shortcut this, so I can just add 9 to both sides, and then take the square root here. So when we take the square root of a number, we actually get the positive and negative. That's just kind of the rule of a square root. If you did the square root of 9 in your calculator, you get 3. So it'd be 3 and negative 3. So I did that one, I did this one. Okay, there we go. So let me rewrite this a bit. Okay, so when it comes to simplifying, we need to factor. So again, definitely practice with that factoring. So if I factor this portion on the top, I would get x minus 3, x plus 2. The bottom here, if we're going to go ahead and factor this, we get x plus 2 and x minus 1. Since we have the same term in top and bottom, I can cancel these terms as well as these terms. So my final answer would just be that x minus 3, because that's all that's left. Alright, let's do some factoring again. So again, definitely check out that factoring resource at the back. It'll save you a lot of time if we get good at that. I know this is your last math class. So let's go ahead here and factor out our common factors. That's always our first step. So on the top, these are all divisible by 3. So I could take out a 3, and that gives me x squared plus 8x. Okay. And the bottom, I could take out a 6, actually, I believe. So I get a 6 out there. Okay, and then if we want to go ahead and do our factoring, so on the top, and again, I'm abbreviating that work just because, again, I've included those extra video resources at the end where it kind of walks you through factoring in that step-by-step fashion. Okay, so things we can cancel. We see we have an x plus 3 on both, so those will go away. And then if I look at these leading terms here, so 3 over 6 is going to reduce to just 1/2. And we don't need to write that 1 out front because we're just multiplying, but let's see what we got. So we got x plus 5, then an x minus 2 on the bottom. Now, I'm not seeing that as an answer, so what they want us to do is to distribute. So if I distribute that 1 here, it's just going to be x plus 5, and on the bottom I'd have 2x minus 4. So that's where they're getting that answer from. So just a reminder, factoring this top term here, since there's no x term, it's like I have a 0 there. So as we factor that top, we'll end up with x minus 3, x plus 3. And then we see our x minus 3's will cancel. So that x plus 3 is all that's left on the top. Good there. Good there. Let's simplify another one of these. So we got x minus 5, x plus 5 on the top. And then again, we go ahead and factor this similar to the other one with that 0x in the middle. So this one here, we see a cancellation with our negatives as well as our positives. So since everything cancels, it's just like having 1 left over. Nothing on the top, nothing on the bottom, so that just gives us a 1. Alright. Okay, so simplifying again. So if we factor that top part there, we see our cancellation again. So my answer would just be that x plus 2 over x plus 5. Okay, and some more complicated solving coming up here. So let's go ahead and rewrite this a bit. Okay, so first thing I'm going to suggest you do whenever you have kind of single terms with more complicated terms is try and factor if you can. If you go ahead and check here, you'll actually see that you can factor this bottom term here. Okay, so if we want to work with fractions, we need to make all the denominators the same here. So just like anytime we add or subtract a fraction. See, this is my most complicated one. So I have an x minus 5, but I'm missing the plus 4. So I'm going to go ahead and put that plus 4 here on the top and bottom. So if you add something to the bottom of the fraction, you have to do it to the top as well. This one has the plus 4, but I'm missing the minus 5. So I'm going to go ahead and include that minus 5 on both the top and bottom. Now that we have the same exact denominator among every single one of our fractions here, we can actually just get rid of all of those fractions. So now this problem turns into 3x plus 4 plus 7x minus 5 is equal to 2x plus 9. And now we can just distribute and solve. So this first term would get me here. So combining my like terms on the left side. Alright, so it'd be negative 25. Okay. Alright, so from top to bottom there. And if I go ahead and subtract this over, I'd get 8x. If I add this over here, I'd get 32. And then if that's adding the 23 and then subtracting 2x, then dividing, we get x is equal to 4. So that's going to be our only answer there. Okay, multiplying the expressions. So first thing, let's do any type of factoring we can to see if we get any cancellation. So we multiply fractions, we go across. So let's see if I could factor this one. I know that that's going to be x minus 2 and x plus 1. And if I multiply, just add that term in basically. So before we expand anything, let's see if we can get there. On the bottom, if I factor this portion here, and then factoring that one. So again, there is some definite advantages here to getting good at factoring, which hopefully that extended video will help with. So for my cancellations, let's see, I have an x minus 2 and an x minus 2. I have an x plus 2 and an x plus 2. So that gives me an x plus 1 over x plus 3 and x plus 4. So they don't have that as an answer, so I do need to expand. So like we talked about earlier, multiplying. So I'm going to keep that x plus 1 over here on the top. So x times x is x squared plus 4x. Then doing this to both. And if I just combine those like terms, right? So I'd get x squared, 4 and 3 gives me a 7x plus 12. So there's our answer there. Alright, dividing, so remember that means multiply the reciprocal. So this is the same thing as saying x minus 4 over x minus 6 times, we do the reciprocal here. Alright, so let's get into our attempts at factoring, right? So on the top here I have my x minus 4 term. And if I factor this portion here, let's see, there we go. On the bottom, right, so I got that x minus 6 I'm bringing down from here. And if I factor here, canceling, so I have a minus 4 and minus 4, and minus 2 and minus 2. So we get our final answer of x minus 3 over x minus 6. Alright, let's do some adding here. Okay, so things we talked about here, we got to make a common denominator. So this has an x plus 2, it doesn't have an x minus 2. So I'm going to multiply the top and bottom of this fraction by x minus 2. Over here we have a plus 2, this one doesn't. So I'm going to put that plus 2 top and bottom. So I'm just going to kind of simplify that. So I have 4x minus 2. Here in my bottom. The order doesn't matter as long as you're multiplying. Again, order doesn't matter when multiplying. So 3 times 2 is the same as 2 times 3. Okay. So it looks like we need to simplify our bottom. So if I just kind of simplify one of these, right? So we multiply it out. I can find the bottom of my fraction is going to be x squared minus 4, and that's from just simplifying this, or this, they're the same. So when we add fractions, or subtract, I should say, the denominator stays the same once it's we get a common denominator. And if I expand the tops here, so I'd have 4x squared minus 8x plus, here I'd have x squared plus 2x plus 3x plus 6. And if we combine our like terms on the top, I'd have 4x squared, 5x squared. So I'm combining these two terms. And then I have minus 8 plus 3 plus 2 there. So I get minus 3x and just plus 6. We can get to our final answer there. As we see, they had. Alright, here, let's see what we got. So if we factor out this bit here, so again, always check if we can factor. I can see all I'm missing on that right side there is going to be that x minus 1 term. So if we kind of re-multiply out our bottom there, because as you'll see when you go through the problem, they don't actually offer that x plus 1, x minus 1. So if we multiply that back out, we'll get x squared minus 1. On the top, I have that 3x, and then it's a minus. So I want to distribute that to everything, so it would be negative 3x plus 3. These two terms, 3 minus 3 is 0, so my final answer would be 3 over x squared minus 1. Good on those. I believe that was it. Okay, so hopefully by this point these answers had helped you out as kind of that practice test mentality. And again, the key idea here is not only going to be able to be doing these problems, but the more time you spend on those additional review videos that I've included, I believe you'll feel much more well-versed in all the topics that this test could potentially cover. Again, basically those are just giant unit lesson videos type thing related to all these different topics you've identified for this course. I wish you the best of luck, and I enjoyed working with you and hope these results turn out just as you had hoped. Okay, so walking through the rest of these problems here, with the trig stuff, you're not going to need a whole lot of calculator things here. What I did was, I'm also going to send you over, I actually was able to find a PDF of the guide for your entire calculator, so showing all the different things. And towards the end here, I did highlight kind of those key calculations you brought up, variance, standard deviation, just because those tend to be a little more cumbersome by hand. When I originally teach them to my students, I show them that way, and needless to say, yeah, they all definitely prefer the calculator for those. So here, the one thing I want to talk about with the right triangles, and again, the additional video at the end will go much more in depth, but this is just meant to kind of summarize here, is with the idea of SOHCAHTOA. So it's a numeric, or a mnemonic device, I should say, to help you kind of memorize these relationships. So, that's sine is equal to opposite over hypotenuse, cosine, adjacent over hypotenuse, and then tan, opposite over adjacent. So what I do when I label these, in any right triangle, the hypotenuse h is always located. If you take the right angle and you draw an arrow across, that's where you'll find the hypotenuse. From the angle, no matter where they put this sigma at, if you draw an arrow directly across from it, that's your O, your opposite side, and then what's left over is adjacent. So that's kind of how we work through it here. For this one, converting from degrees to radians, you can see here my kind of shorthand on our formula. From go to degrees to radians, we take whatever that degree is, we divide it by 180. And again, I'm going to kind of highlight in your calculator those key ideas there of getting that reduced fraction. And then we put pi on top. So I did 45 over 180, reduced to 1 over 4, and then just threw pi on top of that fraction. This question, I can't imagine they're going to give it to you, honestly, without giving you the unit circle. So that's kind of how we see that answer there to get the 1/2. So it just kind of labels it. Of all things to study, this would probably be the least likely, I'd say, to spend a lot of time on. But I will still include things about the unit circle as well, just for your reference. This one, again, there's going to be a whole video that goes over this. So when we have the period is equal to 2 pi over b for sine and for cosine. Tangent's a little different, but again, the extension video at the end there will cover more of that. So what I did here is the parent function, or just in general how these look. To find that b, it's just whatever's in front of the x. So I plugged in b here. So 2 pi over 6, well, that reduces. The 2 over 6 again, we'll look at the calculator for that to get that pi over 3 or 1 pi over 3. When you're using a calculator, never type pi in there. Just always do 2 divided by 6 and then just put pi back on top. Similar to question 1 here, right? So cosine, that's just knowing that SOHCAHTOA, so it was a over h. And if you can label that, then we're good to go there. Another converting to radians, so reducing that 165 over 180 to 11 over 12, and then just put pi on top. And the videos offer a lot too of examples and practice problems with this in addition to what you've done here as well. Here, so if we go to radians to degrees, the short way to think of it is you remove pi, so just get rid of it, and then multiply your answer by 180. So I started with here, I removed the pi and multiplied by 180, so 2/3 of 180 gave me 120. And then I just subtracted that 45, like they said, to get to the 75 for the answer. Same thing here, that's SOHCAHTOA again. Having 3 of those in there makes me think that that's probably going to be a problem you'll see on there. So definitely something to do some practice with there, labeling your OA and H, and just using that mnemonic device of SOHCAHTOA to get your fractions. And then they're just dividing that in the calculator to get the 0.8 and 0.6. Alright, so for variance, standard deviation, and the range, I'm going to kind of slowly scroll through this part here. The key idea here, it looks like on your calculator, to get to these stat functions, so to save you a lot of time on those, we're going to go to 1, or the 1 var there. So we're going to go to start a statistical calculation, perform mode 3, so going mode 3 and then choosing 1 to get that single variable. And all of these are single variables because they're just lists of data. You didn't provide me that word to, so I'm guessing they're not going to test you on that. Typically that's in higher level statistics courses that we see that. So I'm guessing it's just going to be these single sets. So essentially mode 3, 1. When you input your data, all you're going to need is the X column. You won't need a Y column. It shouldn't show the Y column. If it does, don't put anything in there. So you're just dealing with the X. You'll type in your set of data. So just type in all these numbers here. And I'm going to kind of slowly scroll here so it tells you how to go through. And I'm going to send you the full PDF of this as well. I believe that these exact directions start on page 30 of that. I just wanted to screenshot them here for a reference. And then it kind of goes through and tells you which symbol means what. So your sample standard deviation, population standard deviation, mean, the number of items in there. And then in terms of getting the variance, what I would personally do is I would calculate the standard deviation and then just square it. So the variance is defined as the square. So let's say my standard deviation was 5. To find the variance, I would do 5 squared, or 5 times 5. So whatever you get for the sample standard deviation, you can just square it or multiply it by itself to get the variance. Okay, so these are going to be our video notes here for Unit 2. I'm going to start real slow here, kind of walking you guys through each step, and as the unit progresses, there's going to be a certain level of understanding that you've got down the basics. So this first assignment here, it's really, really important that we go ahead and you show every step of work and do every problem, because these things need to be down pat. First thing we get started with here, we're going to work on pretty much a good chunk of these questions together. So the ones that we're going to do are all those problems this year. Then you guys can look on your guys' timeline. Those are the ones you'll be finishing for practice. Okay, so our first one here. Key idea here, no matter what letter we're working with, X, Y, M, Z, we want to get it by itself. So here, to isolate M, or get it by itself, I need to move this 12 over. So we think opposites. The opposite of positive, negative. So I'm going to subtract 12 from each side. This is another unit where using your GeoGebra is going to give you a great advantage as a calculator here. So what I would type in GeoGebra is 10 minus 12, which would give me negative 2. Again, I'm not going to show the GeoGebra skills here, but we've gone through those as a class, and you've done them in previous units. And we got number 3. Actually, number 2 first. So here I want to get G by itself. Now again, I need to move what's with it, so I need to isolate. Think of the opposite. The opposite of negative 9 is a positive. So here I'd add 9 to each side. So in the calculator, negative 2 plus 9 would give me positive 7. Number 3, thinking opposites again. Here I want to get Y by itself. Well, the opposite of multiplying would be dividing. So key idea here is a negative 7, so I'm dividing both terms by negative 7. So, let's see where my keyboard's not working. There we go. So I want to do 91 divided by 7. And there. So we find 13. So our answer here, negative divided by negative cancels, so I get positive 13. Again, you could type those negatives in there. Moving over here. Now, this is A divided by 9. Well, opposite of dividing by 9 would be multiplying by it. So I'm going to multiply both sides by 9. And we get A is negative 36. So those are what's known as one-step equations. You've most likely seen those before, so again, not going to spend a whole lot of time there. Now, these next two. You've learned probably a variety of ways to solve these, but I'm just going to walk you through what I would consider to be one of the more simple ways. So, notice we're down to multiplying by a fraction and just a number here. Whenever you get to this step, we're going to use what's called the reciprocal. So the reciprocal means I just flip the fraction over. So instead of trying to type in divide it by 2/3, what we're going to multiply on the side is by the reciprocal. So the reciprocal of 2 over 3 is 3 over 2. So these cancel one another out. Here in our calculator you will find the answer is going to be 15. Here, same concept. The only thing is I got a negative this time. So now, instead of just 5 over 6, it's negative 5 over 6. But we're still using the reciprocal. This will give me k is equal to negative 10. Alright, moving on. So a couple more steps. These I'll actually do one more with you guys, one of the easier ones here. Let's do number 10. So, key idea here, we want to add or subtract first, and then multiply or divide. It just makes the work a little cleaner. So, to move my negative 5 over, I would add it to both sides, which would give me 2x is equal to 11 plus 5 gives me 16. Then I would divide. So with these, you just want to make sure you do your adding or subtracting first. Similar here, number 12. So this is my multiplying. So the opposite of a positive is a negative 7. So I'd have negative 3x is equal to 27. Wait. Yeah, 27. Sorry about that, guys. So from here, divide both sides by negative 3. And get x is negative 9. Alright, let's check on these last two here before we start practicing. Here, again, so I got some dividing going on here, so I'm going to go ahead and add my 7 first. Remember, we always do our adding or subtracting first, so I get x over 2 is equal to 16. Then multiply 2 on both sides. X is equal to 32. Last one here, we're going to go ahead and mix in that reciprocal 2. Now again, that's multiplying, so I'm still going to do my subtraction or my addition first. Then, using the reciprocal, we get x is equal to 10. Your guys' practice for this would be to finish the rest of number 1 here, so all the rest of the problems on this page. Moving on from there, we're going to go ahead on to number 2. Alright, so this one we're going to work through the whole thing together, and then your practice is going to be to do number 3. So again, once we finish these notes, you're here on number 3, and you'll be doing that one on your own. Alright, so we have Elvira, the cafeteria manager, has just received a shipment of new lunch trays with the school logo on them. She managed to unload 4 cartons of trays when students start arriving for lunch, and she has to stop unloading. She starts with all the trays in the pizza line. But, after 24 students have passed through the pizza line, she decides to divide up the remaining trays equally between the pizza, salad, and sandwich lines. The 3 lines now have 12 trays each. So we know Elvira now wants to know how many trays were in each carton. Use all of the actions taken to help Elvira answer this question. Explain how you arrived at your solution and be prepared to share your explanation. Okay, so working our way through this problem, we know that she starts off with 4 cartons. So that's the total number of things we're working with. And we want to know how many were in each carton. So if I call cartons my x, the total number of trays I have could be represented as 4x. Because it's 4 times, so 4 cartons times however many trays were in each carton. Now, if we start looking about how she hands these trays out, she's had them all in a pile originally, and 24 students got through. So I know I got something like 24 trays. Now, after they pass the line, she decides to divide the remaining trays equally between the pizza, salad, and sandwich lines. The 3 lines now have 12 each. So thinking about how many trays I have, I got 12 in one, 12 in the other, and 12 in that 3rd line. So the total number of trays she has, if we add these numbers up, 24 plus 12 plus 12 plus 12, tells me I got 60 trays. Now, if I want to figure out how many in each carton, by setting these two terms equal to one another, we would just divide, and I'd find my x, or the number of trays in each carton, is just 15. That's one way to solve this problem. So that's kind of our whole thing there. So what I want you guys to work on now is going on to 3, and let's go ahead and work through these. So, again, work through it, get your answer, write the equation. Now, I want you guys to work through these as well. So you're not only going to solve these, and don't worry so much about the justification here for these. I'm not too concerned with that. Just make sure you show each step on an individual line so we can make sure you're doing those correctly. Once you've done with that, we're going to move on to number 4. Now, we're going to be working on problems 1 through 5 together. You guys are doing numbers 6 through 10 for your homework. Alright, so, kind of our steps. We're going to assign a variable to the unknown. So what we're trying to find. We're going to write an equation and then solve it. Starting with number 1 here. If you bought a magazine for $3 and 4 books, you paid a total of $27. How much you spent on each book? So x, what we don't know, we're looking for how many books. So, on the cost of each book. So let's think about my two sides here. Well, I know I spent $27, so that's my total. I know I spent $3 on that magazine. I don't know how much a book was, but I knew I had bought 4 of them. So that gives me my 4x, plus 3 gives me my total. Solving. Divide each side by 4, and I'd find out x, or the number, or how much each book cost, was $6. We have Randall takes his bike into a shop to be repaired. They worked on his bike for 5 hours and charged him $12.50 for parts. The total bill was $75.25. How much did the shop charge him per hour? So kind of same setup here. We're going to go with x is the hourly cost. Now, we know they worked 5 hours, so that's 5x. And they added in that charge of $12.50 for parts. And then my total, you'll notice that total kind of always gets its own side here, was that $75.25. So if we work through this again, subtracting let's see here. So go ahead now. Big suggestion when you have anything involving decimals is make sure you check your work in a calculator. So we get 62.75. We divide each side by 5. And it gives me x is equal to $12.55. So that's how much they're charging per hour. So for this one, we have the 7th grade is ordering t-shirts. They pay $175 for the printer to make the design. After that, they pay $9 per shirt. If they have $697 total to spend, how many can they order? So again, our total gets its own side of $697. Our variable here is the number of shirts we could buy, because that's what we're finding. So our x is always what it is we're finding. It's usually a number of things or a cost. And let's see. I know I had to pay that $175 for the printer, so that's like a one-time thing. And then 9 per shirt. So solving. And dividing. Here we'll find x, our number of shirts, is 58. Number 4, Brianna spent half her weekly allowance on clothes. To earn more money, her parents paid her $8 to weed the garden. How much was Brianna's weekly allowance if she ended with 12? Now, we're trying to figure out x is what her allowance is. So let's work through this one in words. Okay, so I start off with x money. I spent half. Well, that's like dividing it by 2. If I spent a third, it would be dividing by 3. So again, we're dividing by 2 because we're cutting it in half. To earn more money, they paid her 8, so they give me 8 back. And I end with 12. So here, subtract 8, multiply by 2, and we find out she gets $8 a week in allowance. Here, Robert sold half his comic books and bought 14 more. Now he has 32. How many comic books did he start with? So X, number of comics. So again, these half ones, starting off with X comics. Cutting it in half, and then adding on 14 more. That gives me 32 at the end. So same kind of logic here, we're going to subtract. Let's see, 18. And multiply by 2. And we'll find out, we start off there with 36 comics. At this point, go ahead and finish up this next chunk of problems, so 6 through 10. Alright, so once we've finished up here, we're going to go ahead on to number 5 here. I'm going to be doing problems numbers 1 through 4 with you, and then for your homework, you guys are going to finish numbers 5 through 8. Alright, so multi-step equations. What we're going to think about here is we got to combine some terms, we got to distribute. So, look at number 1. On the left side here, what I want you to do when you work with these longer equations is think about drawing a line down. Right through that equal sign. If I'm on the same side, I can combine. If I go across that line, I got to do the opposite. So if I'm looking at this left side, I notice I have 2 terms here that have a number and an x. Those are like terms because they have the same variable. When I'm on the same side of the line, I don't change the sign. So 9x minus 7x, or 9 plus negative 7x, whichever way you want to think of it. Combining those gives me a positive 2x. So in the calculator, just do 9 minus 7, or 9 plus negative 7. My next ones. Well, this positive 1, this negative 5, those are just numbers. Those are constants. So I'm on the same side of the line, you just combine. So 1 minus 5 gives me negative 4. I didn't do anything with this negative 20, so I'm just going to bring it down. Now, we're hopping across the line, so that means I got to do the opposite. So just like we've talked about before, we add or subtract first. And then now I'm going to divide. Alright, number 2. Here we got parentheses, so we know we need to do some kind of distribution first. Distributing means the thing on the outside that's multiplied to it goes to everything on the inside. So for my first one, negative 7 times 3a. Well, I do negative 7 times 3, that's negative 21, and I keep my a. Then, negative 7 times negative 1 gives me a positive 7. Now we're going back across that line to solve here, so I'm doing the opposite. So minus 7. So 84 dividing by negative 21. We get a is negative 4. Alright, now things are cranking up a bit. So, we're going to go through this thing step by step. Draw our line. Alright, first thing we got to do, before we combine things, we always distribute first. So distribute, combine, and then we solve how we're used to. So first thing I'm going to do, notice it's a minus 5, so that's like having a negative 5. So I'm going to distribute that to both here. So I'm not doing anything with this 4m, so that's just going to kind of come down. We're not playing anything with it, we haven't moved it or added it, so leave it alone. Now negative 5 times positive 3m gives me negative 15m, or minus 15, however you want to think of it. Negative 5 times positive 10 gives me negative 50. Now we distribute it, now it's time to combine. So I'm on the same side of the line, and I have two like terms with my 4m and negative 15m. I'm on the same side, just combine. So 4 minus 15 in the calculator, negative 11m. I'm going to bring down that minus 50, still equal over here. Now that we've done that, we can go ahead and solve just how we've been doing. So opposite, because I'm going across the line. And if we divide, we will get our answer of m is equal to negative 16. Alright, here comes another one, a bit longer. So let's make sure we draw that line in. Alright, here we got to distribute twice. So the first one, pretty standard of what we've seen. Now, if we have a variable with nothing in front, it's like having a 1 there. So negative 3 times 1k, negative 3k. Negative 3 times negative 8, positive 24. Now for this second one, since it's minus and there's no number, that's like having a 1 in front. So it's negative 1 times k. So that'd be minus 1k. You don't have to write the 1 there, but it helps. And then that negative 1 times 5 would give me negative 5. Step 2, I got some like terms, same side of the line, just combine. So negative 3 and negative 1 gives me negative 4k. Positive 24 and negative 5 gives me plus 19. And now we're looking normal, nice two-stepper here, minus 19 from both sides. Divide by that negative 4, and I'll get k is just negative 1. From here, you want to use these notes, go ahead now and work on problems 5 through 8. The key idea here is make sure you show all your work. That's the easiest way for me to check, see where you went right, see where you went wrong. So again, make sure you're showing that work. Once you've completed that, we're going to move on to number 6. Alright, so here, we're going to work on problems 1, 4, 8, and 9 together. Alright, so what we're going to see here is we have variables on both sides now. So, it's nothing a whole lot different, just a little bit more work. So for 1, let's go ahead and throw our line in there. Alright, so I'm going through my steps here. I look on either side, nothing to distribute, no parentheses, so I'm good there. My left side, that's a variable, that's just a number, no like terms, same thing over here. So, now what I gotta do is get my variable on one side, numbers on the other. So when I say numbers, I'm talking about just those constant terms with no variable. Now, the way I would suggest you stick with it, just to make it that same kind of pattern, is always move the variable to the left. So I'm going to subtract here, do the opposite, minus 3y, because I'm going across the line. And notice, it can only go with something else with a variable. It can't go with just a number. It goes away. 5 minus 3 gives me 2y. I'm going to bring down that minus 8 and that positive 12. Haven't done anything with them yet. Now, this looks pretty normal to us. Our variable's been moved, so let's go ahead and bounce that 8 over there. Divide by our 2, and we get y is equal to 10. Now moving on to 4. Pretty similar looking, right? So, let's throw our line in. I check. No distribution. No combining. So, we can go ahead and solve. Now, some of you may want to move that negative 2u over, but again, I'm going to just move the variable to the left every time. So to move this over, I'm going across the line, so I do the opposite. So now I have 12 minus 11u equal to 45. Subtracting 12. Notice it's minus 11u, so I'm bringing down that negative. Lastly, dividing. U is going to be negative 3. Alright, so moving on to there, we're going to look at number 8. Alright, here's where things really get turned up a notch. So now I want to do these giant problems. But again, we're going to follow the same steps we've been following this whole time. So first, I'm going to draw my line. Okay. Let's see what we got to work with here. I'm just going to make this line a little bit longer. Alright. I got some distributing to do. I see my parentheses. So I'm just going to start on my left side. Okay, 2 times 4 gives me 8w. 2 times negative 1 minus 2. On this side, negative 10 times that 1w gives me negative 10w. Negative 10 times negative 3 plus 30. Didn't touch the 4. It's not in the parentheses, so I don't distribute to it. So it just comes down. So, at this point, we've distributed. Now I got to look to combine. Looking at my left side. Well, that's a variable. It's a constant. Can't combine those. So I'm just going to bring them down how they look. On my right side, I've only got one thing with a variable, but I do have these two constant terms that are just numbers. So same side of the line, just combine. So I got minus 10w. 30 plus 4 gives me 34. Now, similar to what we've seen before, I'm going to move my variable to the left. Nothing in my minus 2, nothing in my 34. Here, starting to look normal, right? Back to our gold here. We just divide after we add. So I'm going to do the opposite. Add it. 18w is equal to 36. And we're going to divide. And I'll end up with w is just 2. Alright, number 9 here. Drawing my line. Okay, so let's distribute, right? I see my parentheses, that's always coming first. So I got 9m minus 27. Notice I didn't do anything with the 3m because it's not in the parentheses. So we distribute it. Now I'm looking at each side of the line, trying to combine. Can't do anything over here. But over here, I have two like terms, those variables. Same side of the line, just combine. So I get 12m. Let's go ahead and move our variable to the left. Opposite of subtractions, adding. Divide. We'll end up with x is equal. At this point, I want you guys to work through the rest of the problems on this page. So your goal is to finish the rest of the problems on 6. Make sure you take your time and show all your work. Now we're moving on to number 7 here. Alright, so we're going to do A and B together, and then you guys' practice is going to involve solving numbers 1 through 4 at the bottom. So I'll do A and B, and you're working through these 4. So what this is kind of like a special case where we get some unique answers. So here, if we go ahead and solve, so let's get our line in there, right? Our distribution. Minus 2. Now, we're moving our variable to the left, right? So that's pretty much what we did in the last practice here. So I'll cancel over here. My negative 2 is going to come down. Bring down that minus 4. Now, negative 8 plus 8. That gives me 0x. Well, 0 times anything is just 0. So this term actually is going to cancel out. So what I'm left with is negative 4 is equal to negative 2. Is that a true statement? No. That's never true. So what this means is our answer is actually no solution. There's no number I could plug in for x to make this true. All we've done up to this point is equations with one solution. So we got x is equal to some number. Positive, negative, fraction, whatever. But if we get to a false statement, that's false, negative 4 is not equal to negative 2, we write no solution. over here. So throwing our line in. Nothing to change on this side. Distributing. Go and combine our like terms over here. So I got nothing on this side to combine. Here, same side of the line, we're just going to combine. So I'm going to go ahead and just write my number out front here. So 5 minus 8, that's -5. Let's move our variable over here. So I got plus 9x on both sides. And oh, here we go again. It's going to cancel out because it's -9 and +9. So now I get -5 is equal to -5. Well, that's definitely true. So when it's true, our other possible answer is infinite solutions, meaning no matter what I plug into x, these equations are different, just different versions of each other. So that gives me infinite solutions. At this point, you can read these summaries here typed in, as well as complete the next 4 problems. Alright, from here we're moving on to number 8. And we are going to work on numbers 1 through 9 together, and then you're going to finish 10 through 18. So we're not going to do these ones here at the bottom. So again, the homework here on your guys' sheet. Alright, so what these are called is literal equations. We pretty much just got a lot of different variables, but we're going to treat it just like we would if they're numbers. So it's saying solve for w. That means we're going to get w by itself. Well, let's see here. I want to get just w, and I have L times w. 2 letters next to it mean multiply. So to get w, I'm going to divide by L on each side. So here, A over L is equal to w. That's a nice one step there. We only needed one step to get w by itself. So that would be my answer. Just going to box that in. Number 2, I want to get h by itself. Same thing here. Opposite of multiplying is dividing, so I'm going to divide by b on both sides. So I get a over b is equal to h. That's my goal. Solving for h means isolate it. It's by itself. Here, solving for t. Same thing. Let's just divide by r on both sides. And t is isolated. We're done. Now, cranking it up a notch. We want to get t by itself. Well, I see 3 letters. Even though there's 3, it's still just multiplying. So here I'm going to divide by both p and r. I can divide by 2 things at once, right? Goes away, goes away. T equals I divided by PR. Solving for h. So, same thing as before, 2 letters. Let's divide by them both at once, save ourselves some time. V over LW equals h. Alright, getting r by itself. Now pi, even though it's like a letter, it's still just a number. So I'm going to divide by it, and by that too. Canceling over here. So I get r equals c over 2 pi. Solve for c. Okay, well, this is a Greek letter, but we're going to treat it just like any other number. Opposite of subtracting it, add it. Now, one thing you'll notice, since these are different variables, I can't combine them. So this just looks like m plus our mystery variable is equal to c. Moving on to 8. Want to get pi by itself? Well, I would divide then by that r squared. So a over r squared equals pi. Getting m by itself, I want to move that v over. Opposite dividing is multiplying. So I have v times d is equal to m. We're going to do a few more of these together. Let's find some of these tougher looking ones. Let's see a good one here. Alright, let's do 19 and 20 as more examples, just to see something a little more challenging. Okay, so for this one I want to get f by itself. Well, first thing is I want to move this thing out front. So I can either distribute it, but I'm just going to move it at once. So using the reciprocal, I'm going to multiply both sides by 9 over 5. Just like we've seen before. That'll cancel out my fraction. So now what I have is 9 over 5 times c equals f minus 32. Opposite of subtracting 32, let's add it. This has a variable, this doesn't, so that's just 9 over 5c plus 32 equals f. Moving on here. I want to get b1 by itself. Well, same thing, let's get rid of this fraction, so we'll use the reciprocal, so that's 2 over 1. Oh, crossed out the wrong thing. This goes away, because we're canceling it out with our reciprocal. So I get 2 over 1 times a is equal to h b1 plus b2. Well, let's get rid of that h there, so let's divide both sides by it. So here I'd have 2 over 1 times a over h. b1 plus b2. Finally, what was our goal? We want to get b1 by itself, so I'm going to subtract b2. So writing this whole giant thing out, I have 2 over 1 times a over h minus b2 equals b1. That's about as hard as these problems can get. So take your time, work opposites, we're good to go. At this point, again, you'll be working on the rest of the problems on this page. When you complete it, move on to notes 9. Alright, so number 9, we're going to work through a good chunk of this together. And then what you guys are going to do is go ahead and move on to the next ones. This stuff up here we have already kind of done, so we're going to skip over it for now. Again, if you want more examples of that, go ahead and go back to number 8. Alright. So, how much time would it take for the sound of thunder to travel 1,500 meters if sound travels at a rate or a speed of 330 meters per second? The formula we're looking for that they give us here is velocity is equal to distance divided by time. Now, we're looking for how much time, so we're looking for t, and we're given this. So let's go ahead and solve this for t. Let's add multiply by t on both sides. So I get t times v equals d. And I want to get t by itself because that's what I'm looking for. So I'm going to divide by v. Distance over velocity. Plugging in here. We want to figure out how long it takes for to go 1,500 meters. So 1,500 is my distance. 330 is my speed. Calculator, we get t is equal to 4.5, and if we round, 5. So rounding to 2 decimals is going to be good for us. Alright, I have a parachute on a racing dragster opens and changes the speed of a car from 85 meters a second to 45 meters a second in a period of 4.5 seconds. What is the acceleration? Okay, so we're still looking for acceleration, A. We're given our v final, what we started at, and the time. We know all these. So this is our final, because it says we went to that. This is my initial, and this is my time here. So this one we can just plug in. So if we go ahead and solve that. If you're typing this in GeoGebra all at once, whenever you have a fraction with a bunch of terms, put parentheses around the top and the bottom. That'll make it a bit easier. My answer, A equals negative 8.8, and if we round, 9. On to our next one. If I put $1,500 in my savings account, earn $180 of interest at 4% simple interest, how was my money in the bank? How long? Okay, so we're looking for how long. That means we're looking for t. Now, we want to get it by itself, right? So I have I is equal to PRT. I want to get t by itself. We're just going to divide. So I get t is equal to I divided by PR. Now, let's go ahead and work through this. So, P is my amount borrowed. It's called the principal. It's how much I'm starting there. It's what I'm putting in. So, this represents my P, my principal. I earned 180. That's my interest. My rate, well, if I'm going up by 4%, just like we've seen in a previous unit, that's 1.04. So plugging in, again, put those parentheses on top and bottom because we have a multiple term fraction here. Calculator or GeoGebra. Oops, a little bit of a mistake here. This, I meant to say, we're just going to convert to a decimal, so it's 0.04. So here, this would be 0.04. Then in the GeoGebra, the calculator with those parentheses, we'll get a time of 3 years. Again, this last chunk here, this is stuff we've kind of done before. So, you can look back at the previous notes for that. At this point, once you've completed these notes, you're working on number 10. So, here we're going to go ahead and work through everything. So you'll be completing, let's go ahead and A, B, C, we'll do this A, and 3, A and B. So you can skip over those challenge problems. Alright, these are your practices, so you can go and complete all problems here, and then move on to number 11. Alright, 11 is going into inequalities. So they're similar to equations, just with this one little step here. So, now we have open circles and closed circles. We're not going to talk about those, you can read over them now, but it works better with examples. Alright, so first I'm going to solve this thing. I'm going to treat it just like an equal sign. So I would distribute, keep it facing the same way, and subtract, and divide. Now, we're dividing by a positive number here. Since it's positive, this doesn't change. So I end up with x greater than negative 9. What that looks like on a graph, let's just label our middle one, whatever our answer is. Going to the left, we're subtracting 1 each time. Going to the right, we're adding 1. Now, what these mean is if it's an or equals to, so it has the line underneath, we get a closed circle. So we'd fill it in. Since it does not have it, it's an open circle. So if I want x greater than negative 9, that means I want the things that are bigger than it. Well, bigger numbers go to the right. So I'm going to go ahead and shade to the right. Interval notation. That means you're going to kind of define the numbers you can take. Now, it says I want numbers bigger than negative 9. So I know that that's my smallest thing. Since it's not an or equals to, we use a parenthesis here to say we can go up to negative 9, but it doesn't work in our answer. Comma. Well, I'm going on forever to the right, so it goes to positive infinity. Number 2. Let's distribute first. Combine, right? So 1x minus 3x is negative 2x. I'm going to add my 6. Now, Here, if we multiply or divide in our last step by a negative, it has a unique property. It flips the inequality. So now I have x, flip it, less than negative 5. That, again, only happens in the very last step when we multiply or divide by a negative number. So I'm going to put my negative 5 in the middle, go down 1 each time to the left, up 1 each time to the right. So adding 1 to the right, subtracting 1 to the left. Now, it's not nor equals to, so it gets an open circle. This time I want x is less than negative 5. Well, that means less than to the left. So, less than means left. Greater than, we shade to the right. Interval notation here. Well, okay, negative 5 is my biggest thing this time. It's not included because it's not or equal to. And since I'm going all the way to the left, it means I go up to negative infinity. Here. So let's go ahead and distribute again. Combine these two. Now I'm dividing by a positive, so I leave that inequality just the same. Alright, so now we got our middle number, right, that negative 2. And it's an or equal to, so this one's a filled in circle. And I want numbers less than it, so that's less than to the left. And those again are our numbers on the bottom there. So here, we got negative 2 is our biggest thing. Now this time it's a filled in circle, so it gets one of these brackets. That means it's an answer. Then we're going to the left, so my lower is negative infinity. Here, distributing. Combining. So same side of the line, just combine. Now, I'm dividing by a negative, so what happens? That's right, my sign flips. So, x greater than or equal to 4, so 4, or equal to, so it's a filled in dot. Put numbers to each side. I want greater than, well, greater than numbers are to the right. So this time, 4 is our lower number. And it's included. And since I'm going to the right forever, it goes off to infinity. Alright, let's jump to these. We'll just do this last one. So we'll do number 10 together. And what you guys can do is go ahead and finish the rest of these for a portion of your practice. Alright, so let's go through this one. Let's distribute. So there's a negative out front. That's like having a negative 1. Now we can combine. So I'm going to combine my like terms here. Same side of the line, just combine. Here, I don't have any other x's, but I do have two numbers. Now, moving our variable to the left. Now notice, when I add a negative, doesn't matter. It's only when we divide or multiply by 1. Now I am dividing by 1 though. So I divide by negative 1. Let's flip that sign. So on x is less than negative 9. It's not nor equals to, so open circle. We want the numbers less than it, so less is left. In our interval, let's see, I'm maxing out at negative 9. It's not included. I'm going to the left, so it shoots the negative infinity. At this point, again, I would suggest finishing all of these problems here. as well as those here on 12. And for 12, you'll notice in the bottom right corner there is an answer key. Alright, moving on, taking a look here at 13. We're going to do problems 1 and 2 together, and then you guys will work through the rest. Alright, so here we're working with sales tax. So we have Leon paid $26.50 for a shirt with a sales tax of 6%. He doesn't remember the price without tax. Fill in the dotted blanks with the correct operation to complete the verbal model. So, to figure this out, what we're going to do is the price of the shirt in dollars times 6% plus the price of the shirt again equals our total amount paid. So we're going to say X, our unknown quantity, is the price of the shirt, because that's what we don't know, and it's in dollars. So let's see, we have X times, well, 6% is a decimal, 0.06, plus X again, equals our amount paid. Well, he paid $26.50. So remember, if we have just a number, it's like a 1 out front. So here I'd have 0.06x plus 1x combining. If we go ahead and divide here, we find out x is 25. So the original cost of that shirt was $25. Now, very, very similar problem, right? Now we have the cost of Illini football season tickets is, before tax, $199. Tax rate is this. How much will I pay? So again, we're going to multiply by our percent. Add the original, it's equal to the total. So if I let my amount paid here, because we're seeing, so X now is the amount paid, because that's what it's asking us to find. And it's again in dollars. So it says we're going to pay $199, so let's see. This is a decimal. Plus our original price equals a number. We have all numbers here, so let's just go ahead and type that and calculate just how it looks. I'll find out after tax, I'm going to pay $214, and if we round, about 42 cents. So real quick, before you guys finish this one, we'll just walk through it a bit. So, here, again, our formula, let's go with our original times the tax plus original equals the total. Same kind of thing here, times plus. But, if it's discounted, should we be adding or subtracting? What we could do here, though, to make this one a bit easier, let's take our total and take away that discount. So use that formula here. So a discounted rate would be original minus our tax times original equal to the total cost. You guys should be able to work through these. And again, these formulas here, very easily written down on a note card when you guys test. This is going to be our last set of notes here, and then you guys will be moving on to 15 for some practice and the review. Alright, so take a moment, read through this description up here. So that there is how a banking statement or a loan works. I is going to be our interest. That's how much we'd get back at the end, or how much we'd owe, depending on if we're investing or if it's taking a loan. P is the principal. Think of it as how much you start with. R is the rate. It's usually expressed as a percentage. T is the time, and we're going to stick with years. Alright, so let's start with our formula. I is equal to PRT. Find the interest. So we're solving for I. 3,000 is my principal. The rate, so it's a decimal, and 1 year. So our interest here, $165. Find the principal amount I started with. Let's start with I equals PRT again. And if I want to find the principal, I'm finding P. We learned how to solve earlier, so let's simplify. Let's get that P by itself. So now I have I divided by RT is equal to P. So if I plug in here, I have P equals my I, 640, divided by, remember we got a big fraction, let's use some parentheses. 4% is a decimal, times 2. So our P here, 8,000. Okay, now we have find the interest earned. So interest earned, that's I'm finding. So let's plug in what we know here. Okay, I don't know what I is, I'm finding. In my principal, I'm putting in 4,200. That is a decimal. Then my rate, 5 years. So our interest, 1,312.5. With these notes, go on ahead and move on to 15. You'll be completing this. Afterwards, complete your review once you've checked it and signed in with me. Your last assignment for Unit 2 is to go ahead and pass that Unit 2 exam. Alright, so these are going to be our notes for Unit 6. The idea here is we're working with graphing. We're going to start off with solely linear equations, and towards the end touch a little bit on inequalities. Alright, so notes 1, going to do a good chunk of this together. So our first concept is talking about slope. Slope is known as the constant rate of change between points on the line. The idea here, it's known as variable m. For some reason we just go with that, so again you'll see me use that for slope. Type of slope, if we read, just like when we read books, we always go from left to right. So going left to right here looks like I'm going up. This is what's known as positive. If I'm going down from left to right, negative. A flat line, that's not going up or down. So that's what's known as having a slope, or an m, equal to 0. And here, vertically, that's what's known as an undefined slope. So equations that have positive and negative slope look something like y equals mx plus b. So that's for both of these. If we have a slope of 0, we just have y is equal to some number, positive or negative. And if we have an undefined slope, these are that special case where we have x equals some number, positive or negative. Alright, so given a graph, we're going to go ahead and do a few of these to count out some slope. Alright, so taking a look at number 1. Visually, we see that from left to right, our line is going up. So I know it's a positive number. Now, when we're counting slope, we always start at the point on the left. So here's the 2 points they gave us. This one's on the left. So when I count my slope, which is defined as rise over run, we're going to start always on the left. So here it looks like I'm moving up 1, 2, 3, 4, 5, 6, 7. So my slope, I went up, so it's positive 7. Now how far did I go to the right? 1, 2, 3, 4. Now, you could check in GeoGebra to see if that's your good slope. So again, that's something we went over. That's that fraction text command. There I would just do the fraction text, 7 divided by 4, and it's going to spit back out that 7 divided by 4 because that doesn't reduce. We always want to check if our slope's reduced, but in this case it doesn't. Number 2, if I'm looking from left to right, my line's going down. So I know this one should be a negative slope. So looking at my 2 points, I'm starting at the left. Now this time, to go from the point on the left to the right, it looks like I'm going to go down first. Since I got to go down, I know it's negative. Let's say I go down 1, 2, 3, so it's negative 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if we check this one in GeoGebra, we'll find out it reduces to negative 1 over 3. When we're working with slope, we will only write fractions. There are no decimals with slope. So, make sure you're leaving everything in fraction form. Looking at number 3 here. So here's the line we're given. Now, right off the bat, I see this as a horizontal line. So, anytime we have a horizontal line like that with no slope, we know our slope is 0, because we're not going up or down at all to get to the next point. Here, we have a vertical line. So, I'm just going to keep going up, but I don't go over at all. That's where we say M is undefined. Definitely items that, how to count the slopes here being that 0 and undefined, those are note card items. The rest of these will be left up to you as practice. Now let's take a look down here. Now, sometimes we aren't given a graph. And rather than graph everything out by hand and count, we can also use a formula. So the formula we're going to use, y1 minus y2 over x1 minus x2. You may have seen this formula written the other way. I just prefer doing it this way as I think it's a little bit easier to work with. Alright, so here we have x1, y1, x2, y2. So using our formula, let's see, we have the y's on top. The y always has to go on top. That's just how we count it because y deals with the rise, the up and down. So y1 minus y2, well, let's see, that's 1 minus 3 over x1 minus x2. Now, this is something, if you type it in GeoGebra, so if we use this, so if I wanted to do this thing all at once, and again, this is totally a note card item, here's the answer we should get. So we should end up with negative 2 over negative 3, which will reduce to 2 over 3. Now, if you're someone who's not particularly strong at reducing those fractions, here's how you could type it in GeoGebra. And again, totally a note card item. So we're going to use that fraction text command. And then in here, I'm going to type it just how it looks. So 1 minus 3 in parentheses, divided by 1 minus 4 in parentheses. Doing that, it'll actually go ahead and simplify for you. Let's take a look at number 3 here. We had some negatives. Alright, so using my same type of formula here. So I have y1 minus y2, so 5 minus, remember, anytime we have a negative, it gets its own set of parentheses, just like in previous units. Divided by x1 minus x2. So negative gets its own set, negative gets its own set. Typing into GeoGebra with all of those parentheses. So our fraction text. So here, I'm going to go ahead and use a different color just to kind of show you exactly how this whole bit looks in the separate part of the command. So notice all those parentheses I wrote. I just type it into GeoGebra. It's going to do it for me to make sure I don't make any mistakes. So this is what we would type into GeoGebra. And our answer here, we would get 10 over 4, which would reduce to 5 over 2. So try that now. GeoGebra will also tell you if you get an undefined slope or a slope of 0. So the rest of these problems on this page are part of your guys' practice. So at this time, go ahead and complete the rest of these problems now. Once you've done that, move on to 2. You know what? We can go ahead and skip 2. So, on your timeline, it says all problems on notes 1. I do want you guys to make sure you finish all those, but you don't need to worry about completing 2 at all. So once you complete with 1, you guys can go ahead and move on to 3. Alright, so on to notes 3 here. So we're going to do a good bit of this together. Alright, so now we're looking at slope of a line and describing the graph here. We're looking at from a table and graph. So, when we're given a table, we can kind of use any points because a line is constant, so it doesn't matter which points I look at. So I'm going to use, let's say these ones. I'm going to use this and this. So these are the ordered pairs, negative 168, 140, and 14, 10. So setting up my slope, subtracting y1 from y2, that's 140 minus 10 over negative 168 minus 14. So again, bigger numbers, definitely check it in the calculator. Or GeoGebra, obviously. So our fraction here we'll get is negative 5 over 7. Describing that slope? Well, it's negative, so on a graph, it would look like it was decreasing, or going down from left to right. Let's go ahead and take a look at this graph. Now, the key idea here is we want to pick good points. So what I would say by good points is, let's look here. This point, it's on the line, but can I really tell exactly what numbers that's at? Not really. But if I look here, it's kind of crossing at those grid lines. So I could easily say that the coordinates at that point are 1, 20. Probably not the best one. No, but here's a good one. It's at 2, 40. So using those points to find the slope, let's see, y minus y over x minus x. Here we get a nice whole number of 20, or 20 over 1. Either way, writing that answer is fine. It's positive, so this is definitely an increasing slope. Alright, from there, you guys have completed 3. So let's jump on to 4. So, the key words here is what the thing we're looking for. You're going to find slope for each of these using any 2 points you like. And then you're going to tell me, is it increasing, decreasing, so that's positive, this is negative. Horizontal means the slope is 0, and vertical means our slope is undefined. So, you're completing each of these, as well as identifying that. Once you've completed that, head on to 5 for some more notes. Alright, so looking at some of our applications here of slope. The big idea concept is we're going to construct a linear equation and graph those linear equations. So, we're actually going to go ahead and take a look here. We're going to skip over some of these. So, let's see. Let's go ahead and jump down here. Alright, so we're going to zoom in a bit so we can kind of read easier. So here we're given a graph. And what we want to do is go ahead and read this story that goes along with it. And I'm going to go ahead and label the graph with various parts of the story, kind of bringing that picture to the question in hand. So Tommy starts his errands by driving at a constant pace to pick up his brother from school. Well, what that means is I'm going from here, right? So here's my starting point. So we talked about in the previous unit. We always start, our x-axis represents like our home base. So here is where I'm going to go pick up brother. So this part of the line is picking up brother. He makes his first stop where he picks up his brother from school. So stopping means we have a horizontal line, right? A slope of 0. So this is a stop. Let's see here. Tommy drives half of a mile for 1 minute, but has to stop at a traffic light. So here he's driving again. And then we see that stopping point up here. This is the stoplight. Tommy and his brother drive home. He stops at home for a total of 4 minutes. So again, we're decreasing. So this is going home. And we're on the x-axis, so we're at home and we're not moving. So here we're just home hanging out. After Tommy returns home, he decides to go to the library to return a book. Tommy drives back home because he realized he forgot the book. So now we're going farther away. So this is to the library. And here, we're going home again because he ended up forgetting that book. So that's taking this paragraph and associating it with various parts of our graph. Now, some other things we can get from this graph. The speed. A scalar quantity that refers to how fast an object is moving. It is not direction aware. So this is the distance traveled divided by how long it took. So that's the velocity. Or that's the speed we're going. So speed has no negative or positive. Velocity, it's the rate at which moving, or the rate at which an object changes its position. This is direction aware. So we're going to use slope to find velocity. So delta, this nifty little symbol in here. So if we look here, we have delta position. That means our change in the distance. So we could think of distance final minus distance initial over time final. It's saying delta time minus time initial. This is the same equation as we've been using the whole time, just using some different letters. So we're still finding a variation of slope. So for question 1, I'm going to calculate the velocity of the car when Tommy began his errands. So that's here. So the 2 points I'm looking at are where he began and where he started his errands. So before he stopped. So those two coordinates are 0, 0. And, so this is 0, 0, this is, let's see. Looks like it's right in between 2 and 4, so it's at 3 and 1.5. So for the velocity here, or you can write it as m, either way is fine with me. Let's see, we have y minus y over x minus x. So, calculator, we end up with 1/2. So his velocity there is 1/2. So as the slope's going up, velocity is positive. If the slope is 0, what happens to velocity? Well, let's see. His first stop to pick up his brother. Well, that's from here to here. So now we're looking here to here. That's where he picked up his brother from. So we're using these points. So we have that 3, 1.5 now. And then 6, 1.5. So our velocity, or again our slope here, y minus y over x minus x. Here we'll get 0. So if the slope is 0, velocity is also 0. And he turns around to go back home after he forgot his book. Well, that's the last part of our graph here. So these would be the points 30, 0, and 26, 2. So, calculating our slope here. Here, simple GeoGebra, little calculator, we're going to end up with negative 1 half. So, as the slope goes down, the velocity here is negative. Alright, little adjustment to your guys' practice here. This is the problem you're going to complete for homework. So, when you complete that, that'll have completed all the problems here on 5, and I'm actually going to let you guys skip over 6. So we'll be skipping 6, but you do need to complete that problem on 5. So we're completing this last problem here is homework. Once you've done that, we'll move on to 7 for some more notes. Alright, up until this point, most of the stuff we've covered in here should be stuff you've seen before. Now, this might be a little bit new to you, so make sure you take some very detailed notes in this section. First thing we're going to start off is our two forms of linear equations. We have slope-intercept and standard form. Let's start with slope-intercept. Here is our y equals mx plus b. M stands for the slope. B is what's known as the y-intercept. So, here, we're given what those things are. So, y equals something x. Y equals something x. That's going to be kind of your generic setup. Y and x are just variables. So, if my slope is 2, that means my m is 2. My y-intercept, my b is negative 1, so it's minus 1. My m here, negative 3 over 5. My b, my slope is positive 4, so it's going to be plus 4. So following that same pattern, let's go ahead and fill out the rest of these. So m is always the thing that's going first. Then m also goes with our variable, so that m is always multiplied to our x. Then for our b's, those are our y-intercepts. So here it's a positive 2, so it's plus 2. Positive 7 plus 7. Here it's 0. Now you don't necessarily have to put the plus 0 at the end, but I don't mind if you do, just so it's doing the same thing. Here our y-intercept is negative 3, so instead of plus 3, I throw a minus 3 in there. Alright, now, standard form, tad bit different. This looks like ax plus by is equal to c. And this one, x and y are variables, a, b, and c are just numbers. But it's kind of hard to graph in this. So what we like to do is rewrite it. So the goal in each of these, to get into slope-intercept, to make graphing easier, is we're going to get y by itself. So here's my y. So the first thing I do in every one of these examples is move my x. Well, I want to get x over here. The opposite of positive would be negative. So I'm going to subtract 2x from both sides. I'm going to bring my y down. Well, these cancel. Now, these are not like terms, because this has an x and this doesn't. So I can just write it. We're always going to put that m, or our variable term, first. So negative 2x, that's a positive 3, so plus 3. For that one, we're done. Y is already by itself. Moving on to number 2. Okay, still, move my x first, so I'm going to subtract 4x because it's positive, so that's the opposite. Now I have a 5y, and it's plus, so it's a positive. Negative 4x, this is negative 30, so it's minus 30. Now, I can't have anything in front of my y when I graph using point-slope form. So I'm going to divide everything now by 5. Those go away, so I have y equals negative 4 over 5. Check with your calculator, check with GeoGebra. It doesn't reduce. So it just stays negative 4 over 5x. Here, negative 30 divided by 5, checking it does reduce. That's just minus 6. So that would be our final answer there. Here, same thing, move my x first. So if there's just a letter or just a variable, it's like having a 1 in front. So here I'm going to subtract 1x from both sides. Now it's minus 3y, so that means I'm bringing down a negative 3y. And again, positive 12, so plus 12. Now I got to divide everything by that negative 3 to get just y. Calculator, we find out that's 1 over 3. 12 divided by negative 3 is minus 4. Looking at number 4, subtracting my 1x here again, bringing down my negative y. Now, trick here, you got to make sure it's just y. So to get rid of that negative, it's like having a negative 1. I'm going to divide everything by negative 1. To get my final answer. From here, we'll just do these last two real quick as a quick reference. Now I'm going to go ahead and leave it as saying plus 0. You don't need to, but again, it's not going to hurt anything. So there's our answer there, and again, the plus 0 is optional at the end. And for our last example, set of notes. There we go. So, once you've worked through these notes, you should have a pretty good understanding of the difference in the forms. What I want you to do is go on to 8. Here, you'll be completing all of these problems. Once you've done that, we're going to move on to 9 for some more notes. Alright, so taking a look here at number 9 for some notes. Here we're going to start graphing. So the key idea is we need it in slope-intercept form to graph. We plot the y-intercept, our b, and we use the slope to get our next set of points. Alright, taking a look here at number 1. Alright, y is already by itself here, so I'm in slope-intercept form. So if I look here, my b is the thing at the end. It's just the number, and it's positive 3, so b is just 3. My m is what's out in front of the x. Well, here it's just a negative, so it's like having a negative 1. Now, anytime you have a whole number, we're always going to think of it as being over 1. So even if it's a negative number, we always put it over 1. So first thing I do is I plot my b. It's positive. B always goes on our y-axis. So it's positive 3, so 1, 2, 3. Now, to get my slope, well, negative means I go down. So from b, you have to start where you plotted b. The negative on top tells me to go down. So let's think about this. For our m, if we have our fractions here, so on the bottom, positive means to the right. Negative means to the left. On the top, positive means up. Negative means down. So this means down 1, right 1. So down 1, right 1. Down 1, right 1. Down 1, right 1. You want to try and get a few of those points on there. It just makes your line look a bit neater. Now, in some of these graphs, you may be only to fit one other point. That's fine, but if you can fit more than one, I would suggest doing it. Let's take a look here at number 2. So here my b, it's minus 4, so it's going to be negative 4. My slope, it's 3, and it's a whole number, so I'm going to put it over 1. So first I plot b, that's at negative 4, so on the y-axis, 1, 2, 3, 4, so it's negative 4. Now it's 3 over 1, so positive means up, positive means right. So I'm going to go up 3, right 1. 1, 2, 3, 1. 1, 2, 3, 1. So I can get another one even. 1, 2, 3, 1. And again, you may not always be able to fit that many points, but the more the better. Let's see here. Let's go ahead and do one more of these up here. Let's try 8. So we'll do all 3 of these together. First, let's start with 7. Okay, so here, my b, -4, my m, there's nothing out front, so it's just like having 1 over 1. So I start at -4, so 1, 2, 3, 4, so -4 because I went down. And then my slope, up 1 over 1. Up 1 over 1, up 1 over 1. Here, our b is +3. My m, whenever you have a negative out front, always just put it with the top number. So -1 over 4. Again, that negative does not go with both. So if you have a negative, just put it with the top number. So our b, +1, 2, 3. Now my slope, down 1, right 4. So down 1, right 1, 2, 3, 4. Now here, I see I can't fit it. So we're going to talk about a special case where we do the opposite. To get another point. We always want to get at least 3 points on these graphs. So the opposite of going down 1, right 4. So the way I can get a point in the opposite direction but still having that same line would be doing the opposite of this slope. So instead of down 1, I'm going to go up 1. And instead of right 4, I'm going to go left 4. So up 1, left 1, 2, 3, 4. You'll notice it still gives me that same line. So using the opposite is something you'll have to do to get those more points. Now, if we go to this y equals here, notice I don't have something I'm adding. So that's like adding 0. So here, b is just 0. My slope, 4 over 1. So my b, 0 on the y-axis means here. So up 1, 2, 3, 4 over 1. And let's go ahead and use that opposite again to get another point. So here I went up 4, right 1. So the opposite of that, well, the opposite of up is down 4. And the opposite of going right would be left 1. So now down 1, 2, 3, 4, left 1. So again, whenever you're graphing, you want to get at least 3 points. Sometimes you might not need to, but a lot of times you're going to have to use that opposite. So make sure you're comfortable with it. Definitely a note card item. We'll do 2 more of these together. So we'll do 14 and 15 together as well. So first thing we're going to notice here is that these are not in slope-intercept form. I can tell that because y is not by itself. So, just like in the last set of practice notes, let's get it by itself. So I'd subtract 4x from both sides. Don't need to write the plus, it's just positive. Divide everything by 3. And I get y equals -4 over 3, because that doesn't reduce, plus 4. So that means my m is -4 over 3, my b, 4. So let's plot our b, 2, 3, 4. And then my slope, well, this means negative on top, I'm going to go down 4, positive on the bottom, right 3. So 1, 2, 3, 4, 1, 2, 3. If I want to get another point, well, it's not going to be perfect, but we can go ahead and estimate 1 to the right here. Down 1, 2, 3, 4, right 1, 2, kind of out there. So again, if your graph's not big enough, you can estimate that third point. Alright, on to here. So for this one, I'm going to subtract 2x from both sides again. I got -4y is equal to -2x plus 8. Dividing by my -4. So, my b, -2. My m, 1 over 2. So let's plot that -2. Now this means I'm going up 1, right 2. So up 1, right 1, 2. up 1, right 2. Let's go ahead and use the opposite as well here. So the opposite of going up and right would be down 1, left 2. So down 1, left 2. Down 1, left 2. And we get a great line there. From that, what you're going to go ahead and do here is complete the rest of the problems on 9. So take your time, work through them all, and when you've done that, we're going to move on to number 10 for some more practice. Okay, so on number 10 here, we're going to do numbers 1 through 4 together. Alright, so to write an equation in slope-intercept form, y equals mx plus b, all we need to find is our slope m and our y-intercept b. So let's go ahead and take a look at these graphs. Now I'm given 2 points here, so I can use those to get my slope. Just like in our first set of here, we're always starting at the point on the left. So from the left, I'd go up 1, 2, 3. So my slope is positive 3 because I'm going up over. Well, I just go right 1, so it's also positive. My b represents where I cross the x-axis, or the y-axis. So this is the y-axis, and it looks like I'm crossing right here. So that's at the point negative 1, 2, 3. So it's negative 3. So my equation, y equals m, or you could just put 3 there, either way is fine. X, it's negative 3, so minus 3. For number 2, looking at our slope, so again they gave us 2 points, so I'm counting from the point on the left to the point on the right. I'm going down, so it's negative 1, 2, 3, over 1, 2. 1, 2. So it's negative 3 over 2. B is where we're crossing the y-axis. It's right here again. So it's at positive 1, 2. So my equation, m, x, and it's a positive b, so plus 2. Now here we don't have our setup, but we still know we need to find m and b. So for each of these problems, your first step is to identify m and b. Looking at the 2 points they gave us here. So from left to right, I'm going up, so I know it's going to be a positive slope, so up 1, 2. So let's go to the side here. Going up 2, and then I go right 1, 2, 3, 4, 5. I check. 2 over 5 doesn't reduce. So I'm good there. That's my slope. My b is where it's crossing the y-axis, which is here. That's at 1, 2, so it's positive 2. So my equation, y equals 2 over 5x plus 2. Moving on to 4. Again, we go from left to right. So it looks like I'm going down, so I know my slope's negative. Down 1, 2, 3, so it's negative 3. I go over 1, so over 1. My b, where it's crossing here, is at positive 1. And again, here you could just write negative 3 as well, but if you want to keep it over 1, that's totally fine with me. What you're working on now is completing the rest of these problems. So get your slope, get your b. Let's not worry about 13 and 14. So just work through 12. Once you're done with that, you've completed section 10. You'll be moving on to 11 for some more notes. Alright, so for 11 here, we're going to complete a good chunk of these together, and then you guys will be completing some for practice. Okay, so special cases. These are vertical and horizontal lines. So if a vertical line is written in the form x equals a, where x is just a number, it's where it crosses the x-axis. Horizontal is y equals a, so kind of like we referenced earlier. Vertical is x equals some number, horizontal, y equals some number. Here our slope is undefined, here our slope is just 0. Alright, so first thing, this is a vertical line, it's going up and down. This horizontal, it's a flat line, it's going left and right. So vertical means I got x equal. Horizontal, I know I have y equal. If we look, this line goes through the point, well, negative 1, negative 2. So this is x is equal to negative 2. Here, it's going through the point 1, 2, 3. So this is y equals positive 3. For these ones, horizontal, that's y equals, vertical, x equals. So this one will be going through negative 1, 2, 3, 4, 5. So this is y equals negative 5. Here it's going through positive 1, 2, 3, 4. So this is x equals positive 4. Again, this is just one of those things with practice, you'll get down path. So 5 and 6 will be left as practice problems. 5 does not have a very good line in here, so let's go ahead and make it this line. So for 5, go ahead and use this red line here. Alright, we'll graph 2 of these as well. So graphing y equals, well, y equals, that means I'm horizontal. X equals means I'm vertical. So if I go through y equals negative 5, it's horizontal, that means I get this line here. Vertical, x is negative 1, so I'm at x is negative 1, and it's a vertical line, so it's going straight up and down. The rest of these problems are left as practice. So go ahead, and we're going to work through all of these here. Once you've completed that, you can move on to 12, which you'll complete for homework. Notice this is a bit of a review, so ignore the directions here. You are just completing this on your own. So, once you've done with this, you can move on to 13 for some more notes. Alright, we're actually going to skip around a bit here just to kind of make this unit go a tad bit quicker for you guys. So we're actually going to skip 13 altogether. So let's not worry about that. 14, we're going to do, but we're going to make some adjustments. We're actually going to skip 15 and 16 too. So let's go ahead and make sure we know we're skipping these. And for 14, we're going to make it a little different. Okay. So, we're going to ignore these directions. Everything we're going to do is going to be slope-intercept. So for these examples, we're going to be given some information. So we're given our slopes. We know our m. We know a pair, an ordered pair on the line, in x comma y. So what we don't know is our b. So let's start off with our equation y equals mx plus b. Well, I know what x and y are. They're giving me an example of them. I know what m is. So let's go ahead and plug all that information in. So my y is 1, m is 2, x is 4. We don't know b. So to solve this, I'm going to multiply these numbers first. So that gives me 1 is equal to 8 plus b. To get b by itself, I'm going to move that positive 8 over, so I'm going to subtract it. So I find negative 7 is b. So my final answer, y equals m is 2, so 2x minus 7. Here, for 2, we have our x, our y, and our m. So starting with y equals mx plus b, let's plug in. Y is 4. M here is 1/2. Our x is 2. And we don't know b. So multiplying these two first, that gives me 1. Subtracting it from both sides tells me that 3 is my b. So my equation in slope-intercept form, y equals m x, and it's positive 3, so plus 3. I want you guys to do 3, 4, 5, and 6. So pause the video at this time and go ahead and work through those problems. It's doing the same thing as the first two examples we just did. Once you've completed that, we're going to move on down here. So again, we're just going to start with our y equals mx plus b. So we'll do 2 together, and then 9, 10, 11, and 12 will be left as practice. So, first thing we're going to do here for 7a is we're going to find the slope. So here we're not told what the slope is. So we know to write in y equals mx plus b, we need the slope. So step 1, we're going to find our slope. So just like before, it's y minus y, so y1 minus y2. So 7 minus negative 1 over, x1 minus x2. Again, giving my negatives their own set of parentheses. Here, we'll find our slope is -2, or -2/1. Now that I've found my slope, I'm going to go ahead and do it for the second example too, because that's our step 1 for both of these. I'm just going to try to color coordinate a bit here. So the red exemplifies our step 1. So, in both of those, you should have found those slopes. Now, step 2, I'm going to do in blue. Now, just like in those previous examples, now we have a slope and some points that it goes through. So we're going to go back to y equals mx plus b. Again, that second piece of information besides the slope that we could need to find is just our b. So you can use either one of these points. I just use the one where the numbers look smaller. That's just me. So here 1 is smaller than 3 and so on and so forth. So I'm going to use this one. You could use the other one. You'll get the same answers. So now I have my x and my y. And I have my m. So I'm going to plug in. Y is -1. M, -2. X is 1. I don't know b. So solving just how we did above. Here it's -2, so I'm going to add it to both sides. So 1 is my b. So my final answer, y equals m, -2x, +1, so +1. For 8, we can again use either point. Well, 3 and 4 look smaller than 6 and 7. So here's my x and my y. So I'd have -4 is equal to m, which is 1/3, times x, which is 3, plus b. So my final answer, y equals m, x. It's -5 for my b, so I'm 5. At this point, you're going to complete the rest of the problems on notes 14. As I mentioned earlier, we're actually going to go ahead and skip 15 and 16. Also, if you take a look at the study guide, I kind of crossed out some stuff here at the bottom. So we won't be doing anything with standard form or inequalities, just to kind of make this test shorter. And you'll see there's also an answer key at the bottom here to check your work as well. So, once you've completed the Unit 6 review and checked in with me, your last assignment for Unit 6 is to pass that Unit 6 exam. Alright, so these are going to be our section of notes here and practice problems for Unit 7. The focus here is going to be linear model. Alright. First set of notes here, we're going to work through about this first page together. And you guys can complete the second part as practice. So reminder, slope-intercept looks like y equals mx plus b. So the key idea is understanding how much each variable represents or what it represents. For b, this is like a one-time cost or an initial cost. M, we're going to see the word per. So this might be per hour, per item we buy. The key idea is per means it's multiple times, so that's always our slope. X, our independent variable, is like a number of items. Or it's the thing we're counting, how many times we're doing it. Y, we're going to think of as like a final cost, or like the outcome dependent upon the X variable. Alright, so first step here, let's jump in number 1. You and your friends plan to attend the county fair this weekend. The admission to the fair is $5, and the cost per ride is 50 cents. Let's go ahead and see what we know from that sentence. So, I paid $5 for admission. I'm going one time, so that's a one-time cost. That's going to be my B. The cost per ride, 50 cents. I see the word per, So that means my M there is 0.50 for that 50 cents. So we can get our equation from just these two pieces of information. So it'd be y equals 0.50x plus 5. In our last sentences here, your parents gave you $20. Write and solve a linear equation about how many rides you can go on. So y we talked about being a total or like a final cost. So to solve, this means I'm given $20 for my y, and x is the number of rides I can go on, because it's 50 cents per ride. So solving, so the two things I'd like highlighted in this answer here are our equation, as well as our final answer, so I can go on 30 rides. Take a second and read through number 2. Okay, so, second sentence, the ranger charged $6.50 per hour. So I see the word per, I know that's my M. And then a $25 deposit. That's a one-time cost. So our equation now the solving. You wish to rent the canoe from 12 to 3:30, or 12:30 to 3:30. Write and solve to see the total cost. So I'm solving for the total cost. That means I'm solving for y. Here, from 12 to 3, this represents 3 hours. So if I plug it in, I'm plugging in for my x. Our answer? So to rent that canoe for 3 hours, it's going to cost us $44.50. Take a second now and read through number 3. Alright, so here we got our initial value, or how much we paid for that car. So that's like my upfront cost. Now, it's going to depreciate. Well, depreciate means go down. So here my slope, so it's saying per year, is going to be negative 3,000. So our equation, y equals negative 3,000x plus that upfront or initial cost. And again, it's negative this time because it's going down. It's depreciating. Now for solving, we want to figure out how many years. So x is my number of years because it's that per year. So until we're worth this much. So that's my worth, and it's equal to my equation. We're going to solve for x. So here we got our equation. We find out that in about 7.5 years, that's when the value of the car is going to be $3,135. Take a second now, read problem 4. So we're buying a car wash at the gas station for 5. So that's a one-time cost. It's our B. In each gallon, per gallon, the cost, so that's my M, 310. So for our equation, we're here. Now, I have $40. And I want to figure out how many gallons I can get. So X is my gallons, because that's a cost per gallon for X. So I have 40 equals so here, we can buy about 11.29 if we round gallons. The rest of these problems will be left to you to solve. So you're working on numbers 5, 6, 7, 8. Once you've completed those, we're going to go ahead on to notes 2. Okay, now we have the standard form word problems. So standard form, ax plus by equals some number c. So a, b, and c are just constant terms. They're numbers. Alright, x and y are variables. So for number 1, Sam ordered 2 tacos and 3 enchiladas for lunch at the restaurant. His bill was $7.80. If enchiladas were $2 each, write and solve a linear equation to find the cost of each taco. So here, first thing we need to do in these problems is we're going to define our x and y. So, in each of these problems, you're going to be given like 2 different things you're talking about. Now, let's think here what we have. So it looks like we're talking about tacos and enchiladas. So we're going to have x be, since we know how many we bought, the cost of tacos, and here, the cost of enchiladas. So let's say I bought 2 tacos, so that's 2x, 3 enchiladas, 3y. It says I spent a total of $7.80, so C here represents like our total cost, or total profit. Now, they're giving us another piece of information. Enchiladas were $2 each. We said Y was the cost of my enchiladas. So now I can plug in. And at this point, we're down to 1 variable, so we can solve. So, it looks like tacos were about 90 cents each. Take a minute now, read number 2, and try and figure out what the 2 things we're talking about are, our x and our y. So we have tickets at a school play costs 4 in advance, 5 at the door. So this time we know the money, so x and y are the number of advance tickets and the number of tickets we buy at the door. So, our equation, there are 4 for each advance plus 5 for each at the door equals our total. We got 440. Now, it says if no tickets were sold in advance, let's find out how many are at the door. So no tickets, that means our x is 0. Solving, well, 4 times 0 is just 0. So it looks like 88 were sold at the door. Take a minute now and figure out your x and y for 3. You'll notice this information usually comes in the first or second sentence. So here, we find out her piggy bank has all dimes and quarters. So we'll have x be the number of dimes and y be the number of quarters. Again, you'll notice I'm just defining these in the order they come. Okay, so a dime, that's 10 cents. So it'd be 0.10 x plus quarters 25, so 0.25 y. Looks like we have a total of $11.40. Now, it says Karen has 36 quarters. Well, quarters is my y, so I'm going to plug that in. Solving. So it looks like we have 24 times. Take a minute now. Figure out what your x and y are going to be for number 4. So here we're selling solid gift wrap to earn money. Solid color gift wrap, 4 per roll. Printed gift wrap, 6. So let's call this our solid, and this our printed. So we have 4 per roll for that solid, so it's 4x, and 6 for the printed. Now, we earn a total of $2,340. Next, we got the band sells 340 rolls of the printed, so that's our y. So if we plug in, now we can solve for x. So it looks like we got 75 rolls that sell in color. For your practice, go ahead and complete the rest of the problems on this page. Once you've done that, we're going to move on to 3 for some more notes. Alright, now we're moving on to point slope word problems. So this is a formula you definitely want to write down on that note card. Alright, key ideas here. The information presented is going to be a little different. We're going to get an example scenario. So when we're given an example scenario, that's when we know we're going to use point slope form. So what I mean by that, let's look at number 1. So at Eagle Bay, it costs 10 per hour to rent a canoe. So I'm also going to be given a slope. So I know my slope here, or my M, is that $10 per hour. Nick and his friends rented a canoe for 3 hours and paid $45. So our example there, they're saying, here's an example of how this equation looks. For 3, it cost me $45. So when we're given this type of information, that's when we're going to use this point slope formula. Here, y and x are our variables. y1, x1 are this ordered pair we're getting. And m we're also going to be given as our slope. So here I have that equation. Now, what we're going to go ahead and do is we're going to need to solve. We're also told he rented this canoe for 8 hours, so that's going to be our x. So if we plug in simplifying our right side here, because those are all just going to be numbers. We arrive at our answer. Take a minute now and try to identify your slope in your example scenario in number 2. So here it's costing us 15 per hour. In my example scenario is for 9 hours, it was 195. So our equation now, we're going to figure out a linear equation to find the one-time fee for the trash compactor. So we're trying to get this to figure out what B would be. So if we want to find B, that means we need to get into slope-intercept form. So to do that, I need to get Y by itself. So first, I'm going to distribute on my right side. So 15 times x, and 15 times negative 9. Now to get y by itself, so that one-time fee is the b in my equation. So $60 is our one-time fee. So with these problems, we're going to be given something to plug in for x or y, or we can be asked to find, hey, what is that one-time fee? So that means find b. Number 3, a company offers premium cable for $39.95 per month, plus a one-time setup fee. So we know our M is 39.5. The total cost for the setup in 6 months of service was that. So again, here's my example. We're going to figure out the total cost for 2 years of service. So our equation so we want 2 years of service, so my x is 2. So simplifying that right side, we could just type it in the calculator or GeoGebra, just how it looks. So my cost there, 184.8. Our last example here. A home security company provides security systems for $5 per week, plus some initial cost. So my M, 5. We're going to get our example here for 12. It cost me $210. And again, it's saying, find the cost of the initial fee. So I want to figure out, just like in example 2, what's B? So let's start off with our point slope. And again, we're trying to find B, so we're not given us something to plug in. We just got to solve it and make it look like a slope-intercept one. So as you guys probably heard, my daughter was at the park and found a baseball, so she was super pumped. Back to our problem. So we're going to distribute here, so that gives me 5x minus 60. So we're in slope-intercept, so my b here is 270. So that is my initial cost. Once you've completed these, complete the rest of the problems here for your practice. Once you've done that, you can move on to 4 for some more notes. Alright, for 4, here, we kind of got 2 points. So we're given 2 example scenarios. So we're going to work through finding the slope, m, then we're going to find b. So, 25 minutes costs $7.25. 40 minutes costs $9.80. These problems, even though they're a bit more work, are pretty easy because they're skills we've already used. So finding my slope, the difference in the y's. Again, if you haven't memorized this formula yet, totally fine. Definitely a note card item. And again, if you go ahead and type this in GeoGebra, just how it looks with those parentheses. Here, we're going to find our slope. It is 0.17. For the word problems, we can go ahead and use decimals for our slope. Just round to 2 decimal points all the time. Now, I have my slope, so I need to find b. So this would be like part 1. Now part 2 would be taking either one of these points. So I'm just going to use the first one. So my x and my y are 25, 7.25. You can use the second one as well. And your m we just found is 0.17. So now if we plug in to our y equals mx plus b, we can solve for b. Multiplying these 2 terms first. And subtracting to isolate our b. We'll find here that b is equal to 3. So our equation, y equals m x plus b. We're not quite done yet. You'll notice it's asking us to say, write and solve a linear equation to find the cost for 1 hour. So my final step would just be plugging in 1 here for my x. Calculator, we find out that cost is $3.17. So the 2 answers would be our equation here and our answer here. What we're going to do now is go ahead and do one more example together. Okay, so getting our 2 points, we have 100 degrees Celsius and 212 Fahrenheit. Our next one, 0 Celsius, 32 Fahrenheit. So, step 1 again, let's go ahead and find our slope. Here we get a slope of 1.8. And again, for these problems, decimal slopes are fine. Step 2, let's go ahead and use this first point here again for my x and my y. And I know m is 1.8. So now I can plug in to find my b. And again, if you're feeling a little bit lost on solving these equations, the best place to go would be Unit 2. So now we've got our equation, y is equal to mx plus b. Now, it's saying it's going to be 25 degrees Celsius. Well, we wrote Celsius as our y's. Or I take that back, we wrote Fahrenheit as our y's because it was the second thing listed. So Celsius represents our x. So here I'm going to plug in that 1.8 for my Celsius of 25 and figure out what the Fahrenheit is. That gives me 77. So these would be the two answers we're looking at here. And again, to get which way you plug in, it's all about the order you wrote it. I write it in the order they give me. So Celsius, Fahrenheit. So Celsius is like my x, Fahrenheit's like my y. At this point, you guys can go ahead and finish up the rest of the problems on 4. Once you've done so, move on to 5 for some more notes. Alright, so 5 here is going to act as a review for us. What we're going to do is do this first page together. So you see I've already wrote in what each one is. And we're going to talk about how I know. So here, for 1, so it's kind of combining all 4 of the first sets of notes. So for our first one, we were buying $48 worth of 2 types. Anytime I get like 2 items I'm comparing, so 2 different types of cakes, seeds, 2 different types of cars, that's always going to be that standard form. I'm giving an X and a Y. So we have ryegrass lawn seed and fescue. And we know how much they each cost. So this represents the number of each. So from here, let's go ahead forward and work with our equation. So let's see, okay, so I have, it's 70 cents for each of my x's, and $1.15 for each of my y's, and I spent $48 total. From there, let's go ahead and move on a bit. So now, we know that we got 25 pounds of fescue, so that's my y's. So I can go ahead and plug in. Multiplying that 1.15 times 25. Subtracting. And dividing. So we get 27.5. So that would be our answer there. So 27.5 pounds. Number 2. Jeff is keeping track of his weight over several weeks. After 2 weeks, he weighs 194. After 6 weeks, he weighs 186. This looks like we're going to need to get to y equals mx plus b, but a shorter way is this is a 2 example problem. So, I got after 2 weeks, I'm 194. After 6 weeks, I'm 186. So again, since we weren't given a slope, there's no way I can go right to y equals mx plus b. So if we go ahead and start solving here, finding my slope, we find out our slope here is -2. Finding my b, so I'm just going to use that first point here for my x and my y. M is -2. And again, if you had used the second point, you'd arrive at the same answer. So B is 198. So for our equation, we got y equals mx plus b. After 12 weeks, well, that weeks we seem to put first as our x's. So I can go ahead and plug that in now. So that gives me 174. So these would be my answers here. Now this one, here's why we could see this one's kind of our easier one. So a landscape supply business charges 30 to deliver mulch. Well, that's a one-time fee. And the cost, 23 per cubic yard, so there's my M. Well, I already have that M and B, so I can write my equation very quickly. Now, 8 cubic yards, well, that cubic yard thing, that one with our X, because that's dealing with our slope, so I'm going to plug in 8 there. So our answer, y is equal to $214. For our last one here, if Karen used a birthday check her mother gave her to start a savings account, she plans to save $25 per month. So we got a per, so I know I got a slope. And then I have one example. So what that means is I'm in that point slope type form. So writing our equation, now we're going to write and solve when we're going to find the original check. So original is like starting. So what we need to do, we got to find what B is. So distributing over here. Adding to get y by itself, so I can identify B. So our B is that constant term in here, so our B, our original check, was for 50. At this point, go ahead and try the next set of problems. I would suggest identifying which type of problem each one is first. Once you've completed that, we're going to move on to 6 for some more notes. Alright, so we're looking at 6 for our first notes. Okay, so here we're working with some little linear modeling. So we're going to be given some example problems, and we're going to work through them together. So we're going to do the first 2 problems together, and the rest of these will be left as practice. Alright, so for our first one, real world application 1. So just some quick vocab here. X is always going to be our independent, Y is our dependent. So the independent is a change in your experiment that you can control, so that you're measuring against. Y, it's the outcome. It's what we're going to see, our independent effect. So you're visiting downtown Chicago and a taxi company charges a flat fee of $3 for using a taxi and 75 cents per mile. Let's look at our variables first. So the slope here is going to be that per hour cost. So that's 75 cents is going to be our per hour slope. The y-intercept is our flat fee of $3. So for our independent, that's our cost per mile. And our dependent is the flat fee. So here they want us to write an equation to find the cost C after m miles. So using the variables they give us, well, our cost depends upon how many miles. So it'd be 0.75 because that's my slope, plus that $3 flat fee. How much for 8 miles? Well, let's see. That's giving me my m. So, calculator. Or GeoGebra, again, type it just how it looks. We'll find out that that's going to be $9. Here they're giving us a cost, so it'd be 15 is equal to 0.75 m. And we're going to find how many miles we drove. So if we divide both sides here by 0.75, we'll get 16. Moving on to our next example. An airplane 30,000 feet above the ground begins descending. So it's going down. So that's a negative slope here. Feet per minute. Assume the plane continues at the same rate of descent. let's look at our variables. So m here is that negative 2,000. And what it represents is that descending rate. The y-intercept would be 30,000. That's our starting height, or our initial height. So an equation, the elevation just means height, after it's been in the air for m minutes. Well, that would be E equals negative 2,000 m plus our initial height of 30,000. Altitude, so that again, that elevation after 5 minutes. So I'm plugging in for m. It says m is my minutes. So there, you should get 20,000. Moving on, it's saying now we're at 8,000 feet. How long it's been descending? So we're finding our minutes. It looks like the plane's been going down for 11 minutes. Once you've completed this, finish the rest of the problems on this page for your practice. Once you've done that, move on to 7 for some more notes. Alright, for these, we're actually going to go ahead and skip over this table a tad bit, but we are given some points, so we'll write them in. Okay, in 2008, Billy Bob purchased a car for $18,000. So in 2008, he got the car for $18,000. By 2013, it depreciated to $10,500. Now, the reason why I left this age in cars blank, so we're going to always treat our first point as the year 0. So, 2008 we'll treat as a 0. Age of the car in years here, 2013. Well, if I subtracted these two, 2013 minus that will give me 5. So at this point, the car is 5 years old. We're not going to worry about graphing these. The key idea here is our independent x, that's always dealing with time, so that's the age in years. The dependent, well, we'll go with the value instead of the cost. Either one will get you the same idea. So our 2 points we're going to use are 0, 18,000, and 5, 10,500. Now, it's time to find the slope. So what that tells me is this car is going down by about $1,500 per year. The initial value, that means find B. So if I choose, let's say, this point, so I'm using this for my x and my y respectively. My m we found is negative 1,500. So plugging in. Oops. My m was negative 1,500. X is 0. So 18,000 is going to be our B. So this linear model, the value of the car V after n years would be V equals my slope. It says after n years plus that initial value of 18,000. So my model, if when the car is worth nothing, set me a value of 0. And we're figuring out how many years that would take. It's saying when. dividing at the end. So it looks like after about 12 years, that car is going to be worth nothing. Here, we're going to have pretty much the exact same steps, so we'll just go through the first parts here to kind of get our independent, dependent, and those different variables. So we have Gemma as a sales clerk in a jewelry store. Although she receives a base pay of $10,000, the rest of her pay is determined by the value of merchandise that she sells each month. In February, she sold $12,000 worth of jewelry and earned $1,960. In March, her pay fell to $1,720 because she'd only sold $9,000 in sales. So here, our independent is the sales, because that's what we're really going to kind of change. The dependent is her salary, or how much money she makes. So, our 2 points here, we have that base pay amount of $1,000. We got some examples going on here. So what we really want to figure out is our slope, how we're going to change. So let's think here. We got our 2 points, right? So if I sell $12,000, I earn $1960. So 12,000 goes with 1960. 1720 in my earnings. Oops, wrote these backwards. So our earnings, let's go back to how we'd find this. So our independent is how much we're selling. So that first one was good. 12,000. And we earned 1960. Here we got to make sure, so it said we sold 9,000 and earned 1720. So just pay attention to the order you define your variables. Finding our slope. We get an answer of 0.08. So she's getting about 8% pay for those sales. Here we're finding the y-intercept. Well, if we pay attention here, we figured it out already. She gets 1,000. So here, B is just 1,000. Or you could calculate it out. The linear model here would be P is equal to that 0.08. And it wants D dollars in sales plus that initial salary. Now, if she sells 14,000, well, that'd be P 0.08 times 14,000 plus 1,000. Plugging it in the calculator. Looks like here her pay would be $2,120. At this point, you're good to move on. You'll be finishing the rest of these problems as practice. Once you've done so, you can move on to 8 for one of our last sections of notes. So here, we're going to do one more practice problem together. So we have a company that manufactures surfboards has a fixed cost of $300 per day and an output of 0 surfboards, and a total cost of $5,100 for an output of 20. So our independent here, the thing that's going to affect it, would be the number of surfboards. So our independent is always the number of things we're selling or how long something takes. The dependent is usually a cost or how much we're going to make. So here it's that cost per day. So our 2 ordered pairs, well, for 0, it's 300. For 20 surfboards, it's 5,100. Finding our slope, or our rate of change. we get $240. So it's costing us about $240 per surfboard. The initial value. Well, here it's saying at 0, we get 300. So you can either go back and see how to solve for that beef, but you'll notice anytime when we know what the initial cost here, so a fixed cost or a flat fee, or here, basically if you have x is 0, whatever goes with it is going to be your beef. So now, our cost C, so it's $240 per surfboard N, plus that initial cost of $300. We're not going to worry about graphing this. Okay, so find the total cost for an output of 12 boards per day. Well, that would be C is equal to 240 times 12 plus 300. Which gives me 2,910. Here, they're giving us our total cost, so we're solving for that N. So subtracting 300. Dividing. So this would be 15 surfaces. At this point, go ahead and complete the rest of these practice problems. Again, don't worry about the graph. Once you've done that, we're actually going to skip over 9 and 10, and I'm going to do some problems directly off the review. They're related to scatter plots, but I figured that would be the best method of showing you the key ideas here, and without costing you an abundance of time on this unit. So here, I'm going to go ahead and jump on the review and look at a few problems. Again, we totally skipped 9 and 10. So let's see here for some scatter plots. Okay. So, correlation. Essentially, if it's going down from left to right, it's negative. That just means if I drew a line, it'd be going down. If I look at C, well, this is going up, so this is positive. Correlation just means, like, what's the slope look like? Here, it doesn't look like there's any pattern, so this is no correlation. It means the data doesn't really have anything to do with each other. Here, same thing, it's not going up or down. Looks like it's going down and then up, so we're going to call that one no correlation as well. So again, just having a general idea about positive, negative, or no correlation. Okay, which relation is shown by the scatter plot? Well, okay, so it looks like as the cost of the flight goes up, so as cost goes up, the number of them that are being sold is going down. So sold goes down. Well, that's choice A. So again, just kind of rationalizing what happens. As your x gets bigger, what's your y doing? Okay, which one here makes sense? So, let's see here. Let's start with D. So this is saying as the price goes up, clothing are sold goes up. That doesn't really make sense. So, no, that's not an answer, right? If the price is going up, you're probably going to sell less things. Okay, cost of sunscreen, so as it's going up, so as cost goes up, it looks like swimming, there's really no correlation here. So since there's no correlation, not our answer. Next one. Here, plane ticket cost. So as our cost is going up, the people going to Hawaii, so tourists also go up? That doesn't make much sense to me. You'd think if plane tickets were cheaper, more people would go. So no. Here, amount of copies made. So as your number of copies goes up, it's saying the ink is going down. Well, that one definitely makes sense. The more copies, the less ink you have. For 8, the scatter plot below shows the average yearly consumption of bottled water per person in the United States starting in 1990. Using the trend line, so the trend line just means this line that they drew in the graph. Let's see how much bottled water was in 1997. Well, 1997 would be between 96 and 98. So if I go up here, and I'm looking at my trend line, it looks like about 16. So again, just making a conclusion from the line. here, we'll take a look at, that one we should be good. But we'll take a look at 9. A high school principal wants to predict the number of students who will drop out of school. So he's got an equation. The key idea is years since 2004. So the first thing we're going to do, just like earlier, is rewrite these years. So that's the number of students, but the years since 2005 means 2004 x's are 0. Now, we're looking at 2015. So, if I think about that, between those 2 years, I would subtract them then to get 9 years. I lied. 11 years. So that 11 is what I would go ahead and plug in here for my x. So that would give us an idea about how many students dropped out. Equation of the trend line, well, we have 2 points, so I'm going to use those. We're going to find slope using the slope formula, and then find b by plugging into y equals mx plus b. Figure out your equation, and it's similar to what we've done. Same thing here. So are they on the trend line? Let's look at these points. 125, 163. Well, it's here. 163. That doesn't look like it's on that line, right? Because that's pretty close to 200. So that would be false. 80, 70. 80 somewhere here. No. That's the, or 8700. Yeah. Maybe? But not definitively. So if they're not blatantly on the line, the answer is false. Positive correlation? Well, from left to right, that's going down, so that's definitely negative, so that'd be false. And these should look like all these word problems we've done. So at this point, you should feel pretty comfortable with everything in here, so go through this review a couple times, and after that, once you checked it in, all you have to do left in this unit is pass that Unit 7 exam. Alright, so these are going to be our notes for Unit 8. First one here. With this one, the big idea is if you have not done Unit 6 yet, or if you need a review on graphing, I encourage you to go back and watch some of that Unit 6 video, and then work through all of number 1. So you're going to do all of these problems here on 1. What that'll give you to do is a good refresher on, again, just graphing a single linear equation. From there, we'll move on. Alright, solving systems by graphing. This is 2, so we're going to kind of skip over a bit of the ideas here. Kind of the big idea is the 3 different outcomes. One solution. So in one solution, we have some lines that intersect each other at exactly 1 point. Here our solution is an ordered pair, x comma y. No solution means I have 2 lines that no matter how far I go on, they never touch one another. These are parallel lines. And our last one, infinite solutions, is when I have 2 lines, but in reality, they're the same line. So here the equations might look different, but the lines are exactly the same. So these are the same line. Alright, you guys are going to love this. When we solve these, we are using GeoGebra. So anytime you solve by graphing, we're only going to use GeoGebra. So go ahead and open that up now. So, once we go ahead and solve, here's what we're going to do. So we want to have y is equal to 2x, or negative 2x plus 3. So for my first equation, I'm going to go ahead and type that in. So in the input, y equals negative 2x plus 3. Once you've done that, press enter. You'll see a graph of your line, as well as the line named over here. For our next equation, we have 2x plus y is equal to 3. So let's go ahead and type that one in, just like it looks. Here, we graph as well. Now, what we're going to notice here is that these are in fact the exact same line. We see our f and g overlapping, so since they're the exact same line, they just look different. our answer here is going to be infinite solutions. For our next one, we have y equals 1 and y equals negative x minus 3. So let's go ahead. We're going to delete what we have. So I'm just going to click on them, right click, delete, right click, delete. Definitely clear them out each time. So for our input here, we're going to type in those equations. So my first one is y is equal to 1. So up here, y equals 1. Press enter. It draws our line in. Our next equation, y is equal to negative x minus 3. Y equals negative x minus 3. So, if I want to see where these intersected at, I'm looking here. So it looks like they're intersecting at negative 4, and then halfway between 0 and 2, which is 1. So their intersection is negative 4, comma, 1. You can use that exact same method to solve all of these problems. So anytime you're asked to solve by graphing, easiest way, use GeoGebra. So what I'd like you to do is complete these next two problems. And once you've done that, complete all the problems here on practice 3. Again, we are just using GeoGebra for all 10 of these. So no need to actually show the graph, just use GeoGebra, identify your answer. From here, once you've completed that, we're going to move on to 4. We're actually going to skip over this. I don't really like how the page was formatted, so I'm going to do a couple problems on your homework for you. So here we're using substitution. So on this one, the concept is we're going to plug something in for something else. So together we're going to do problems 1 and 10, and the left will be left as practice. Check something. All good. Alright. So, for this one, this is an example where we have two y equals. So I'm given y equals in both problems. So in this case, we're going to set these two sides equal to one another. So I would have negative 4x plus 7 and negative 5x plus 9. And they're equal to one another. Now, we're going to solve for x. So let's move my x to the left, just like we've done before. So I find out x is equal to 2. Now, to get my solution for y, that other part of the ordered pair, I can use either equation. So I'm just going to use the top one. So I know that y is equal to negative 4x plus 7, and to solve for y, I'm going to plug that 2 in for my x. Calculator here gives me negative 1. So the final answer, which I'm looking for here, is 2 comma negative 1. Now, let's take a look at number 10. Here, if we look, we have, let's see how I name this, 1 y equals. So I only have one equation where it's already y equals. So in this scenario, we're going to use a little bit of a different type of substitution. So first, put parentheses around the equation with the y equals. Now what we're going to do, and this is similar if I had x equals, it's the same thing. So since it's y equals, we're going to plug in to the other equation's y. So that entire term that I've written here in red, with the parentheses, goes here. So what that gives me is negative 6x minus 3, parenthesis, negative 2x plus 8 equals negative 6. Now, once we've substituted, we can solve. So first, I'm going to distribute that negative 3 to everything inside my parentheses. Again, if you're looking for a review on distribution and solving equations like this, the best place to go is going to be that Unit 2 video. Same side of the line, we're going to combine these two terms. So here, negative 6 plus 6, that gives me 0x minus 24 equals negative 6. 0 multiplied by anything goes away. So this gives me negative 24 is equal to negative 6. Is that true? That's a false statement. So what that means, since I got to a false statement, there's actually going to be no solution here. Similar to what we did back in Unit 2, is let's say I arrived at a true statement. So if I got something like 5 is equal to 5, well, that's true. So that would be how we'd find infinite solutions. Let's go ahead and do one more together. So let's try number 12. So here, if I'm looking for my y equals, this is another 1y equals. So that's there. So I'm going to plug it into this y. So I'm leaving everything around it the same and putting those parentheses. So 3 parentheses x minus 1 equals 9. From here, as I've said, we distribute first. So I'm not doing anything with the negative 7x plus 3x minus 3 is 9. We can combine these two terms here because they're like terms and on the same side. So same side of the line, just combine. Let's add 3 to both sides. So I have negative 4x plus 12, divide. So I'd get x is equal to negative 3. Now, when you're plugging back in, you can use either equation, but I would suggest using this one since it's already solved for y. It gives me a little bit less work. So I have y equals x minus 1, and if I plug in that negative 3, so always plug in with parentheses, calculator, y is negative 4. So our solution that I'd be looking for is x, comma, y. Alright, from there, what you're going to work on now is finishing all the problems on this page. Make sure you take your time and show all steps as I have. You'll also be working on substitution here. You'll notice the first chunk of these, 1 through 5, we have y equals. So in the 1 through 5, we have 1 y equals. So let's do a quick bit of examples here when we don't have that scenario. So, actually it's 1 through 6, my apologies. So 1 through 6 should look pretty familiar. We have 1y equals. Now, some other problems here, we move on a bit. So, first thing we're going to do for each of these problems is identify a special term. So by special I mean, it's a variable with a coefficient of 1. So here, if I'm looking, well, that's a coefficient of negative 4, that's negative 5, this is negative 1. But here, this is a coefficient of positive 1. We'll see why that makes sense after we identify it. Looking here, well, it's negative 7, that's negative 2, but this one is just an x, so it's a coefficient of just 1. Let's see, negative 5, negative 3, 6, well, here it is, there's my one with just a coefficient of 1, or just x, or just y, positive. 10, we would use this one, that's just a positive y. 11, 3, negative 3, negative 3, well, here it is. It's just x, or just a positive 1x. 12, upon examination, we find it's here, at that positive y. 13, well, this is a negative x, so we don't want to use that, but there's a positive y. And 14, again, our positive y. 15, then we get a y. 16, another y. It doesn't matter if it's y or x. And we'll skip this last bit of problems here. You'll also notice at the bottom of this page there is an answer key to check all your answers. So just make sure you're showing your work. Alright, so let's do number 7 together. So, first thing, to use that substitution, I got to get y by itself. So to do that, I would take this negative 4x plus y equals 6. I want to move my x over. So I'm going to add 4x to each side. So that gives me y equals 4x, because it's positive, plus 6. Now I can substitute, just like we've done before. So I'm plugging that into my other equation. from here, I need to distribute that negative, so it's like having a negative 1. So it'd be negative 5x. And again, for more notes on this, go back to reference the Unit 2 video. Same side, we're going to combine. Divide. I get x is equal to negative 3. Let's go ahead now. We do have an equation up here solved for y, so let's plug in there to find our y. You could also plug into those other two equations, but this one will make it a bit simpler. So I'm plugging in that negative 3 for my x. Calculator here, we'll get y is negative 6. So our solution, negative 3, negative 6. We'll also do 8 together, because this one's solved for x. So here, x was my special variable with that coefficient of 1. So what I'm going to do is solve this equation for my x. So to do that, I'm going to add 2y to both sides. So that would give me x equals 2y plus 11. So that, I'm going to substitute, but this time I'm going to plug it in for x, because that's the variable by itself. So here, I'd have negative 7 parenthesis 2y plus 11 minus 2y equaled negative 15. Solving, so we're going to distribute again. Again, Unit 2 video. Now, even though they're not next to each other, they're still on the same side of the line, so I'm just going to combine those like terms here and here. Dividing gives me y equals negative 4. Now, to get my final answer, this time we got y first. So I'm going to plug that y back in here to my x equals equation to figure out what x is. So here I get x is equal to 3. So my solution, x always comes first, so 3 comma my y of negative 4. At this point, you should be good to finish all the problems up to this page, besides the ones I've crossed out at the bottom. Once you do that, we can go ahead and move on to 8 for some more notes on a little bit of a different method of solving. Okay, so for 8, we're actually going to skip over it, and we're just going to go right into homework, just again, give you guys a little bit less work here. So let's go on to 9 and do some of these together. Now, talking about kind of similarity between problems, we're going to talk about which chunks of this homework are going to have similar strategies. So for numbers 1 through, let's see here, 4. That's going to be one chunk that's kind of the same. Let's see, now our next chunk here, number 5 through 8, those will be similar. Give me a moment here. You know, we'll just work through 12. But those will be similar as well. Alright. So we're going to do problem 1, 5, and 9 together. And again, this practice will conclude here. You are welcome to do the next chunk, as it is great extra practice. You'll notice that there is an answer key following at the bottom. However, these would be the ones I would check in for you to advance on. Alright, so how to tell when to use elimination? We'll notice here that neither of these equations is solved for y. So the key idea of when we should use elimination is when no equations are solved for y. Otherwise, if we have something solved for y, we've seen substitution is pretty quick. So, the key idea here is we're going to have this type of setup. So something x plus something y equals a number. Something x plus something y equals a number. What we want to do is find some leading terms here. So if I called this a, let's just say it's some number. Let's just go with a nice hashtag here for the number symbol. So let's say I want to cancel my x's. Then I would want this number out front to be the same as this one, but I want one of them to be negative. So maybe the top is negative, or maybe the bottom is negative. It doesn't matter, as long as they're the same number, but one positive and one negative. Similarly, if I want to cancel my y's out, I would have the same number, and maybe the top one's negative this time, or the bottom. Again, it doesn't matter. Notice, when we're doing this, we only need to cancel one variable, either x or y. It has nothing to do with these numbers. So, for our first one here, let's look at my x's. We see that they're the same number, and one's negative and one's positive. So that means I'm going to cancel my x's. If I looked at my y's, well, those are different numbers. Can't cancel them. So in this first chunk of examples, these are the kind of setup where there's already something to cancel. So here, since these are the same, we're going to think about adding, and we're going to add down. So negative 4x plus 4x, well, that's 0x. But we know that multiplying by 0 just eliminates the term, so it's gone. So these terms cancel. Adding down, negative 2 plus positive 8 gives me 6y, equals, adding down, negative 12 plus negative 24 gives me negative 36. Quick some division here, y equals negative 6. Now, it seems fast, but we still got to find that x. So I'm just going to take my top equation here and plug in my y to figure out what x is. So, my final solution, x comma y, 6 is x, negative 6 is my y. At this point, I would suggest pausing the video and working through numbers 1 through 4 and then checking your answers at the bottom. These will all follow that setup where something's going to cancel almost immediately. Once you've done so, we'll move on to 5. Now, here, you can notice in these next 4 problems, we don't have any of those nice cancellations like you had in 1 through 4. So we got to do a little bit of work. So, let's look here. Well, these are different numbers. They're both negative. So that's going to be a little more work to cancel those. We'll see that later on. But if I look at my y column here, well, they're the same exact number. But I need to make one positive since they're both negative. If they were both positive, I'd need to make one negative. So here, to get my positive, I'm just going to multiply the second equation. You could do it to the first, it doesn't make a difference. But to change my second equation up here, I'm going to multiply everything by negative 1. So that negative 1 goes to each and every term. So that gives me the equation, negative 1 times this gives me 4x plus 9y equals positive 23. So that's the distributing there. Now I got a positive 9y and a negative. So I'm just going to go ahead and copy this equation down. It doesn't matter which one's on top or bottom. Now at this point, I have that set up. So I got positive 9, negative 9y. So I can add and I know they'll cancel out. So these terms cancel, which means I add down these. So 4x plus negative 2 gives me 2x. And it's equal to, if I add negative 2, dividing by 2 on both sides, I'll get x is just negative 1. Now, let's use my top equation again to plug back in and find y. So I'm substituting x as negative 1. Y equals positive 3. And my x was negative 1, so my answer, negative 1, positive 3. You'll notice That similar step there of multiplying one of the equations by -1 will work for each of these next 4 problems. So again, pause the video at this time, work through 6, 7, and 8, check your work with the bottom answer key before you move on. From here, we'll move on down. So let's take a look now at number 9. Alright, so amping it up a bit here. For 9 through 12, these are going to be a little more complicated. So, right now I'm looking, I don't have any terms that are the same, not one positive, one negative, so we're going to do a little bit more work here. So what we're going to do is when you're given a situation like this where we can't do any of the methods we've done above, we're always going to look to cancel x. So, I'm looking at my x's. I got 5x and 10x. So, the way to cancel these, I'm going to multiply the top by what's in front of the x here. So I'm going to multiply everything here by 10. So that gives me 50x plus 10y equals 90. On the bottom, now, since they're both positive, I know I'm going to need a negative. If one was already negative, one of these x's, like for example, here, then we wouldn't have to do this because one's already positive and one's already negative. But here, since I have both positives, I know I'm going to need a negative. So now on the bottom, I'm going to multiply by what's out front of the x. But I'm going to throw a negative in there so I can cancel and distribute to everything. So this gives me negative 50x plus 35y is equal to 90. So once we've done that, now we can start solving. So here's where we'd have to do that twice. So multiplying top and bottom. So this is the most complicated version of these problems. So here we're always going to cancel x's by this method. So these, positive 50, negative 50, they go away. Adding down, I get 45y is equal to 90 plus 90 is 180. Dividing by 45, I'll get y is equal to 4. Now, we're going to plug back in. I would suggest using the original equations. You can use any of those on there, but the originals tend to have smaller numbers. So I'm going to use that 5x. I'm going to substitute, so plus 4 equals 9. X minus 4 from both sides. So 5x is equal to 5. Divide. X is equal to 1. So my final answer here, x comma y is 1 comma 4. So, once you've gotten through this, complete problems 10, 11, and 12. If you need help, make sure you're asking questions and referencing these notes. Once you've done that, check your answers with the key at the bottom, and we're going to move on to 10. So 10, we're going to work on these first 4 problems together. You'll then complete the rest for homework, as well as number 11 for homework with all of these 5 problems. So we'll do a few together, and then you'll have a good chunk to practice on your own. But as far as our notes go, let's go ahead and take a look here. So break-even word problems. Essentially what this means is we're going to have something like one equation equal to another. Alright, so number 1, you decide to market your own custom backpacks. You invest $8,050 for a printing machine and spend $275 to buy and print each backpack. If the backpack sells for $10.50, how many backpacks must you sell to break even? So we're going to think about 2 sides of an equation here, our costs and setting it equal to our profits. That's what the idea of break even means. How many do I have to sell so that I'm starting to make money? So on my cost side, well, I invested $8,050, so that's a cost. And then it's saying I spend $275 for each backpack. So plus $275, remember that each and every, that means we get an x by it. It's equal to, I'm selling each backpack for $10.50. So that $10.50 also gets an x. From there we solve. So I'm going to subtract. So 10.50 minus 2.75 gives me 775x dividing gives me 1038.71. Well, I can't sell 0.71 of a backpack, so the answer we'd be looking for here is we're going to round up to the nearest whole number, because that's how many backpacks I sell, because I can't sell a fraction one. So we're always going to round up in these break-even problems. Now, number 2. Chad and Stacy invest $3,600 in equipment to make dog collars. Each collar costs $5.25 to stitch and sells for $12.37. So things that are costing me money, if I'm investing it, it's over here. And it's $5.25 for each, so that gets an X. Equal to, I'm selling them for $12.37 each. Solving. Dividing. I'll get X equals 505.62. So again, we always round up in these problems. So I need to sell 506. Moving down. At the local ballpark, the team charges $12 for every ticket and expects to make $3,200 in concessions. So that looks like I'm charging $12 for each ticket, so that's X, and I'm going to make an additional $3,200. I have to pay my players, so on the other side here, I'm paying them $7,500. And all other workers get another $2,000, so that's another $2,000 I'm spending. And lastly, each fan gets a free bat that costs me $5 per bat. So since it's per bat, that gets an X. So a little more work here, but we're solving the same kind of way. So there's nothing I can combine over here, so that's just going to come down as 12x plus 3,200. Over here I can combine my numbers. If, say we solve this one to the left, again, you know it doesn't matter which way we go. Subtracting over here to isolate my x. Give me 7x is equal to, and dividing, I'd get x is 900. So this one came out to a nice whole number, so no need to round. So there, we need to sell 900 tickets just to break even. If I sold more than that, it would be a profit. And our last example, before you guys get on to practicing here, at the local movie theater, the owner charges $10 for each ticket. And I'm going to make about $1,200 in popcorn sales. So I'll take 10x plus 1,200. The owner must pay her ticket takers $2,700 and all other workers $500. So now I'm spending money. Each customer gets a free medium drink that costs me $4 per drink. So same as above. Let's go ahead and solve now. So that gives me 6x is equal to 2,000 divided by 6. I get x is 333.33. So again, we always round up. So I'm going to need to sell 334 tickets. You'll notice the examples and other problems line up very closely, so please complete those now. And again, when you're done with that, go on to 11. Again, very similar examples. Once you've completed that, move on to 12 for some more notes. Alright, so looking at 12 here. Here we're dealing with inequalities. So, greater than, less than, or equal to. That's when we get the line underneath. These use a solid line, which will make sense once we graph a few. These two, without the or equal to, use the dashed line. essentially it'll get into helping us determine which values actually satisfy these. So, first thing we're going to do is we're going to notice that these are graphed almost identical to our standard graphing equations, with the only difference being is that solid or dashed line and our shading. So, if I'm going to graph my first line, let's do that in red. So here I have, pretend this is an equal sign. So my m here, the number out front of the x, that's just 1 over 1. And again, if you're looking for a review on graphing, go head back to Unit 6 videos. My b here, positive 2. So I'm at positive 2, and my slope positive means up 1 over 1, so up 1, right 1. Now, before you draw the line in, because this doesn't have that line underneath, we're actually going to draw this in with a dashed line. So let's go ahead here and draw it in with a dashed line. And for these, we can just use 2 points to graph. You'll understand why shortly. For our next one, I'm going to do this one in blue. It's already solved for y, so we can identify m and b rather quickly. Here it's negative 2 over 1, and b is negative 1. So I'm going to go down here to negative 1, and then negative 2 means go down 2, positive 1, right 1. So down 2, right 1. Now this one has the line underneath, so that means this one gets to be a solid line. Now, the way of identifying solutions involves shading. So, some notes on this. If we want to go ahead and shade these, I'm going to give you guys a bit of a shortcut. So, if it's greater than or greater than or equal to, these we're going to shade above the line. If it's less than or equal to, you guessed it, we shade below. So, let's look at our red equation here. This one is a greater than, so I'm going to shade above this line. If you think about above, that would be the top chunk here. So I'm going to shade here and here. If you look, every time we graph one, we're going to get 1, so let's take a minute here. I have 1, 2, 3, 4, kind of chunks of the graph. So rather than shade, let's just go ahead and like kind of mark them. So I'm in this section here, so I'm going to kind of just draw a nice little, let's go to star. So I'm either here or here, because I'm above that red line, so now I'm in this part. Now for the blue line, it's a less than, so we're shading below the line. So the 2 chunks below the line are here and here. Now the final part where we're actually going to shade is the part that contains both solutions. So the part that would contain both solutions here would be where I have both my stars. So this chunk is where my solutions are. That means any point in here I could plug in, and it makes those inequalities true. Let's move on to number 2. So remember here, since I don't add anything at the end, that's like adding 0. So here my m is just 2 over 1. My b is 0. So graphing means up 2, right 1. I look, it's got a line there, so that tells me it's a solid line. And the next equation again. This one now, it doesn't even have an x, so that's a special case again where we had that horizontal line. So it's a horizontal line going through negative 1, and it's solid because it's got the line underneath. So that's this line here. And again, for a review of this, in Unit 6, there's an entire lesson on special case graphing. Alright, so let's look at our red line first here and think about where we're going to shade. So this one's greater than or equal to. So that means I'm shading above. So the top of this red line involves here and here. For my blue line, it's greater than or equal to, so above the blue line would be here and here. We see rather quickly which section has both of those stars. So this is our final shading for all the solutions that make this true. Our last example a bit more work. So as you remember, we can only graph when it's like y equals mx plus b. So here, I'm going to have to get y by itself. So I'm going to subtract x from each side, which gives me y is less than negative 1x plus 5. So going to graph here, we know that m is that negative 1 over 1, and my b is positive 5. So I'm at 5, down 1, right 1. Since it's just less than, this one gets a dashed line. Now for our blue line. Well, here it's already solved for y, so m is just 1 over 1, b is negative 4. It's or equals to, so it's a solid line. So here, if we're looking at our 4 parts of this graph, let's go ahead and highlight these just for further recognition. So in this example, we need to kind of look at where these 4 areas are. If we look, every time we get these lines, it's forming some kind of cross, just at different perspectives. So if I look where they're crossing at, well, it looks like I have a little area here, and then the cross on the top, well, I got this chunk of my graph. Well, here to the left, I have this whole region. Again, it doesn't matter on the size of the region. That doesn't necessarily tell us what our answer is. We're just going to visualize where these 4 sections are. And our last one, kind of below the cross, would be down here. So that's a quick way to determine where those 4 regions are. You're looking from our intersection, up, left, right, and down. And again, it may be at various kind of perspectives, but that's the general pattern. So I'm going to go ahead and erase those shading now. You can go ahead and figure out which one is the correct one for our solution. Alright, so looking at the red line, right? We got a less than, so I'm going below the red line. So that means I'm either here or here. Our blue line, that's a greater than, so that means I'm above the blue line. So that's here or here. We can quickly see this is the section of our graph that contains both of those stars. So that's where we shade. And again, just because it's the biggest doesn't necessarily mean it's right, but in this case, it happened to be true. Once you've done that, I would like you to complete the next 3 problems, as well as move on to 13. You'll be working on the highlighted problems here, so all 6 of them. When you've completed that, be sure to check your work, and then you can move on for your next section of notes in 14. So, number 14 here is a little bit of a different method of how to go ahead and check these, but I think you'll find that the shading works great the way I had showed in the last lesson. If you are totally struggling with that, what I would like you to do is raise your hand. Come up to my desk when you're called upon, and I can show you a couple of these examples together. But, assuming you already kind of got what's going on, you can skip over this section for now. If you'd like to practice, you may go ahead and complete these problems. Even just 1 through 4 would be great. The rest here involve a little bit more work. However, again, if you are struggling with the methods shown in 12 and furthered upon in 13, this I would be happy to show you another way to solve them. So, going from here, we're going to move on to 15. So again, all of 14 is essentially, if you're struggling with 12 and 13, raise your hand, I call on you, you come up to the desk, we go through 14 together. So a different method of testing and shading those inequalities. But if you're feeling good, you're feeling confident on 12 and 13, you can skip 14. It's up to you. 15, we're going to do 2 of these together. So we're going to go ahead and work through problems 1 and problems 2 together. So a bit of a word problem with inequalities. Once these are completed, you will finish 3, 4, 5, and 6 as practice. This will be the way in which you best prepare for your final exam. For this unit, Unit 8 exam, not final exam. So once we get through this, you'll finish up 15, and then jump on to your review. But, let's finish up our last bit of notes here for this unit together. Okay, so for problem 1. As a fundraiser for your soccer team, you must raise at least, that's going to be a key word there, $30 by selling cookies for 2 a box and donuts for 5 per box. You must sell more than 10 boxes. Okay, so first thing we're going to do is define our variables. So again, this is kind of similar to what we did back in the end. We're selling 2 things. So it looks like I'm selling cookies and I'm selling donuts. So let's let X be cookies and Y be donuts. So similar with those XY problems we see in Unit 7, so if you had not completed that, it'd be great to go back there and look for those kind of standard form problems. So we got cookies and donuts. Now, for this first inequality, I'm looking at this sentence. Okay, so I'm selling cookies for $2 per box, so it's 2x, and I'm selling donuts for 5, so it's plus 5y. Now, if I want to make at least $30, that means I want to make greater than or equal to $30. So that would be greater than or equal to 30. Now for the second inequality, I'm going to look here. You must sell more than 10 boxes. So cookies and donuts, that's the number of boxes of each. So if I need to sell more than 10, well that means that x plus y must be greater than or equal, must be strictly greater than 10. Here it's at least, so it's greater than or equal to. Here it's strictly more than, so that means greater than 10. Now, with this too, we're going to graph using what's known as intercepts. But a way that I find a tad bit easier here, so we're going to go ahead and plug these things in. Now, some notes on using intercepts. So let's take these off to the side here. To find our x-intercept, we ignore the term y. So even if there's a number in front, we just basically pretend it's not there. To find our y-intercept, we ignore the term x. So again, no matter what's out front, we pretend it's not there. So let's look at our first inequality here. So I'm going to do this one in green. So for my green one here, I have 2x plus 5y. And when we solve these, we can go ahead here and just pretend it's equal to. That's how we find intercepts. So first, I'm going to find my x-intercept. And then over here, I'm going to do some extra work to find my y-intercept. So here, when I want to find my x-intercept, we are going to ignore our y term. So that's ignoring that 5y. Similarly here, to find my y-intercept, I ignore x, so I'm going to ignore 2x. So if I ignore this 5y over here, that gives me 2x is equal to 30. Divide by 2. So my x-intercept is at 15. Here, if I ignore the 2x, that gives me 5y is equal to 30. That gives me a y-intercept of 6. So for first inequality, my x-intercept, 15. My y-intercept, 6. Take a minute now and make sure you have that all down. I'm going to erase to do the next inequality. Okay, actually we won't erase, let's kind of do some work down here. Alright, so I'm going to do my next one in red. So I know I'm going to have 2 parts to this thing, so I'm going to write my equation twice. I got x plus y is equal to 10. So again, when we find intercepts, we always treat these as just equal signs. So for my x-intercept, here it's just y, but I'm still going to ignore it, so I ignore my y. For my y-intercept, it's just x, but I still just ignore it. So that gives me, well, y is equal to 10. In this one, if I ignore x, oops, backwards here, we're ignoring y. So that gives me my x-intercept, since it's just x equals 10, it's just 10. Here, when I ignore the x, I get y is equal to 10. So my y-intercept here is also just 10. So for both of these, 10 and 10. Alright, now we're going to use those to graph. Now the reason we're only looking at the first quadrant here where everything's positive is because we're dealing with strictly real-world things. So these, in most cases, we're only going to look at positive numbers. So let's go ahead here. Looks like 15 is my biggest, so I could probably just label these by ones. So let's go ahead and label everything by ones. And since I don't quite have enough, I'm just going to kind of extend that up a bit and throw a 15 on there. Another option is you can use a different scale. So say you want it to go by 2s. As long as you label it, you can use whatever scale you want. Example 2 here, we'll write the inequalities, but we'll leave the rest up to you to do. So we'll go ahead and go through the inequalities here, but as far as the rest of the problem, that'll be left to practice. Okay, so now I'm going to graph my 2 inequalities. So let's start with my green one. Here I have an x-intercept of 15. So I'm here at 15, and a y-intercept of 6. So now I'm on the y-axis at 6. This is an or equal to equality. So what that means is I have that solid line. For my red equation, I have an x-intercept of 10, and a y-intercept of 10. It's just strictly greater than. So what that means is that's a dashed line. Now for the shading. So to figure out where my solutions to this are, well, let's take a look here. So my green is a greater than or equal to. So that means I want above the green line. So that would be this section and this larger one here. Sorry. So for our red, we have a greater than as well. So going above the red line puts me here. Oops, should probably put that in red. So above it would be here and here. We see that this is the portion of our graph that contains both. So our solution set, where we would shade, would be this whole upper region here. Now, let's work with this situation. Well, the following combinations work for this. 25 boxes of cookies, 20 boxes of donuts. So we let cookies be our x. So this axis here represents our cookies. Y was our donuts, so this vertical axis represents our donuts. So the number of each in boxes sold. So 25 boxes of cookies. So that's way over here somewhere. And 20 boxes of donuts. Well, that looks like it's going to be way up here. But let's go ahead and check. So I want to see if it satisfies both of these. Again, we can see that if we plug in the point 25, 20, well, it's going to be way up here somewhere. So that's definitely in the shaded region. So the answer is yes. Oh, 10 boxes of cookies, 5 boxes. So it's 10, 5. Yeah, that's definitely in there too. So that's another yes. 6 and 2. Well, 6 boxes of cookies, 2. That is not in that shaded region. So the answer there is just no. For number 2 here, we'll just go ahead and write these inequalities, and at that point, the rest of this will become practice. Alright, so we have Frank works 2 jobs. He makes 6 per hour working with his dad, and 14 per hour doing yard work. So the 2 items here, we'll call this working with dad for X, and 14 for doing yard work. So that'll be yard work. And again, it's the hours of each. In 1 week, he needs to make at least $84, and he only has time to work a maximum of 10. So let's think about equality 1 as how much we're making. Well, I get 6 per hour for dad, plus 14 per hour, so y for yard work, and I need to make at least 84. So that's going to be greater than or equal to 84. For my next one, I only can work up for a maximum of 10 hours. So that means that x plus y has to be less than or equal to, because it says I can work 10. So we'll use that same strategy here of the red and green to find our intercepts. So for these two, we'll find our x here and our y here. So for my x-intercept, I ignore the y. So I get 6x is equal to 84. For my y-intercept, I ignore the x. So I get 14y is equal to 84. Kind of solving both of these here. So here my x-intercept would be 14. And my y-intercept here would be 6. Now working with our green one, or our second equation. For our x-intercept and our y-intercept. For x, we ignore the y, so I just get x is equal to 10. So that's just going to be 10. Here for my y, I ignore the x, so I end up with y is equal to 10. So my y-intercept is also just 10. Alright, so now we're going all the way up to 14. So again, they'll fit on this one, and say they didn't. Say you had like 25 as a point, just count by 2s. But let's go ahead and this one and just go by 1s. Okay, so before we graph, let's go ahead and label these axes. So x, my x-axis here, this is working with dad. That's how many hours I'm doing that. So hours working with dad. Y is my yard work, so it's hours of yard work. Alright, now let's go ahead and graph. So my red line here, x-intercept of 14, y-intercept of 6. It's an or equals to, so that's a solid line. For my green, 10 and 10. It's also an or equal to, so that too would be a solid line. Now, before we can start answering questions, let's shade. So the red one was a greater than or equal to, so I'm shading above the red line, so that'd be here and here. The green is less than, so I'm looking below. So below the green line would be here and here. We check and see that the sweet spot where this scenario works out is right in this shaded region where we have both of our stars. So in your case, instead of using both stars, since you may or may not have two colored pens, maybe do the first one as a star, the second one as a square, as a circle. Whatever works for you. Alright, so answering these questions. Describe a potential combination of hours so that this is satisfied. What that means is let's find something in the shaded region. I would suggest not picking something like right on the lines just to make sure. So if I look here, well, 2 and 7. Or we could do 1, 7. That's definitely in there, right? So let's use 1 for my x, so that would probably be 1, 7 for my y. For this one, which one should he work so he can maximize his income? Well, yard work pays more, so quit working with dad. And why? Because yard work pays more. Alright, from there, you guys are finishing the rest of these problems. Once you've done that, you can go ahead on to the review. When you've completed the review, the last thing you have to do to successfully get through this unit would be pass the Unit 8 exam. Best of luck. Make sure you're checking, raising that hand, and asking for help if you need it.
Alright, so these are going to be our notes here for Unit 4. This is where we're dealing with exponential functions and logarithms. Alright, so let's get started. Alright, first thing we have here is the idea of an inverse function. So this is kind of switching our x and y's around with functions. The key to what we're going to be switching for, or inversing, is our logarithmic function with our exponential. So key ideas here. B stands for the base. In either one, when we switch, the base stays the same. So whatever's down here, it's going to stay the same here. Then we flip-flop a and x. So it's b to the x equals a. This will make a lot more sense after some examples. So let's go ahead and work through these. The base of this is a 3, so it stays a 3. Switch the 2 and the 9. Working through my next one. The base is a 7, so it stays 7. Switch the 0 and the 1. So in general, an exponential is like a base to some power equals some number. Here, my base is 4. Switch the negative 2 with the 1 over 16. So that's going from logarithm to exponential. Here we want to take an exponential and put as logarithm, so they all start with log. That's where every logarithmic will start. The base is 14. Switch the 2 and the 196. So let's always put parentheses here. Put something inside a logarithm. The base is 12. Switch the 1 and the 12. The base is 2. Switch the negative 3 and the 1 over 8. That little habit right there, if you want to work through this, is going to be essential in this unit. I'm going to skip over these for now. I'm going to talk about them right here. So we're going to go kind of back and forth. So if we get a logarithm, we're going to make an exponential. If we have an exponential, we're going to make a logarithm. So for 1 here, I have a logarithm. Let's make it exponential. So the base, if we don't have a base in the logarithm, if it's ever not there, we assume it's 10. That's just kind of a calculator type thing. But again, just always remember, if there's no base, the same thing here, no base, we make it a 10. So I keep the base the same, switch the sides. So 10 squared is equal to x plus 1. So that's the whole term in there. Over here, keep the base the same. 10 to the 7th is equal to 3x. Over here. Here I have an exponential and I want a log. So it's log. The base is 10, so it is 10. Technically you don't have to write that, but I would get in the habit of doing it. Switch the 92 and the x. Here's log base 10. Switch the 74 with the 2x. Special cases right here, so 5, 6, 7, 8. ln is a logarithm with base e. So since it's just ln, my base is e. So here, my base is e, switch the 5, 3x. Same trick here, we have an e on the bottom. So it's e to the 19 equals x. Same idea here. So e and ln are kind of a pair together. They're a special case. So since I have an e here, I'm going to start with ln. Base stays the same. Switch the 24 with the x plus 2. Here, ln. And again, don't technically have to write this. It's kind of like the regular log of a 10, but it's a good habit to get into. Switch the 33 with the 0.75x. So some notes for the calculator here. Change of base formula. So in GeoGebra, sometimes we can evaluate things differently. But again, just kind of our general change of base here with the standard calculator is log base b of a is equal to log 10 of a over log 10 b. So in the calculator, it would just look like log parenthesis number divided by log parenthesis number. So again, some calculators can do it a little more fancy, and I'll work with you guys individually on that, but that's our general change base. So let's talk about each of these, how to evaluate them. So what's great about GeoGebra is it actually can evaluate logarithms directly, as can some of your calculators. But I would like to avoid the change in base formulas. It's a little more work than we need. So let's get GeoGebra set up for how we will in this unit. So in the first unit, we needed that spreadsheet. Here we don't need it. So let's go ahead and just change a few things. Also, your input bar is usually down here. So what we're going to do is go to View and go to Layout. So do this with me right now, just so we can change things around. If you're opening up GeoGebra, just hit pause. Still waiting. Alright, so make yours look like mine. Here's kind of the default. What we want to click here is make sure this one, the input bar is on the top. And you also want to put a toolbar on the top. Once we have that, we're kind of good to go here. Yours should also default to having these things shown. If it doesn't, just ask me and I'll help you out. So what we're going to get rid of is this weird gritty background here. So we're going to right click and just hit grid. We just want the axes. That'll kind of help us with our findings here. Actually, not. Let's leave the grid. Alright. So this is kind of our general layout here for when we are going to work in this logarithm unit. So to evaluate these, our first one here, we have log base 16 of 64. So in the calculator, I'm going to go up here to my input bar and type out log. You see a lot of options. We want the first one. So the B stands for the base. We said our base in that question was 16. And clicking to the right, our of part is 64. Press enter. And there's our answer, 1.5. So our answer here, 1.5. Now we have log base 8 of 1 over 16. Log base 8. Here, 1 divided by 16. Our answer, negative 1.33. Let's try this one over here. So we have log base 5 over 2. Log base 5 over 2. 0.43. Alright, real quick. This one here, whenever we have a negative inside the parentheses, that's going to give us an undefined answer. So if there's ever a negative, you know the answer is undefined. And GeoGebra will split that out as well. Let's do these last two here. So this one, there's no base. Remember, it's 10 there. So it's log 10 of 294. Which gives me 2.47. And our last one here, so remember it's syntax. So the natural log of 13. Remember, ln, that means our base is 8. So here we would do log. In the base, you literally just type the lowercase letter e and put 13. And we get 2.56 there. So, pretty easy evaluating with GeoGebra. Alright, here comes the fun stuff. Solving. Let's get right into it. Alright. So, we're starting with exponentials, right? Every one of these, there's not a word log in there, so we need to do logarithms to solve. So, first thing I'm looking for here, I don't have any adding or subtracting going on, so I just need to use logs to simplify this. The base of the thing with the exponent is 2. So I'm going to do log base 2 to both sides. Now the goal of this is to cancel things out. So log base 2 and a base 2 exponential cancel, and my x comes down. And on this side I have log base 2 of 61. I would then use GeoGebra to evaluate to get a decimal. Let's move over here. So now before I can worry about this, I said I have a minus 6. So just like in algebra, we would do that first. So I would add 6 to each side, which is e to the y plus 3 is equal to 30. Now I have my exponential on one side, a constant number on the other. So we said this is that special case, so I'm going to do the ln of both sides. Cancel, and I get y plus 3 is equal to ln, or log base e of 30. Opposite of adding is subtracting. So notice the syntax here. So that y equals the natural log of 30 in parentheses minus 3 on the outside. So to evaluate something like this in GeoGebra, we have the natural log, so log base e of 30 minus 3. Notice those parentheses. So here, my log. So base e of 30, and outside that, minus 3. And we get our answer there of 0.61. Alright, solving this one. Not adding or subtracting thing, but I have multiplying. So the first step here is going to divide. So here I'm getting e to the 4x is equal to, let's see, 5 divided by 5. GeoGebra. 19. Then I do my natural log right to give me that exponential. So then I get 4x equal to the natural log of 19. Getting rid of 4, so I would divide. So I know GeoGebra x equals the natural log of 19 divided by 4. So to get that answer, so we get a natural log of 19 divided by 4. So we got a log base e of 19. And outside it divided by 4. We get 0.78 for our answer. Alright, a couple more of these. And again, guys, the only way to get good at these is just practice. You had a bunch of them in your packets for a reason. Take your time, work through them, show every step. Alright, so here I have some multiplying going on, so before we go and divide that out. So I have 7 to the n equals, let's see, 148 divided by 4. 37. Now it's a base 7, so I'm going to do log base 7 on both sides. We get our cancellation, so n is equal to log base 7 of 37. Go to GeoGebra to get our final answer. I'm changing things up a bit on these two, so these are about as complicated as they're going to get. So we add or subtract, multiply or divide, and then use our logarithms. So right here I have a constant term up front, it's a positive 12. So I'm going to subtract that from both sides. And then bring this whole thing down, so negative 4x up to the x, negative 4 up to the x plus 1. Subtract it with 6. Now, before I can do a logarithm, it needs to be a positive base. So if I have a negative out front, to make it positive, I'll divide both sides by negative 1. So now I have positive 4, the x is equal to negative 6. Now, our logarithms, right? So I would do log base 4 on both sides. So I get x plus 1 equals log base 4 negative 6. Stop right there. We have a negative in the parentheses. We can jump right to our conclusion that this is undefined. Even if you didn't notice at that point, when you type in GeoGebra, it'll still give you that undefined solution. One more to go over here. So we add or subtract, multiply or divide, logarithms. So here I'm going to add first to get that negative 8 out of the way. I have 5 times 10 to the 3k minus 3 equals 40. Next step, dividing by that coefficient out front. So I'm never dividing by the base, we use logarithms for that. But if there's a number out front, we divide. So I have 10 to the 3k minus 3 is equal to 8. Now, using my log base 10 on both sides to get rid of my exponents, I have 3k minus 3 is equal to log base 10. Okay, now we could go ahead and evaluate that now to get it, but I'd suggest waiting until the end. That way it gives us a perfectly rounded answer. This should take us back to some algebra 1 type stuff, so I'd add 3 first to each side. So I'd get 3k is equal to log base 10, 8 plus 3. And lastly, I need to divide. So dividing by 3, now the trick here is how I'm writing this. I'm dividing this whole thing by 3. So with some nice parentheses here, we want to use parentheses on the top to tell GeoGebra that this is all one part. then we're dividing by 3. So in GeoGebra, log base 10 of 8 plus 3 divided by 3. So log, let's throw a parenthesis in there at the start, so now log is 10 of 8 plus 3. And outside our parentheses, so my nice parenthesis there on the outside, divided by 3. And we get our answer of 1.3. Given a logarithm or a natural log here, and we want to use exponentials. So if I start with a log, I use exponentials. If I start with exponentials, I use logs. So I have no base here, so that means my base is 10. So I'm thinking of doing 10 up on both sides. Hint, hint, we cancel. X minus 4 is equal to 10 up to the second power. I'd add 4 to both sides, and x is equal to 10 squared plus 4. And evaluating in GeoGebra. To get the up to symbol, hold shift and press number 6. So 10 up to the 2 plus 4 equals 104. Moving on. Alright, so just like with our exponentials, we think of our order. So add or subtract, multiply or divide, and then there's that step where we either use logarithmic or exponential properties to simplify. So I'm not adding or subtracting anything, but I am multiplying by 2. So first step here, I'm going to divide. So I have log base 3. And I like to put parentheses around this stuff. If you have trouble finding the parentheses, I can help you. So if there is no parentheses, assume that whole thing's inside of it. We'll see in other examples where they have parentheses and then some other stuff. And then that's equal to 4. So you divide it by 2. Now our base here is 3, so I'm going to do 3 up on both sides. And that gives me 5x is equal to 3 to the 4th power, dividing by 5. So x is now equal to 3 to the 4th power divided by 5. So in GeoGebra, 3 up to the 4th divided by 5. Here they give us a nice fractional answer, which is also cool. So whether you get decimals or fractions, either way I'm totally fine with it. So GeoGebra gives, so let's leave that easy. If you need help rounding later, I can have help. Essentially, you would just retype it in GeoGebra. So you just type directly 81 divided by 5. It would give us our decimal. So either one's fine. So let's leave that as both. 6 divided by 2. Alright, checking out number 3 here. So in this case, we have a natural log. We're not adding or subtracting, we're multiplying out front here of it, so we can go right to our properties. So our base is e, so I'm going to do e up. So I got 8x is equal to e to the second power divide. And find x is equal to e to the second power over 8. So before we evaluate, there's one quick thing in GeoGebra. You've seen me run through a lot of these calculations. One thing you want to do in between each calculation is delete everything. So let's go ahead here. If you have more than one thing, you can hold the Control CTRL key and highlight them all. So I'll show you how to do this real quick. So then we just right click and delete. If I had just one thing, you can just directly right click and delete. You want to make sure you have this Alt key clear before you do each one of these problems. Otherwise, some things get confused. So to evaluate this, e squared divided by 8. I'm just going to go ahead and type that in. So e squared divided by 8 gives me my answer 0.92. Now the point in clearing this out is if you don't have it cleared out, for some reason it has a variable, e is another number, it uses that. So just always make sure you have it clear. So after each calculation, I'm just going to do it. Alright, moving on over here. Okay, so add or subtract. That means I got a 1 out front. You know, and let's challenge ourselves as much as possible. Let's put 3 out front. Okay, so as long as these problems again, I add or subtract first, so I'm going to subtract that 1. So I have 3 log base 4 2x plus 5. So these are those parentheses I'm talking about. If they want things inside them, we'll show them inside. Now I have a 3 out front, so I'm going to divide everything by 3. subtract 5 from both sides and divide by 2, which I get x is equal to. For my subtracting portion here, I'm here. So remember, and then we're dividing everything by 2. So we get those nice parentheses. Now, let's add this one to together. So we have 4 to the 2/3 minus 5 over 2. So I got it clear. So now I'm going to put some parentheses to take my top. 4 up to. Whenever you're raising it to a power of a fraction, it needs another set of parentheses. So 4 up to the 2/3. And then we had minus 5. All divided by 2. So take a minute right now to make sure yours looks exactly the same. This is something I would suggest writing down on paper while we're doing this. Is how I'm typing this in. We got our answer of negative 1.2. Let's do both of these. So here I have logs on both sides. You'll notice in all these problems that we do, the bases are going to be the same on both sides. So no real new tricks there. So the base is 10, so I get 10 up on both sides. Here they both cancel. So I get 5x minus 1 is equal to 3x plus 5. Solving, I would subtract 3x from both sides, so I'd have 2x minus 1. This should all look really familiar back in algebra. I'd add 1 to both sides and get 2x is equal to 6. Divide by 2 and I'd get x is equal to 3. Here, same thing, base is 10, so we get 10 up. I get 2x plus 15. Now notice, I'm only doing this where it cancels on both sides because both sides have logarithms. As we've seen before, that's not always the case. Now if I have just a variable, there's nothing there, so it's a 1 on the front. So I'd subtract 1x. And I'd get x, or 1x plus 15 is equal to negative 1. Subtract 15. Divide by 1 if you have to. If not, you know that this is the case here. These ones can be left up to practice if you choose to do it. I'll leave that there. You can pause right here if you want to take these problems. Alright, moving on. We're going to knock out some word problems here so we figure out how exactly we can put this in the context of the problems. So here we have the pH of a liquid is a measure of how acidic or basic it is. Concentration of hydrogen ions in liquid is labeled H positive. So that just means that's our variable, H positive. Use the formula pH is equal to H positive, or the negative log of H positive, to answer these questions. So here, we have find the pH of the nearest tenth of a liquid with H of this. So this is this. That means I'm just plugging it in. So I'm finding my pH, and it's equal to negative log of 7.2 times, that just means times, 10 to the negative 4. So let's go ahead and type this one in the calculator. So negative log 7.2 times 10 to the negative 4. So I have negative log. And we are base 10, so we clarify that 10 of 7.2, and then to get the times, we hold shift and press the 8 key. 10 up to, and again, it's a negative, so let's throw some extra parentheses. Ensure you have this in your notes. Press enter, and we get 3.14. So we're not going to worry about the places to write. We'll just go with whatever algebra gives. Here, this time we're given the pH. So we have the pH of 3.1 is equal to the negative. You can write H positive. I'm just going to write H. It means the same thing. Now, remember we have that negative in front, so we divide both sides by negative 1, which gives me negative 3.1 is equal to log, and then we have a base, so it's base 10 of H. To get H by itself, I do with 10 up. So I have 10 to the negative 3.1 is equal to H. GeoGebra, answer. These ones, same exact thing, just different numbers. So I'll leave those up as optional practice. If you would like to do them, I'd be happy to check them for you. They should be pretty much identical to what we found there. So same strategies, just different numbers. So this one would be a plug-in, this one would solve just like the first one. Alright, another one that's very similar to the test questions here. So we have loudness. L is measured in decibels. The formula for the loudness of the sound is given by L equals 10 log I over I sub 0, I naught. It says I, so the capital on top is the sound. I0 is the intensity. And they tell us here I0 is a constant. That means we can just kind of plug that in. So they're just challenging us to read it in the problem. Okay, so here, this gives us our I. So I is this number. We want to find L, loudness. So this is another plug and chug type question. So we have 10 times log. And there's no base, so it's base 10, right? Because there's no base there. And then in our parentheses here, this is where we get some more parentheses going on. So on the top I, I'm plugging this in. So when we plug this in, think about plugging these in with their own set of parentheses. So 4.91 times 10 to the negative 2. And then we're dividing by our bottom. So that 10 to the negative 12. So type this one in together. So we have 10 times log base 10, 4.91 10 to the negative 2. All divided by 10 to the negative 12 and our parentheses. So let's go ahead and start this one. So let's delete what we got, right? We always talked about doing that. So I have 10 times log. Our base is 10. Here's where our equation goes. So here's what's in our log, right? So we have parentheses 4.91 times 10 to the negative 2. So parentheses 4.91 times 10 up to negative 2. And then I'm still in this chunk. So I'm going to go ahead and throw in a divided by 10 to the negative 12. So divided by 10 up to negative 12. You'll check too, if you have ugly, unnecessary parentheses, they'll show up as red. So always make sure you have green. If you're confused on that, again, reference your notes, talk to me. So take a moment right now and make sure you have this exact same thing right in your notes. Okay, awesome. Let's go ahead and press enter. There's our answer, 106.91. And we're good to go. One more of these here, so it tells us our intensity. This one's fine for loud, so this would be the same kind of thing here. We can just plug it. So the only thing different is now this number would be in place of this one. Here, same thing. This number would be in place of this one. So I'll leave those up for a minute if you'd like to do that optional practice and check in with me. I'd be happy to help you. Here, same setup. The only difference is they wrote it a little different. This is going to be the same type of problem as I divided by I subject. They give us all that information. So we're actually going to skip all this one. And let's do number 4 here. So the only real difference here is they give us a different form of the logarithm. We know how to work with that. So 1 year or 5 years, we'll write out both of these. We'll just plug it in for 10 years. So 4,300 times natural log 2 times 1 plus 7. Or if I want to do this one in 5 years, it's 4,300 times natural log 2 times 5 plus 7. So let's go ahead and do the second one here. So let's go 4,300 times 5%. Okay, so in here, let's delete what we got. So I have 4,300 times, remember our natural log here, so base E. Now in this part, when it's numbers, we can just type them all. If there's no weird exponents or anything, we just type it. So 2 times 5 plus 7. So 2 times 5 plus 7. Take a moment, make sure you have that exactly as I had it. And there's our answer. So 12,182.82. exponentials. So to shortcut things a bit here, we're actually just going to use GeoGebra for this unit. Alright, so the big idea is growth or decay. If B, so if our base here is greater than 1, it's growth, meaning it's going to go up. If it's less than 1, decay. Other than that, let's go ahead and go to GeoGebra to get some graphs. So real quick, let's growth or decay. Base is 3, growth. 4 over 3, that's bigger than 1, so growth. 1 over 4, less than 1, decay. 1 over 2, less than 1, also decay. Again, if you're not sure what those decimals equate to, GeoGebra will give us those approximations. So 4 over 3 is 1.333, 1 over 4 is 0.25, 1 half is 0.5. So again, just type those into GeoGebra if you're not immediately sure if they're bigger or smaller than 1. Alright, so growth or decay, as I look from left to right, it's going up. Growth. From left to right, we're going up. Growth. From left to right, I'm going down. Okay. Go ahead and ask me. Left to right, it's going down. Okay. Alright, domain and range. So the domain for every one of these is going to be so just like in our previous lessons, these are all numbers for every domain with exponentials. So all the exponentials are always going to work. Now, our range is a little tricky. So here, I see this line that it appears I'm crossing, but I don't actually cross, is going to be at y is equal to 0. So my range is from 0, and I'm going up forever, so to infinity. Here my range, I say I don't cross that negative 3, but I still go up forever, so to infinity. Here it's positive 1. I'm going up, infinity. Here I don't cross negative 4, and my equation still goes up. Infinity. Our asymptote's pretty easy to write. They're always going to be our horizontals, so they're all going to start with y equals. And it's just that number from our range. So here it's 0. We never put infinity in here. Here it's 1. Here it's negative 3. And here it's negative 4. Let's go through some end behaviors real quick. So we still think of those as positive, negative infinity, positive, negative infinity. So, this top one, as we go to the right, y goes up. As we go to the left, our asymptote comes into play here. 0. This one, as we go to the right, it goes up. As we go to the left, asymptote comes into play. This one, as I go to the right now, I'm not crossing that line. So that's where my asymptote is. Whereas when I go to the left, I'm going up, so it's infinity. Same thing here, as I go to the right, our asymptote. But as I go to the left, it goes up, so infinity. Take a minute now and ensure you have all of that down. So I will pause the video at this time. Moving on. Alright, graphing. Cool part here. So we want to graph 2 up to the x plus 5. Alright, so as we're graphing this, we have 2 up to the x plus 5. So in GeoGebra, we're just going to type that. Here you make sure you use lowercase f, so 2 up to. We always put parentheses around that exponent, so just x up there for this one, and then outside, plus 5. Press center, there we go. So we can go ahead and graph that. You see it should cross here at 6, it's going up this way. It never crosses that line 5. So we can recreate that pretty quickly in our graphs. We'll do this one as well. So 1/3 up to the x minus 2. So tell me what you have. Now, every time I have a fraction base, I'm going to throw parentheses around there. So 1/3 up to the x minus 2. Take a moment, make sure yours looks exactly the same. Center. And again, we can recreate this graph. So notice I'm just left clicking to move around here, dragging my graph. So I see it never crosses the line -2. It's going through -1 here. It goes up to the left. It stays flat to the right. So again, very easy to recreate. And each of these can be done the same. There we go. Let's do one more of these here. So let's try a little more challenging one. So it's 1/2 times 3 up to the x plus 1. So fraction, I always put here, so 1/2 times 3 up to the x plus 1. It looks the same in notice GeoGebra. Their output should always match how this looks. So if it looks different, we did something wrong. And again, our graph is to recreate here, so we would do we don't cross here at 1, up to the right. Looks like we're in between 0 and 1 here. 1.5. Alright, so let's move down here. Okay, here we're going to work with logarithms. We're not going to worry about the transformations. Let's go right into talking about graphing. So for this one, we see our domain is our first question here. Now domain, we'll notice with exponentials, our domain was all real numbers, but our range changed. Here it's the opposite. So our range is always going to be all real numbers. So anytime we have a logarithm, our range is always all real numbers. What's going to change is our domain. So if I'm looking here, it looks like I never quite get to x is equal to 1. That's where that line goes down. So my domain is 1. But I can go right forever, so to infinity. Here it looks like I'm never crossing that 0. So it's from 0 going right to infinity. Here it looks like I'm not crossing -4. But I can go right forever to infinity. Here I'm not crossing -4 again. But I go right forever to infinity. So our asymptotes with those exponentials are always y equals. These ones are vertical lines, so they're always x equals. And where are we going to get that number from? You guessed it. The non-infinity number in our domain. So it's 1, -4, 0, and -4. And behavior, let's go ahead and throw in our positive and negative infinities like we've done in the past. Alright. So as I go to the right, I'm going up. As I go to the left, I'm going down. As I go to the right, I'm going down. As I go to the left, I'm going up. To the right, I'm going up. To the left, I'm going down. Right, I'm going down. And to the left, I'm going up. By this point in our time together, this should be very easy for us to do. So take a moment now, pause your video, and make sure you have all of this down. Alright. Okay, so graphing, you guessed it, GeoGebra. So I have log base 4 of x minus 1. So let's delete what we got. So I have log, my base is 4, and inside of those parentheses, x minus 1. Press enter. Does it look the same? It does. It has the parentheses, so here we see it's going through 2, up to the right, down to the left, we're not crossing 1. We're good to go. Let's write our number. So let's do 2 log x plus 1 minus 3. About as crazy as they're going to be. So 2 log x plus 1 minus 3. Let's even get a little more wild. Let's get a weird base. Like base out was 3 here. Let's go to base 3. That's 2 log base 3 x plus 1 minus 3. So 2 times log base 3 of x plus 1 minus 3, so plus 1. And then outside of those parentheses, minus 3. Enter. I would quickly do a visual inspection here and make sure that that is exactly the same, which it is. And we have our graph. So it's going to cross at 4, doesn't cross over that negative 1 asymptote, goes through the y-axis at negative 3. We're going to go. So then recreate that graph. And we're not going to do anything else with this unit. So at this time, you've completed these notes. Ensure you do every single practice problem. That's the only way to ensure that we are ready for this exam. As you've completed that, make sure you check the answer key, asking all the questions you have. Prepare with a review as a class, and then we'll move on to our exam. Alright, this is going to be Unit 5A in our notes here. The key idea is working with and solving polynomials. So here, a polynomial is essentially an equation that can be varying in degree. So degree just refers to the highest exponent. What we're going to go through, we'll skip through this a bit here. For example, we see that this would be a degree 4 polynomial. It's because the highest exponent is 4. We're going to go through and just kind of start with solving. So there's a lot of different techniques, so make sure you're taking detailed notes on each one. Alright, for these first ones, these are dealing with grouping. So key things that tell me I need grouping is notice I have 1, 2, 3, 4 terms. If you look at each of these examples, each one of them includes 4 terms. You'll also notice that the highest exponent is 3. So whenever we see that our highest exponent is 3 and we have 4 terms, that's a key indicator we need grouping. So for grouping, we put parentheses around the first 2 and the second 2 terms. So I'm going to go ahead and do that now for each of these. I would suggest pausing the video and taking this time to write it out now. There. So let's start with our first one. The key idea here is we're going to work with our first term and get what we need, then match the second one to it. So if I look for what's in common, I look at the coefficients first. I have 2 and 5. Nothing besides the number 1 divides 2 and 5, so I can't take anything out there. I do notice, though, they both have an n. The smaller of those exponents is squared. That lets me know what they have in common is n squared. So what's left, I'm thinking about dividing each of these by n squared. So I have a 2 left, and if I'm taking out 2 n's, that means I have 1 left. Here I have my 5 left over, and I took out 2 n's, so there's none left. Now, I need to match my second term with this one, so it's 2n plus 5. So, what that means is I need to take something out of here that makes those numbers change. Well, if I think to get 2 from 8, that means I'm dividing both of these by 4. It's a positive 4, so I'm factoring out plus 4, and I'm left with 2n, dividing here, plus 5. From here, we only have one step left. So whatever my parentheses are, they need to be exact matching. They are. So I'm going to go ahead and write that first. So I have 2n plus 5. And now I'm going to create my second factor from these 2 terms. So I have n squared, and it's positive, and then plus 4. And that would be how factor. We'll do number 2 last. Now, in this example, we notice that something divides 20 and 5. The answer, what does, is 5. I also notice I have an x third and x squared, so I can take out x squared. When I divide these, well, 20 divided by 5 is 4. I took out 2 x's, so I have 1 left. Here, I took out a 5 and x squared, so that's just leaving me a positive 1. Now I look, this happens to match up exactly. So if I have an exact match, that's just like having a plus 1 out front, because there's nothing in common. I notice they match up, so that's my first term, 4x plus 1. And then my outside terms make up my second set, so 5x squared plus 1. Back up here to this example. Between 25 and 5, I know they're both divisible by 5. Similarly, I could take out that x squared. So that would leave me with 25 divided by 5. And then 1x left here. Negative 15 divided by 5 is minus 3. have two x's, so I'm good. Now, I'll notice my leading term here is negative, but in this one it's positive. That lets me know I need to divide by something or take out something negative. To get 20 from 5, that would be dividing by negative 4. So if I divide both terms by negative 4 and take it out, that would give me my 5x minus 3. Now that they match up, I can rewrite my final answer. So 5x minus 3, 5x squared minus 4. Pause the video at this time and make sure you have all these notes down. We're actually going to see these two. Alright, so when we deal with quadratic trinomial, here what we're dealing with is our standard type of factoring. So we notice our leading coefficient, or our highest coefficient, is squared, such as a power of 2. All of these are going to be very similar, so we're going to go ahead and draw a diagram up here of what we're going to use. So in general, if I look at a quadratic equation, it follows this form. So the diagram you'll see me utilize each time will look like this. We set up our sides as over A. The top is A times C, and the bottom is B. So we're thinking about adding. These two terms need to add to B and multiply to AC. And the terms I'm referencing are just the top of these fractions. We'll see what we use the fractions for in a second. So for each one of these, the first thing we're going to do is identify our A, B, and C. There's nothing out front here, so it's like A is 1. Here in front of my x is A minus 4, so B is negative 4, and C is 3. Here out front of my x squared is 2, my B is negative 8, and my C is negative 10. Here, there's nothing in front of either of these, so I put a 1 there as a placeholder. Take a moment and pause the video to make sure you have all of this written down. Alright, so once we've identified those, we can create our diagram for each of these. So my side terms are over A, so they're over 1. The top is A times C, so 1 times 3 is 3. And the bottom is just B, and we're thinking about adding to it. So let's go ahead and create our diagram for each of these now. Here's over 2. 2 times negative 10 is negative 20. And the bottom is negative 8. Lastly here, my A is 1, so over 1. My top is 1 times negative 4, and my bottom is negative 1. Alright, so let's start here with number 1. Now, a great way to do this is using GeoGebra to check your factors. I'm just going to verbally say what you should be checking. So I want to multiply to 3. So to find out ways I can multiply to 3, I would take 3 and start dividing it by 1. You'll notice through this process, if you check each number, so you take your top number divided by 1, divided by 2, divided by 3, divided by 4, so on and so forth, you will eventually arrive at the answer, and hopefully get quicker over time. If you ever receive a decimal, so say I tried 3 divided by 2, I would get 1.5. I know that that's not a factor solution, because these are only going to be whole numbers. So for here, we check, and we want to think our way through this. So I get 1 and 3 when I divided it by 1. Now before we get to that, let's think about what this bottom number tells us. So I have a positive here. The only way to multiply and get a positive number is either use 2 positives or 2 negatives. Now let's say I went with 2 positives. Is there any way I could then add and get a negative 4? The answer is no. So that logical step tells me both these are negative. So then when I check, well, I get negative 1 and negative 3. If I add those together, that gives me negative 4. So in either order, you can put the negative 1 here or here, it doesn't matter. These are our factors. So let's go through now and get each of those factors down. Let's check out number 3 here. Oh, that should say 42, so let's make that say 42. Alright, so here I have a negative on top and a positive, or a negative on the bottom. Now, this is a big thing. Whenever we have a negative on the top, we know that there's one specific scenario. The only way to multiply 2 numbers and get a negative is exactly one of these is negative. So if you ever have a negative on top, you can say one of these is negative. Doesn't matter which way we mark it. I always just put it in front. So as I'm checking these, I'll do 1 divided by 42. There's no way I'm going to add those numbers and get negative 1. We check 2 and we get 21. Well, if I add those and see which one's negative, still not close. We keep going through and eventually we arrive by dividing by 6, and I get 6 and 7. So if I want it to be negative 1, I would try negative 6 plus 7. That gives me positive 1. But if I do negative 7 plus 6, that'll give me that negative 1. So again, just make sure you mark the right one negative. Moving on to here. Now we'll notice there's a 2 on the bottom here, but it doesn't change how we find these numbers. So I have a negative on top. So again, just like before we talked, that means one of these has to be negative and one has to be positive. So as I go through this, I'll divide it by 1. 1 and 20, those don't work. Divide it by 2. Okay, so I did 10 plus negative 2, I got positive 8. So if I do negative 10 plus 2, I'll get negative 8. Alright, now that we've done that, here comes the part where we write up our answers. So, let's use our variables. We have x minus 3 over 1 and x minus 1 over 1. Now I check, do these reduce? So 3 divided by 1 is just 3. Here, 1 divided by 1 is just 1. So at that point, we're done. We've successfully factored our polynomial. Here, I have x minus 6 over 7, or 7 over 1, sorry. And then x plus, because it's positive, 6 over 1. I check, both of these reduce, so it's x minus 7 over 1, or just 7. And here it's x plus, just 6. Moving up here, x minus 10 over 2. X plus 2 over 2. So we check, they do reduce. This one reduces to just 5, and this one will reduce to just 1. So since they all reduced, take a moment now, pause the video, and ensure you've copied down all of these notes. Now, one thing we didn't talk about in the previous example, which we'll have to hit on here, is what's known as the GCF, the greatest common factor. Basically means if all my terms have something in common, I have to factor it out. That's what's letting us use that little trick I showed you above where we divide by a and save ourselves some time. So if I check here, nothing divides 6, 17, and 14. So we're good there. So that means we can go right to our diagram. So my a is 6. I'm assuming you've already written these down at this point, so I'm not going to label a, b, and c. But if we wanted to, there's a nice little shortcut. So my b here is negative 17. My a, that's 6 times 14, so that's negative 84. So let's go ahead through now and set up each of our diagrams. Pay attention that you're marking those negatives if you see them. So notice I'm checking for that GCF. So here, nothing divided all those. But in this case, you know what, let's finish the first two, then we'll go on to number 3. Alright, so we have our diagram set up. So let's go ahead here and solve these. So I want to multiply to negative 84, add to negative 17. So I can tell, since it's a negative, on top, one of those has to be negative. Now, to find our values. So, how I can use GeoGebra to find these factors is I'm going to go ahead and start dividing. So, start dividing here. We want 84. Let's see if I divided it by 1. That gives me 84. Not going to be 12. Let's try dividing by 2. So, 2 and 42. I don't think I can add those and get 17. So, let's keep trying. So, I have 3 and 28. It's getting closer, but not quite there. So I have 4 and 21. Well, I think those are pretty close together. So let's try. I I know I need one of them to be negative. And I want my final answer to be negative 17. So let's try negative 4 plus 21. It's positive 17. If I did negative 21 plus 4, that gives me my negative 17. So I have negative 21 and positive 4. So for my answer, x minus 21 over 6 and x plus 4 over 6. So, to check if these reduce, we're going to use GeoGebra yet again. Now, this is something really important. I'm going to show you a command in GeoGebra that reduces everything to their best version of their fraction. Here's the ones we're going to need. So we have 21 over 6. To do that in GeoGebra, we're going to type up here and start typing the word fraction. Once we get here, we want the second option, which is fraction text. So I want 21 divided by 6. Take a moment now and make sure you write down that command exactly. Pressing enter, we see that that reduces to 7 over 2. So I have x minus 7 over 2. Using the same exact command here, you'll find that 4 over 6 reduces to 2 over 3. Now, before these always reduce to these numbers, so now we're going to use another little trick to get our final answer here. So this saves us again all that group factoring that we used to have to do. Since I've already reduced these, I can now take the bottoms and bounce them to the front. So this gives me 2x minus 7. This one, 3x plus 2. And that's our final answer. Let's move on to number 2. So I check, nothing divides 3, 22, and 4. So I can go ahead and start factoring. So I want to multiply to 72 and add to 22. So let's go ahead and clear out what we have in here so we don't get confused. So I'm just going to highlight all these. And again, you can just delete these one by one. Alright, so we want to get multiply to 72 and add to 22. So let's start 72 and 1. Not going to work. 72, 2. Still not going to get us to 22. And again, I'm thinking here that they need to be both positive because they have a positive on top, positive on bottom. So these should be pretty close together. So let's try 72 divided by 3. Go. So 4 and 18, those will add to 22. So 4 and 18. I'm checking my reducing. 4 over 3 doesn't reduce. But 8 over 18 over 3 does, it's just 6. So again, GeoGebra. Reduced, so now we bounce out the front if there's anything left. So 3x plus 4, x plus 6. Again, you can pause at any time if you need to. Alright, we'll skip this one and just do one more again. So here, first thing I notice is I have 6, 15, and 9. All of those are divisible by 3. So that means I can factor out the 3, and I also notice they all have an x. So I can take out an x as well. That gives me 2x squared minus 5x plus 3. So now, this is something that's going to stay up front. This is where I use factoring method. 2, add the negative 5, multiply 2 times 3 gives me 6. So it's a little bit of checking here. I know that I want to multiply to a positive and add to a negative. So the only way to do that is with both of these being negative. I check through, I'll find negative 2 and negative 3 do the trick. So I still have that 3x out front from up here. I have x minus 2 over 2 and x minus 3 over 2. I write down my 3x. This one reduces to just x minus 1. Here, it doesn't reduce, so I know I'm going to slide it out front to get 2x minus 3. And there's our answer there. Make sure you have all these notes down. Let's do one more of those together here. We have to take out the GCF. So I notice these are all divisible by 2. And they all have an x, so I can take out 2x here, and that would leave me with 6x squared minus 6x minus 16. Now I look again and realize these are all even again, so I know they're all divisible by 2 again. So if I take out another 2, well, that's 2 times 2, so that gives me 4x. And then dividing each of those by 2, we get here. And again, if you realize these are all divisible by 4, you can skip that portion of the problem. So let's see what we got here. We're going to divide by 3, because that's my a. Add to negative 3, multiply to negative 24. Well, let's see what we have. We have 12 and 2, 6 and 4, 8 and 3. From this, we'll be able to check and see that we can't actually factor this any further. So since we can't, that's our final answer. Alright, here comes some special cases. So we're thinking about difference of squares, perfect square trinomials, and sum and difference of cubes. The first one to start with here is difference of squares. So what this means, difference refers to that we're subtracting in the middle. So you'll notice in each of these, we're subtracting. Here it's adding, so we're just going to go ahead and skip over that. Now what a perfect square means is that if I take the square root of a number, it comes out as a nice whole number as well. So here our general pattern for these. If I consider my first term a and my second term b, because I want a minus b, a plus b. Now to find these, we take the square root of each of these terms. So notice I'm ignoring the subtraction sign. So the square root of x squared is just x. The square root of 25, which we can find in GeoGebra, is just 5. To do the square root in GeoGebra, I would start typing SQRT, hit enter, and then just put the number. So if I want 25, that'd be there. Make sure you type this down or write this exactly as you have it. Pressing enter. You see our answer is just 5. So again, GeoGebra will do the math for us. Now that I take the square root of each of these, I can write my answer. So we said my x here, or my a is just x, minus b, and then x plus b. Let's try this one here. So I'm going to find my a, so I take the square root of both of these. So the square root of 16 is 4, square root of x is x. When you do that part in GeoGebra, you cannot put the x squared, but you'll have to just put the 16, and then know it gets both parts. That b, the square root of 49 is going to be 7. So this would be a minus b, a plus b. Here, my a, I take the square root of 9 is 3, and I get my x from the x squared. My b squared root of 100 is 10. So a minus b, a plus b. Those are our answers there. So these ones are a little more challenging to find. Essentially, there's something we've already done. We're just going to write the answer a little bit different. So we notice this is similar to what we've done before. We have 3 terms, the leading coefficient is a square. So I look. I have nothing that divides 1, 8, and 16. So we go right into our factor limit. And through process of elimination, here I'll find 4 and 4. So similar to what we've done before, let's go ahead and write this up. Reduce. Now, here's where the difference comes in. Since these two terms are exactly the same, what I can write it is write it once and just say it's squared. Now that's literally the only difference in this. Since they're the same, we just write it once and say it's squared. Let's try here. Okay, so we have nothing, and we can factor out, because I know nothing divides 9, 30, and 25. So let's go ahead here and set up work. And multiply in GeoGebra, that gives me positive 225. So take you a few more because the numbers are a bit bigger. But we'll notice eventually we get to negative 15 and negative 15. Because I had a positive on the top, so either both were positive or both negative. And I want to add to a negative, so I said they were both negative. So I have x minus 15 over 9. I'd find out they reduce, so this would be x minus 5 over 3. This would be the same. We noticed then we could throw it up front because we reduced. And lastly here, since these two terms are exactly the same thing, we just rewrite it. Do one more together. So, I notice these are all divisible by 5. So that means I can take a 5 out. That would give me 25x squared minus 10x plus 1. So there's some trial elimination here. We'll find minus 5 as our answer. We should keep this 5 out here because we factored it out. Do this what we can. Should all look close. Pretty familiar by this point. And lastly, since these two match, we can rewrite them as just squared. Alright, should have it down from there now. Alright, moving on now. So here we have sum and difference of cubes. So first thing we notice is different is these all say cube. We use a really similar pattern though to how we found the difference of squares. The only thing here is with cubes, we can have either adding or subtracting. So we're going to use this acronym SOAP. So, in general, our patterns go something like this. A and B. A squared. AB. B squared. Those parentheses I'm putting in seem extra right now, but they'll make sense momentarily. And the SOAP part stands for same, opposite, always positive. So I would write those down. S stands for same, O stands for opposite, AP stands for always positive. And that deals with our signs, whether we're adding or subtracting. So first thing we're going to do is kind of set up our diagram here. So I see I have a cube term and just two terms. So whenever we have this, we know we're going to use some variation of 2 numbers, 3 numbers. So the same sends to the sign that we start with. So same, opposite, always positive. And again, you'll notice that spacing will fill in those blanks here in a second. So my A term comes from taking the cubed root of this. So I'm thinking of x to the third to the 1/3 power. So third and 1/3 cancel out, so that's just x. For my B, I'm thinking of 216 to the 1/3 power. To do that in Ciolkosz, I have 216. Hold the shift key and press 6 to get up to. You'll notice I have those parentheses around 1/3. If you do not do that, you will get the wrong answer. So please make sure you write this down exactly as I have. So we press enter and we find out our answer is 6. Now we're just filling in. So A and B, x and 6. That says A squared, so x squared is just x squared. And A times B, so x times 6 is just 6x. Last thing, B squared, well 6 squared is 36. And that's our answer for that one. For this one, we're going to rewrite it. We always want to put our x up front here. So for my a, notice the same pattern as above. That's just going to be an x. For my b, if we take the 1/3 root, we'll get 4. So setting up our diagram here, same. So it's a plus sign. Opposite, always positive. So a and b, a squared, ab, and then b squared. Here we'll find our pattern is a minus, so we have same, opposite, always positive. Remember, we'll find a is x, b, we'll take, notice I'm just going to use regular a here, so to ignore the negative, that just tells us how the pattern goes. So a to the 1/3 gives me 2. ab, a squared, a and b times each other, and then b squared. Set up our pattern here. So we have the same, opposite, always positive. Now here when I do my a, I want to do this in 2 parts. So I'm going to take 24 up to the 1/3, and x to the 3rd up to the 1/3. So I do this in GeoGebra. You know what, let's switch this. Let's make this say 64. So then for my leading term here, we'll find 64 when there's 4. X to the 3rd just gives me x. My b here, 81 to the 1/3. Sorry. Let's actually make that 81, let's say 27. So I'm going to do 27 to the 1/3. And we'll get 40. So here's my a. B is just 3. So it's a squared. So 4x squared would give me 16x squared, because I squared both terms. In the middle, 4 times 3 is 12x. And then b squared, just 9. Let's do one more of those together. So here, my a, I'm just taking the 3rd root of each of these. So that would be 3x. For my b, I'll end up with 5. So setting up my skillet here, same. Opposite, always positive. So I have a, b, a squared, so that's 3x squared, so 3 squared is 9, x squared is x. A and b, that gives me 15x. And then b squared would be 25. At this time, make sure you have both b's down. I would suggest pausing the video. Alright, we're moving to finding the zeros, also known as roots or intercepts, and we're going to go ahead and solve. So, the game plan here is we have a couple different ways to solve this. We can use factoring, we can use what's known as the square root property, and if all else fails, we can use quadratic formula. This last one we'll talk about later. Alright, because firstly we're given the directions of solving by factoring. So since we already know this, we're going to kind of move a little quicker here, and I'm not going to explain as much because we've already touched on how to do this. So I'd factor out that 2 because they're all divisible by 2. And then if we factor our inside here, through our process of elimination, we'll find our answers here. 2. And again, you would go through your reduction steps as we've shown before, but I want to focus on solving. So, one thing to notice here is just having just a number out front doesn't actually change one, so we can actually ignore that when we solve. What I'm going to think of is taking each of these terms and setting them equal to 0. So x plus 6 equals 0. X plus 1 equals 0. I would add 6 to both sides. It's 6. You add subtract 1 from both sides and get negative. So those are our solutions. Taking number 2 here, we see all these terms are divisible by 3. and they all have an x in common. So I can take out an x. So those are not all divisible by 3. I'm going to say they're all divisible by 2. X, so 3x squared. Now I have 2x out this time, so we'll add one more step in here for us at the end. So let's go ahead and factor first. So we'll find our factors here. And follow your steps you've already learned for reducing these when we factor. And you should end up with this as your factor form. Now we'll notice we have 1, 2, 3 x's here, so we're actually going to have 3 equations to solve. So the first will just be that 2x squared equals 0. And the second will be 3x plus 8 equals 0. And the last will be x plus 1 is equal to 0. So solving the first one, we would divide by 2 on both sides and get 0. Solving this one, I would subtract 8 on both sides, have 3x is equal to negative 8. Divide by 3. And we find out our final answer is negative 8 over 3, or an equivalent decimal. Our last one here, we just subtract 1 and get negative 1. If you're having trouble remembering how to solve this, please ask me and I'll be sure to help. Alright, one more of these. So we notice here we have a negative out front. So we never want to have a negative out front if we don't have to, so let's go ahead and see if we can take some stuff out here. But we notice they all have an x, so I can take out my x. And that gives me, you know what, let's get rid of that negative as well. So if we pull that negative out, it's like taking out a negative 1. It's just going to change all of our signs here to make the factoring a tad bit easier. So by factoring out the negative, I can just switch all the signs. So this becomes positive, becomes negative. And then our factoring. We see a negative, so we know 1 has to be negative. And through some work, we'll find these are our factors. So I bring down the negative 1x. Through the simplification process we've discussed, we have this as our factored form. And if I set each equal to 0, I'd have 3 different equations. So I'd have negative x is equal to 0. 5x minus 3 is equal to 0. I'm going to go ahead and try to work in solving these at this point. So for this first term, we divide each side by negative 1. I get x is equal to 0. Here I would add 3. I get 5x is equal to 3. Divide both sides by 5. X is equal to 3 over 5. Here we subtract 1 and get x is equal to negative 1. So those would represent our 3 answers. Again, you can check to see if this reduces in GeoGebra using fraction text, which you'll find it does not. Alright. These will be left up to optional exercise. If you would like to do them, I'd be happy to check your work with you or work through them with you. Alright, moving on here to our next concept. We have solving with the square root property. This will be a bit of a review here. I squared, for future reference, is equal to 1. And the square root of negative 1 is I. It's known as the imaginary number for complex numbers. We're not going to use it a whole lot, so we're just going to kind of talk about how to manipulate it and not really worry about the theory as much. So how I know I can use this relates to how these problems look. So you'll notice I have a squared term and then some type of constant. There's no term with just an x. So take a moment and write all these down now. Alright, so again, just solving by square root property. Again, we talked about a squared x and then only one term that does not have an x. So to solve these are actually the quickest and the easiest in my mind. So I would add or subtract first. So I would add 36 to both sides, giving me x squared is equal to 36. I have nothing out front. So when I take the square root, the trick here is that I get both the positive and negative answers. And then if we break down our 36 here, so it's divisible by 2. So you'll notice this thing we show a lot with quadratic formula as well. When a number is even, we always divide it by 2 first. It's even again. Notice I'm writing all these prime factors. So prime numbers are like 2, 3, 5, and 7. There's a few others, but those will be our big 4. side. And then 9 is divisible by 3 and 3, and we can't break down any further. So simplifying here, I still have positive or negative. Now, if I make this pattern here, these are my factors, so I have a pair of 2's, so I can take 1 out of the square root, and a pair of 3's, so I can take a 3 out as well. That gives me my answer of plus or minus 6. So positive and negative 6 are my solutions. Here, following the same idea, we'd subtract 32 from both sides. Take my square root. And I get x is equal to the positive or negative square root of negative 32. Now, an additional step here, when we have a negative inside of a square root, we're not allowed to write that as an answer. To get rid of it, I simply take out an I. Give it a second. There we go. So I would take out I, and then I have a positive 32. That's the sum of how we deal with negatives inside a square root symbol. And seeing if we can break down 32, well, it's even. 16 is also even. 8 is also even. 4 breaks down to 2 and 2. So if I look at my prime factors there, so I broke everything down to prime, so 2, 3, 5, 7. I have 2 pairs of 2, so I can take out 2 2's. I still have my I, and what's left inside the square root is that additional 2. So my final answer would be plus or minus 2 times 4I. 2. When you break these down, you need to follow that exact same pattern. If not, this will become much more challenging for you. Here, we subtract 5 from both sides. I get my plus and minus when we do our square root. So that if x is equal to positive or negative square root of negative 5, we would take out our I. From checking, 5 is more than 9, so it doesn't actually break down any further. This one's a little different, so I'm going to subtract 81 first. Then I notice I have a 3 out front, so I'm going to divide by that before I do the square root. Now when I take my square root on both sides, and I'll get x is equal to positive or negative. And we know we're going to get the I out front, so let's go ahead and jump to that now. Positive 27. If I break this down, it's not divisible by 2, but I check, and it's divisible by 3. Which gives me positive or negative. I have 1 pair of 3's and a 3 left over, so the leftover stays inside. When we are solving by square roots, take a moment now and I'll show you how to put this down. Alright, one of our last big topics here is solving by quadratic formula. So we're only going to do one of these now and just do a very careful job of showing all the work. That way, when we go back and do it later, we'll see it again in the last section of this unit. So let's start here with number 1. Actually, we'll do 2. So we'll do number 1 and number 3. So I'm going to take a moment now to write that down. Alright, the first step is we need our quadratic formula. So it's opposite b plus or minus square root in parentheses b squared minus 4ac all over 2a. This is something most teachers will expect you to memorize, but for the purposes of this course, you can assume it'll be right on the board. Written on the board, not right. Sorry. Alright, so using this is how we're going to solve these. Now, there's going to be a very specific order to this, so I suggest that you take very detailed notes on this because they will aid you on your test. So step 1, we identify our A, B, and C. So here my A is 3, B is 5, C is 3. I also ensure that my equation is set equal to 0, which these are. So the first thing we're going to do in both of these, I'm just going to mark this, is just plug into that equation. So I have x equals opposite of b. Well, here it's positive, so the opposite of positive is negative. Plus or minus in parentheses here. You'll notice these parentheses are very useful, and you'll understand shortly why. 4 is negative 6. So if this was a negative, say it was negative 6 here, then I'd leave it as positive here. That's what opposite implies. C all over 2 times A. Alright, for our next step, we're going to combine two things together. So what we're going to do is work with what's inside the square root first. So we can kind of copy down what we're going to leave alone here. So I know I have a negative 5 plus or minus something. And on the bottom, I can do this real quick. 2 times 3 is just 6. Over here, I have a negative 6 plus or minus something. And then 2 times negative 5 will give me a negative 10. Alright, now this next part is very important. We're going to type this all into GeoGebra just how it looks, but not the square root. So here I have 5 squared minus 4 times 3 times 3. So in my input bar, parentheses 5 squared minus 4 times 3 times 3. Take a moment now and make sure that you've typed it exactly as it appears. My answer, negative 11. So inside my square root, negative 11. Now let's complete this part. We know we're going to keep that square root symbol, so we can go ahead and write it. I'm going to type all this in. 6 squared minus 4 times negative 5 times 27. So 6 squared minus 4 times 5 negative 5 negative 5, then 27. So negative 5. Okay, take a moment and make sure you have it exactly how it looks. I get 576. Alright, from here we'll finish this problem first, and then move over here. Okay, so, first thing I see a negative, so let's go ahead and get rid of that. So that would give me a negative 5 plus or minus I squared of 11 over 6. Now we check, and we see we can't break down 11 at all. It's divisible by 1 and 11, so it too is one of those prime numbers. If that's the case, we can actually stop right there, and we're done. So if I wanted to write these up separately, it would be negative 5 plus I over 11 over 6, and then the other answer would be negative 5 minus I over 11 over 6. So that plus and minus are where two answers are from. But for our purposes, this is the final answer. Now over here. So we realize 576 is even, so it might break down a bit. We don't have a negative, so I don't need to worry about the I. So let's start breaking that down. It's divisible by 2. So let's see, 576 divided by 2. Gives me 288. That's even as well. So if I divide by 2 again, you'll notice I divide by 2 until I can't anymore. That'll give me 144. Dividing by 2 again. That gives me, let's see, 15 plus 22. That's 72. Dividing by 2 again. Gives me 36. And again, there's 2, that's 18. And again, there's 2 and 9. That gives me 3 and 3. So here we got a lot to work with. But again, our pattern's the same. So we're looking for a pair of numbers to take. So I have one pair, another pair, another pair, and then a pair of threes. So since everything matches up in pair, these all come out of the square root. So my solution here is 2 times 2 times 2 times 3. By using a calculator, we'll find out that's going to give us 24. So replacing that with 24, I get 2x is equal to negative 6. Plus or minus. Since I lost everything came out, it's just 24. Or negative 10. Now traditionally there's some simplifying in place there, but for the purposes of our class, this will be our final answer. Take a moment now and ensure we have everything written down. Alright, moving on to our last portion of this unit. Solving polynomial equations. Alright, so if we take a look at these three problems, and I'll do all 5 here just for the sake of it. Let's go ahead this one here, we see that we have things that start with x to the third, and we have 4 terms. So that lends me back to my group factoring that we began at the start. So before I can use any other methods, I'm going to have to use my group factoring. And that'll be for both of these first 2 problems. So what they have in common is x squared, so that's 5x plus 3. And then here they both have 5 in common, so I can take that 5. Again, if you need a brief review on this, return to the beginning of the video. Here, these both have, let's see, I can take out an x squared, so it'd be 3x minus 5. And to make this one match up, I would take out I want to get a 3 from 6, so let's take out a negative 2. So that'll give me 3x minus 5. Now, just as before, we see we have a matching term, so I can write that as 5x plus 3. And then my other 2 terms make up x squared plus 5. Here, my matching term, 3x minus 5, which is my second term composed of those coefficients. Alright, so take a moment now, pause the video, and make sure you're caught up to there. Alright, so that's kind of our step 1 there. Now we need to solve. So I'm going to use red for my left term. So this is 5x plus 3 is equal to 0. And my left term here is 3x minus 5 is equal to 0. And then for my right terms, let's go ahead and use blue. So this is x squared plus 5 equals 0. And x squared minus 2 is equal to 0. Now, here, since I had those 2 factors, I knew I could just break them apart. So as soon as we get 2 distinct terms, it helps to split. This is a very basic equation to solve. We'd subtract 3 first, and then dividing by 5 gives me the solution x is equal to negative 3 over 5. Here, add minus 5. Oh, let's go ahead. Let's do this one first. So I'd add 5 both sides, divide by 3. So those are algebra 1 type equations, right? Now, if we go ahead and solve our blue ones, so I subtract 5 from both sides, which means x squared is equal to negative 5. Taking the square root gives me plus or minus square root of negative 5. So then I would get my I. So this should all look very familiar from our previous lesson. So our solutions here would be these 3 numbers, plus or minus 5, or plus or minus I root 5, and negative 3 over 5, which makes sense because our highest exponent is 3, so we should have 3 answers. Here I add 2 to both sides. Taking the square root gives me positive or negative square root of 2, which doesn't simplify. So here's my 3 answers here. So key ideas here, I noticed I needed my grouping because I had 4 terms and the highest exponent was to the third. And when I had my factored form, my 2 things, I could just set them equal to 0 and solve. Alright, moving on to here. We're actually going to skip over this one. So to the third power, and they only have 2 terms. So what that means is I need to think about my SOAP. So if I take this, if you go back to that section of notes, we'll find A is this, B is this, here we'll find A is X, and B is, let me check that one again, SOAP. So SOAP says same, opposite, always positive, same, opposite, always positive. Again, they're setting 0, so we'll go ahead and remind ourselves of that. So filling in our terms. Here. About solving these. So that's kind of step 1 so far. Now let's do our split again. So if I look here, I can take my first term and make those the red terms. So x plus 8 is equal to 0. Here it would be x minus 7 is equal to 0. And we'll use green. So now I have x squared minus 8x plus 64 is equal to 0. And here I have x squared plus 7x plus 49 is equal to 0. So let's go ahead and solve our red ones first, because those are kind of our nice algebra 1 style equations. So if I subtract 8, I'd find here x is equal to 8. By adding 7 here, I'd find x is equal to 7. Now, these next two, we might think we could try factor, but you'll notice neither of these factor. Thus, we need to do our quadratic formula to solve, because they have 3 terms and factoring doesn't work. So let's go ahead and plug in here. Opposite of 8 would be positive 8. So go ahead and set this one up as well. Squared plus 4 times 1 times 64 gives me negative 192. So I now have x is equal to 8 plus or minus square root negative 192. That's just over 2. Let's go ahead and get this one done as well. So I have 7 squared minus 4 times 1 times 49. So 7 squared minus 4 times 1 times 49, which gives me negative 147. Alright, so let's go focus on the left side again. We know we have a negative in there, in both cases actually, so let's go ahead and get rid of those and throw an I. Since our resulting term inside of that square root was positive. Alright, so let's break them down now. Or at least try to. Let's start with 192. So it's even. So I know it's divisible by 2. That gives me, let's check here. Get 96 there. That breaks down again to 48. Sorry, I divided by 2. 48. Break that down again, so that gives me 2 and 24. 2 and 12. It's even again, so 2 and 6. And then 2 and 3. Alright, so finishing up this part, we have all of our primes here. So I have 1, 2, 3 pairs of 2. And a 3 left over. So that means that this is 2 times 2 times 2, and my leftovers are 3. So that gives me 8 square root of 3. So the final step here is I'm just going to replace that 8 square root of 3 here. So that would be 8i with this question. And again, technically we could simplify this a bit more, but for our purposes, that'll be good. Moving to our left equation. So 147 is not even, but let's see if it's divisible by 3. So I get 3 and 49. So again, those primes, 2, 3, 5, 7, 11, 13. The first four we really need about here, we get 7 and 7. So I have a pair of 7s with a 3 limit over. This is 7. So replacing that square root of 147, I'd have 7i 3 over 2. So again, our two sets of answers here are as shown. This is where I'd suggest making sure we have everything down just as I've shown it. So please pause the video now. At this point, these will be both left up to optional practice. You should be good at this point, so what I would suggest doing is ensuring you finish all practice questions, check their answer keys, and refer to me with any questions that you have. Good luck, and we'll be reviewing soon for your exam. Alright, this will be our notes here for our Unit 5B. Alright, so what we're starting here is dealing with the graphs of polynomials. So let's go ahead and take a look at our first one here. All polynomial graphs have these features in common. So the domain is going to be all real numbers. We have some type of asymptotes, either maybe horizontal, vertical. We can have them. And end behavior, things go up and down forever to infinity. Alright, so let's talk about these few points here. So relative minimum would be something like either of these points. So here or here. Basically it means it's a part of the graph where the graph makes a turn, and therefore it's a minimum. A maximum would be points like here and here. Or again, we kind of hit a peak. So on the top side, then start going back down. Absolute max and min, those deal with like the smallest possible locations. We'll get to more of those in example. A 0 is where we make a cross. So these are the examples of zeros. So it's where we cross the axis. A double 0 would be this location where it just touches. Again, this will all make more sense as we do some more examples. Alright, so let's take a look at these graphs and see what we can find. So zeros. That's where I am touching or crossing the x-axis. So I have here at -2. This looks like about -0.5, so we'll do an estimate for that one. At 1 and at 3. Now all of these are true zeros because we see it starts at the top and crosses. Crosses, crosses, and crosses. Nowhere does it touch. So how to figure out the least degree? This is from how many zeros we have. So here we have 1, 2, 3, 4. So the least degree here would be 4. So least degree just deals with the number of zeros. For our minimums, so if we look closely here, we have this one. This is going to be a minimum. So if we want to think about the coordinates at this point, it would be about -1.5, -2. Look, here's another minimum. That one's pretty close to 2, so we'll say it's at 2, -4. And again, I'll be pretty loose on those as long as it's pretty close to an approximation. So maximums is here we kind of have a peak. So if I look here, here's a peak in the graph. So if we estimate at that point, let's say at 0.5, 1. Domain we talked about is going to be all numbers. Our range. So if we look here, it goes up forever. So we know it's going to shoot off to infinity. But our smallest value, as we see, is at that minimum here, where we get to -4. So it's from -4 to infinity. Looking at our end behavior. So in this case, both sides go up. So as x goes to the right, y goes to infinity. And as x goes to the left, or to infinity, y is also going towards infinity. So one thing you'll notice is even functions. So if the least degree is an even number, so 2, 4, 6, either both sides will go up or both sides will go down. So for our end behavior, those should always match up again if our least degree is an even number. These we're going to skip over. So increasing and decreasing intervals. So let's go ahead and get Alright, take a look at this one. So zeros. So we got -3, -2. Now here it's at 1, but we notice this is a special one, so it's touching it but not crossing it. So we're going to go ahead and write that +1. And we'll throw a star by it, meaning it's a double zero. And as we look, we cross again at 4. So instead of a star, we could just write 1 twice. So let's just write 1 twice. That'll help us with our count. So least degree 1, 2, 3, 4, 5. So this is an example of an odd function because the least degree is an odd number. So 3, 5, 7, 9, odd numbers. Our minimums. So if I'm looking for my curve, so here's a minimum. So if we approximate that, it looks like it's at -1, -2. There's another minimum down here, so at about 3, -6. Maximums, we're looking here and here. So I have one at -2.5, comma 1. And then my other one here is at 1, 0. Again, that one's our double zero there. Alright. Domain. Again, we talked about this always being all real numbers. In our range here, we see we go up in one direction forever and down for the other. So that one we can think of as all real numbers, but you can think of it going from negative to positive. So either one of those works. And for end behavior, we think about as x goes to the right. What does y do? And then as x goes to the left, or negative infinity, what does y do? So as I look here, as I go to the right, we're going up, so it's positive infinity. As I go to the left, it's going down, so negative infinity. So again, we talked about that in the first one. It was an even least degree of 4, so both move the same direction. Here it's an odd degree, so one goes each way. Alright, so solving by graphing. Alright, so we're actually going to do these in GeoGebra. So a lot of times we define zeros that are nice whole numbers, and this just involves using GeoGebra or a graphing calculator if you have one. So if you have a graphing calculator and like to follow these directions, you can, or I can help you out. So if you would like to, you can pause it at this time to figure out how to do it with the graphing calculator. Otherwise, we can go to GeoGebra. So let's go ahead and solve some equations here using GeoGebra. Alright, here we go. Alright, so first step, we're going to look at that graph. Try to find how many real zeros and what they are. So if we look here, alright, some things we want in GeoGebra are going to be, what are axes, and maybe a grid as well. So this is going to help us kind of visualize a graph. So I'm going to go ahead and picture my screen here a bit to zoom out. Alright, so let's go ahead and graph our first equation. So we want x to the third minus 2x plus 4. So x to the third minus 2x plus 4. Press enter. And we have our graph. So something important to check here is when it prints out our function, let's make sure it matches up exactly as it looks here. We're good. So we're good. So the number of real zeros implies where it crosses or touches the x-axis. So here we see just 1, and it's at -2. So to answer my question, how many real zeros? There's 1. And the real zeros are -2. Let's try one more of these here. So x to the 4th minus 4x cubed. So let's go ahead and delete this one. That's 4x cubed plus 2x plus 4. Alright, so for our real zeros here, let's see if we matched up right. X to the 4th minus 4x cubed plus 2x plus 4, good. So it looks like we have 2 real zeros because I'm crossing the x-axis twice. And here exactly where these are at. So in this case, we're actually going to worry about just approximating them. So this gives us an idea that I'm somewhere between, let's see if we zoom in a bit here. Alright, so I'm somewhere between 1 and 2, and closer to 4, but between 3 and 4. So we're going to just write those now as approximates. So we're going to say approximately 1.5, maybe the other one's close to 4, so it's like 3.8. Again, to move on to make more sense how we actually calculate this. Alright. Now, we're going to find the equation and sketch a graph. So first thing we have to do is find our equation. Then we can use GeoGebra to get an idea of what a graph is. So it says we have the roots at -3 and +2. So when we write an equation, we think opposites. So the opposite of -2 would be +3. Opposite of +2, -2. Then we need to expand, so I multiply things out. X times x is x squared, minus 2x. Multiply here would give me +3x, and minus 6. I check. I only have one thing that's squared. However, these are like terms, so if I do -2 + 3, it'll give me plus x or plus 1x minus 6. Getting a graph is going back to GeoGebra, so we have x squared plus 1x minus 6. So if I do like this, x squared plus 1x minus 6. And again, we can recreate this to sketch our graph. If you move around, you can see the bottom, and it goes up forever. So anytime it tells us to sketch a graph, that's what we're going to do. We're going to write our equation and then use GeoGebra to generate a graph again. Key idea there, you want to make sure you know the direction of the graph, so up or down, as well as that make sure you identify those zeros. So you don't make your tick marks, so on and so forth. Alright, let's work on this one here. So we have opposites, so +4, -1, minus 6. So if we go ahead and start multiplying, I'm just going to work with these first two terms, and then worry about the next one. So I have x squared minus 1x plus 4x minus 4. And I'm going to bring down the second term I haven't used yet. These two are like terms, so to make this a little less work for ourselves, we can go ahead and combine those now. And then now we multiply it out again. So it's important to remember those parentheses. So I first have x to the third minus 6x squared. Then I have plus 3x squared minus 18x. Then lastly, when I do this -4 to both terms, I'd have minus 4x plus 24. So more zeros means we have a little more work, but it's not necessarily harder. So I see I only have one thing to the third. I have two things that are squared, so I'd give me -3x squared. Two things that have just x, so minus 22x, and I bring down that plus 24. Take a moment now and make sure you have all of that written down. Alright, so we'll move on. Now, this one's going to be a problem that gives us a bit of a trick to it, so I'm going to ask that you kind of remember the way I set this up. Anytime I see something odd looking like this, I want to get that done first, which will show us a trick here on saving a lot of time. So it says plus or minus square root of 3, so that means I have one term that's minus square root of 3, one that's plus square root of 3. And then we're going to put the opposite here, so x plus 2 at the end. Now the reason we're going to do this first is because some things are going to cancel out. If we don't cancel it out now, it's going to make a lot more work for us in the end. So if we go ahead and multiply these out, x squared plus root 3x minus root 3x. Now if I multiply these, we talked about using the square root function in GeoGebra, we'll find that this comes out to minus 3. Because the square root of 3 times the square root of 3 is just 3, and then negative and positive make a negative. And again, GeoGebra will do that for you. Here, this is the cool part. That saves us some work. So since I have positive and negative root 3, those will actually cancel out. So I'm left with x squared minus 3 times x plus 2. When I multiply this out, we'll get x to the third plus 2x squared minus 3x minus 6. And again, going to GeoGebra will allow us to generate that graph as well. we want to identify these zeros first. Then we can use them to get our equation. So if I'm looking here, I see I have zeros at -1, 0, and 2. So let's do 3 zeros, so let's set up our equation. So for the first, opposite of positive, or -1 would be positive. Here would just be x minus 0, and then x minus 2. Now if I want to simplify a bit here, anytime I have a 0, that's just like having an x there. So this would be like x plus 1 times x, and x minus 2. So if we go ahead here, let's do x times x, which is x squared. And 1 times x is just 1x. Bring this one down. And we're going to multiply this out. X squared times x is x cubed, minus 2x squared. And then here times here, that would give me plus 1x squared. And then this one gives me minus 2x. So I can combine a little in the middle here. So I have x to the third minus x squared minus 1x squared minus 2x. So that's our equation we would then have everything from. Let's try this one here. So this one a little different. So I have one at -1. And then here we notice it's not crossing, it's just touching. So it's like I have 2 there and positive 2. So if we want to go ahead and write this out, that would give me x plus 1, x minus 2, and x minus 2 again. So now I'm multiplying out these first two terms. That gives me x squared minus 2x plus 1x minus 2. Bring it down to that secondary x minus 2 we haven't used yet. So again, to save ourselves some more work, we're going to combine like terms here. So that gives me x squared minus 1x minus 2. And then multiplying out again, we have x to the third minus 2x squared minus 1x squared plus 2x minus 2x and then plus 4. So combining, I have x to the third, combine these two, -3x squared. These two actually cancel out because positive 2x minus 2x, so then I just have plus 4 at the end. And we got our equation there. Alright, moving on now. Now we can get into the bulk of our unit here, using synthetic division. Alright, so key idea here is making sure we set it up right, analyzing our equations, and the idea here is if we have a remainder of 0, then it is a 0, or it does evenly divide, and thus that gives us an x-intercept or a 0 on the graph. If it does not have a remainder of 0, then it's not a 0 or x-intercept on the graph. Alright, so first things first, I had to figure out what I'm going to divide by. So here, I'm thinking about this equation, I have x plus 1. So the opposite of that, because I want to figure out what the opposite is 0, then the x is equal to -1, because that's subtract. So just think opposites here. So we're dividing by -1. Now, setting up our equation, we see our highest thing is squared. There's nothing out front, so it's like having a 1. So I need to make sure these go down in order. So I have squared, then I have just an x, which is good, so my next coefficient is 5. And then I have just 6. Now, if we were missing something, like we'll see later on, we'll use a 0 as a placeholder. So, general steps to this are the first term we just bring down as it is. So, the first one is just a 1. So, I just bring down a 1. Now, the idea to remember how to do this is we multiply around. And then we add down. So, multiply around, add down. So, I have a 1, so -1 times 1 is -1. Adding down, positive 4. -1 times 4 is -4. And our last term here, we can always throw an r there. If we have a remainder, it'll show up here. So when I add these, I have positive 2. So this is not a 0, and I have a remainder. Now, each time we divide, our highest exponent goes down by 1. So if we start with squared, this would be just x, and this is going to be a constant. or just a regular number. So my answer here for what this comes out to would be 1x plus 4. And then my remainder is positive, so it's going to say plus. If this was a negative, I'd put a negative there. And then it's 2 divided by what we divided by originally. So 2 divided by x plus 1. We're going to do a lot of these together. So you should take detailed notes and listening along. Alright, so let's move forward. Let's skip this part. Alright, let's go ahead and do some more synthetic division. Okay, so let's get our coefficients first here. So I start with the third power. So if we draw our box out here, give yourself some space. And we know if we have remainders that come at the end. We'll get to that later. So we start with the third power. The coefficient is 3. Then I go down to squared, so that's good. And negative 2. Down to just x, good. Negative 23. And then I have a constant at the end, such as 14. Again, we said if we have a remainder, it's going to come here, so just a reminder. And then the opposite of positive 3 is negative 3. Let's go ahead and start our division. So we bring down 3. I multiply negative 3. 3 gives me negative 9. So I'm multiplying around, adding down. Negative 11, positive 33. Adding these two gives me 10. Negative 30, adding those gives me negative 16. So it's not a 0, so let's write up our answer. So we started with the third power. I divided 1 time, so now it goes down to square. So I have 3x squared minus 11x plus 10. And then it's a negative remainder, so it would be minus 16 over what we divided by x plus 3. Once you get this down pat, it's a fairly quick process. Looking at the next one here. So let's get our setup going. Alright, so here's where we're looking. You see we start with the third power. There's no coefficient there, so it's like having a 1. Now I'm looking to go down by 1 each time, and I notice that I don't have a squared term. So that's like having a plus 0x squared in there. So we use a 0 as a placeholder. And I go down to just x, which is negative 6, and my constant of 4. Opposite of negative 2 is positive 2. And we begin our process. So here, 2 times 1 is 2. 0 plus 2. 2 times 2 is 4. That gives me a negative 2. Negative 4, and I get a remainder of 0. So here we do the true 0. That means a solution to this equation is at positive 2. Writing the answer, we had third and we divided once, so it's 1x squared plus 2x. Minus 2. Since our remainder is 0, there's nothing more we need to write. So slight differences there in how we write it, whether it's a 0 or not. Alright, a little more challenging here. So here we have a 5th degree, but the process is still the same. So I start 5th, and my coefficient is 2. I'm looking for that 4th degree. I don't have it, so I put it at 0. I have my negative 3 going down to squared. I'm good. I don't have anything with just an x, so there's another 0. And I end up with negative 1. Opposite of negative 1 is positive, so I'm going to start with that. So 2 again. Negative 1, negative 1, 4, 4. Adding, I get 4. Then I get 4 up here, doing 1 times 4. I get negative 3. A lot of work there. But again, we're just adding and multiplying, all which can be done in a calculator. I'm just trying to expedite the process as opposed to showing it to save you guys time. And again, GeoGebra does all the math for us. Alright, so as we go through here, we started with a 5th degree, so that means my first thing is now 4th degree. 3rd degree, squared or 2nd degree. 1st degree, I mean just having a variable. A constant term, and then lastly it's positive 3, so plus 3 over x minus 1. So a long answer, but not a different answer. It's the same thing we've been doing. Moving on to our next one here. So let's set up our box. So I have 1. I go down by 1. It's negative 1. Going down 1 exponent again, negative 4. I'm missing my x term, so I go to 0, and then 4. minus 1, so that means I'm dividing by 1. Multiplying, adding. Multiplying, adding. Multiplying, adding. Multiplying, adding. So here's the remainder of 0, so this does divide evenly. So writing up our answer, we started with a 4th degree, so now my new biggest term is 3rd, so it goes down by 1. Here it says plus 0x squared, which you can write, or you could just eliminate this term, which I'll show in the next answer. And minus 4x, minus 4, and we don't have a remainder. So you can write it this way, or you could write it without this term, because 0 times anything is just 0. So either one of these answers is totally fine by me. I think by this point we've got the process down, so we're going to go ahead and skip over these last two. They'll be left as optional practice, and should you choose to do them, I'd be more than happy to check your work for you. Moving on, we have the rational root theorem. So this is kind of figuring out which rational numbers could possibly be roots of our polynomial. This is a great way of attacking a problem when you don't necessarily have a great idea of where these zeros might be. So we'll use this in a combination with graphing to figure out which ones it is. Alright, so we'll just do two of these together right now. So finding all the possible rational roots. This involves factors of numbers. So we think of P as our last term, and Q, so here it's our leading term, will just be a 1. In this example, P is our last term, Q is our first term again. Here there is a number out front of our leading variable, so our highest variable I should say, so it would just be 2 there. In the first one we didn't have 1, so we made it a 1. So the way this works is we think of all the positive and negative numbers we can make by using their factors. So the factors of 3, that means what divides 3 evenly are 1 and 3. The factors of 1 are just 1. Here, the factors of 8, so let's see, 1 and 8. I have 2 and 4. And that's it. It doesn't matter what order you write these in. That's just, traditionally we put them in order, but it doesn't really matter. You can do it in whichever way you want. Then the factors of 2 are 1 and 2. Now, some of these are easy, other ones a little bit more challenging. I'm thinking of all the different numbers we can make from this. So I have 1 divided by 1. That gives me 1. And then 3 divided by 1 would give me 3. So I have positive or negative 1. And positive or negative 3. So those are all of the possible rational zeros. Now those aren't guaranteed to be the zeros. Again, we have non-rational things, we could have weird, ugly, complex answers. But again, these ones are kind of our go-tos to start. For this one, I can do 1 divided by 1, which would give me 1 or negative 1. Then I could do 1 divided by 2, so I could have positive or negative 1/2. You'll notice you'll get some repetitions in these, that's fine. We only need to write them once. Here I'd have 2 divided by 1, so positive or negative 2. 2 divided by 2 is 1. I already have that, so I don't need to write it again. 4 divided by 1, positive or negative 4. 4 divided by 2, well, that gives me positive or negative 2, which I already have. 8 divided by 1, so positive or negative 8. And then 8 divided by 2 would give me positive or negative 4, which I already have. So all my possible zeros, I would have 1 or negative 1. 1/2 or negative 1/2, 2 or negative 2, 4 or negative 4, and 8 or negative 8. So a lot more options there, and it'll make more sense when we start graphing these, why we like to have those ideas in mind. Alright, so let's move on through and find out which ones are actually roots. So find the rational roots of each equation. So if we think about this, we have the factors of 3, which are 1 and 3. And our leading coefficient is 1. So similar to above, we'd have positive or negative 1, positive or negative 3. So I'm kind of looking at 1, negative 1, 3, or negative 3. Now, my best bet here is going to be examine this graphically. So I have x to the 3rd plus x squared minus 3x minus 3. So let's delete this. X to the 3rd plus x squared minus 3x minus 3. rational ones are going to go right through those intercepts. So if I look, that doesn't look like any of the numbers I came up with, right? So that 1, -1, 3, or -3. That -1, though, definitely works. This one we see not quite where we want. But that -1 is going to be one. So finding the rational roots, we said -1 works. So let's go ahead and do that just for the sake of saying x equals -1. So again, we figure out what they are, we look at a graph, and we're good to go. Let's try this one. So on the factors of 6, so that's 1, 2, 3, and 6. The factors of 1 are just 1. So my choices are, I would have positive -1, positive -2, positive -3, and positive -6. So I have x to the third minus 7x minus 6. So x to the third minus 7x minus 6. Let's make sure I just typed that in right. Okay, so let's go ahead and graph it. So if you left click, you can drag and drop right here. Okay, so let's see what I got. I have one at -2, -1, and 3. So my zeros would be -2, and positive. So those are all our rational zeros there. Moving on, we'll do one more of these. So my factors, I have positive or negative. Factors at 8, so we said those are 1, 2, 4, and 8. Factors of 2, which is just 1 and 2. So if we think about these, that gives me a positive for -1, positive for -1/2, positive for -2, we don't need to repeat that. Positive for -4, don't need to repeat that, that's 2, and positive for -8, we don't need to repeat that, that's 4. So again, these ones we already did. So let's go ahead and graph this and see which of these give us our actual zeros. So I have 2x to the third minus 9x squared. The third minus 9x squared minus 11x plus 8. This is where this is going to come in handy, because we're looking for these rational zeros. So I look, and I don't see any nice whole number answers, but what I do see is where these points are. So it looks like I'm between -1 and -2, and then between 0 and 1. So if I think about those answers, which one of these is between 0 and 1? If you use the calculator, you'd find out that 1/2 is equal to 0.5. So our answer here would be x is equal to, if we look again, that's exactly halfway between. So it'd be x is equal to 1/2. Alright, let's go ahead and move through these notes. We don't need them. Alright. So, let's go ahead and move on a bit more. So now we're going to go ahead and solve. So the key idea here is we define all possible zeros. So here's a diagram if you want to take a moment to read through. You can pause the video now, and then we'll work through it together. Okay, so key idea here is that the number of solutions will match the degree. So here I see that I have a third power, so I know I need 3 answers. And number 2, we have a fourth power, so only 4 answers. So step 1 here is we're going to graph these. So we always graph first to see if we have any obvious 0 answers. Again, you're welcome to try the other methods talked about, such as factoring, but this is kind of the go-to set of steps that will get us to our answer. So let's go ahead and try graphing first. So we have 3x to the third minus 10x squared. 3x to the third minus 10x squared plus 4x minus 3. So right off the bat here, I get one of my zeros, right? I can clearly see here that it goes through positive 3. So I know I have a 0, so I'm going to keep the list here of zeros. So I know one's at positive 3. Now, anytime we know we have 0, that means I can divide by it. So let's go ahead and set up our synthetic division here by dividing by 3. So I have 3, -10, 4, and -3. Now, when we divide by 0, our remainder should always be 0. So if I go through here, let's see, we got 9, 1, -3, 1, 3, and 0. Great. Now, if I think about this equation that I have, this gives me 3x squared minus 1x plus 1. Now, you might be thinking maybe we could factor, but what I would suggest is following this pattern. So we looked in the graph to find the first 0. Now, we can go ahead and use our quadratic formula to solve. So I'm going to set it equal to 0 and use the quadratic formula. So I have my A, B, and C. As soon as we get down to a squared as our highest variable, so that would be the time we can employ quadratic formula to solve. So that gives me x is equal to opposite b plus or minus square root b squared minus 4 ac all over 2a. If you're looking for a more in-depth review of quadratic formula, feel free to go back to the previous unit's video. In 5a, we did a much longer explanation. At this point, we're just going to kind of work through what we already know. So I would simplify this without the square root utilizing GeoGebra. That gives me a nice enough answer here. So I would get negative 11. On the bottom, we get 6. We talked about simplifying here, so that would give me 1 plus or minus I squared 11. And we can check, and we'd realize that 11 doesn't break down any further. So this would be my additional zeros. So for my master list of zeros, I would have 3 and then 1 plus I square root of 11 over 6. And then the minus portion, 1 minus I square root of 11 over 6. So that would be my zeros. And you notice that I have 3, which matches up to my degree of 3. So I know I'm done. Again, please make sure you clearly identify your final list of zeros so that it's easy for me to see where you went and if it's correct. Take a moment now and ensure you have all that worked out. Alright, on to our next example here. Here we see we have a degree 4 polynomial, so I know that my final set of zeros will have to include 4 numbers. Alright, so let's go ahead and go to our graphing technique here. So we have 2x to the 4th minus 7x cubed. Minus 4x squared plus 20x. So again, one thing to ensure is that we match up. So 2x to the 4th minus 7x cubed minus 4x squared plus 20x. Alright, now let's see our zeros here. So this first one, that doesn't go through a whole number, so let's not worry about that. This one goes through 0, so that's good. This one goes through 2, also good. This one, not a whole number, so I don't really want to worry about it. So let's see, we have 0 and 0 and 2. 0 and 2. That means I have half of them already, so I was able to get half just from the graph. Now we use our synthetic division, so let's start with dividing by our 0. So I'm going to have 2, -3, I have an x squared, so I'm good. I have an x, so I'm good. I don't have a constant, so we can put a 0 at the end, but we don't need to. Alright, so here was divided by our 0 first. So multiply, add, multiply, add, multiply, add. Now, what's a trick about this one is how this kind of looks. So we said we should have a remainder 0 when we do this, but we still have that remainder. So let's think about what we can do here. One thing to notice before we do this is sort of a special case, is when all my terms have an x, so I don't have a constant term at the end. What that means is we can actually factor it out. So if I factor out an x, that gives me 2x to the 3rd minus 7x squared minus 4x variables have an x, we always want to factor that out first. So this x out front represents this 0 here, which means I can just work with this equation when I divide by my next 0, 2. So now I have 2, negative 7, negative 4, and 20. Well, notice that this gives us the kind of answer we're looking for with synthetic division. So we're dividing by positive 2, so these will give me 4, negative 3, negative 6, negative 10, and then a negative 20 here, so that's the remainder of 0 and 1. Now, we factored out, so we had a degree 3. I divide it once, that means my new resulting equation is squared. So if we use our A, B, and C to solve using quadratic formula again, we will have opposite of B plus or minus square root B squared minus 4 AC all over 2A. Just a reminder again, traditionally we memorize the quadratic formula, but for our purposes you can assume it will be written on the board. And again, if you're looking for more notes on use of the quadratic formula, the 5A video would be the place to go for that. Alright, so let's go ahead and simplify here. I'm using what's inside the square root of algebra without typing the square root symbol, which will give me positive 89/4. Now if we go ahead and check here, it's not divided by 2, it's not divisible by 3. We'll learn that this one is not going to exactly break down like we want it to, which is totally fine. So, since it doesn't break down, this is actually going to be our final answer. So up here, our next two list of zeros then is going to be 3 plus square root of 89 over 4, and 3 minus square root of 89. So we are good there. That will be our final set of answers. So we have 1, 2, 3, 4 answers, which makes sense with our fourth degree polynomial. As a conclusion to this unit's notes, I just real quickly typed this one into GeoGebra here, and we analyzed our graph. So we might have to move it around a bit, so you want to check you see all of the graph. So if we zoom in, zoom out, you'll find it. Here we have intercepts at -5 and -2. So what that would tell me is that this question is going to be eerily similar to others. So my zeros would start off at x equals -5 and -2. And then we'd go through and do our division there step by step, get down to quadratic, and utilize quadratic formula. At this point, you have all the notes and skills you need to complete this unit. So please ensure you've taken all the notes, rewatch what you need to, and once we get through the practices, then we'll be moving on to test and review. Alright, thank you, and make sure you're asking me if you have any questions.
Alright, so these are going to be our notes for Unit 6. So if we go ahead and get going here. There we go. Alright, so we're going to be solving systems of equations here. We're going to start off with linear solutions. So for our first one here, we have use the graph to solve the system of linear equations, then check the solution algebraically. So if we're given a graph here, we're just going to go ahead and identify it. So there's a couple different scenarios here. We either have one point of intersection, such as here, where we see the graph and the two lines meet at a single point. So with linear equations, we either have one solution, infinite solutions, or no solutions. So one solution is here where they intersect. So the coordinates of this point are 2, -1. Okay, we have already covered graphing linear equations, so at this point is review. We're going to graph using GeoGebra in this course, so let's go ahead and take a look here. So both of these are already solved for y. So let's go ahead and use GeoGebra to solve them. So my first equation is -x minus 2. So let's go ahead and graph that. So I have -x minus 2. And real quick, it's going to freeze for a second here. Hold on. There we go. So what else I did here, in case you didn't have it like this, is I right-clicked and hit axes and grid. That way I can go ahead and see these as well, where the graph goes. So that's our first graph. Now for our second equation, we have 2/3 x plus 3. So always put your fractions in parentheses. 2/3 x plus 3.
our point of intersection. So it's going to be at -3, +1. So our solution there, -3, +1. So moving on from there, at this point what we want to do now is we have a different equation that's going to be in standard form. But what's next is GeoGebra can actually handle that as well. So we have 5x plus 4y equals 16. So I deleted what I had here. So 5x plus 4y equals 16. Press enter. And for our next equation, x minus 4y equals 8. So x minus 4y equals 8. And we'll see our point of intersection is here at 4, -1. All right. This one's the same thing, so we'll leave these up to optional practice. Again, at this point, when we're given a problem that is solved graphically, we can just utilize GeoGebra to graph those for us. Moving down here. So this is going to be, actually we are going to skip this. All right. So substitution should be a matter of review. You guys have seen that in the past. So we're going to focus on solving by elimination. So if we go ahead in here. All right, so we'll notice with these is no variable is solved by itself. Right? Now if you know substitution and you see equations like y equals, you're welcome to use it. What this video is going to focus on is utilizing elimination. So here, I'm looking at my variables. Now, the key of elimination is we want to pick either x or y, and then get rid of it. So, if I look here, I have a 4 and a 2. So those are both positive. They're not the same number. Here, I have positive and -3y. Now, the reason I'm going to use y here is because they're the same number, but opposite signs. So some problems will involve a little bit more work. But for here, we're already good to go. So you'll notice also I'm in the form my x's line up, my y's line up, and my constant numbers line up. So here, if we think about adding these equations together, we add down. So 4 plus 2 gives me 6x. 3 and -3 give me 0, so they cancel out. Now, that idea of canceling out is where elimination comes from. It tries to eliminate a variable and get one by itself. So if we divide by 6 here, I'll get x is equal to 4. And then I can plug that into either equation to find my y value. So I'm just going to use the top one, so 4, and plug in my x. So I get 3y is equal to 0. And I divide by 3, get y equals 3. So I get 0 there. So our answer would be 4 from x, 0. Moving on to example 2. All right, this one's going to require a tad bit more work because we notice our bottom equation looks good, but our top one doesn't have x and y on the same side. So to get my y over here to line up, I would have to subtract it. So I look, my x's are both positive, different numbers. Let's check my y's. Again, we have a positive and -2. So I can go ahead and do elimination by adding. So 3 plus 5 gives me 8x. My y's cancel, and it's equal to 20. I divide here. If we use GeoGebra in a fraction text command. So let's go ahead and just do that. So fraction text. I want 20 divided by 8. We notice that comes out to 5/2. And then I'm going to go into that first equation. So 3x minus 2y. Move this up a bit. So my x is 5/2 minus 2y equals 8. So using GeoGebra to get this, we would have 15/2 minus 2y equals 8. What I'm going to do is multiply everything by 2 here, just get rid of the fraction. So that would give me 15 minus 4y equals 16. Or you could go ahead and do in the calculator 8 minus parentheses 15 divided by 2 parentheses with your fraction text. Here I'm going to subtract 15 from both sides, so I'll get -4y is equal to 16. Or that's 1, sorry.
And when we divide by negative 4, we'll get y is equal to negative 1 over 4. So our solution would be 5 over 2 and negative 1 over 4. So you'll notice graphing is only really useful when we get those nice whole number answers. For anything with fractions, we're going to have to rely on our algebraic solve. Alright, so this one, looking a little different. We know to start out with we have x's and y's are both different numbers. So, easiest thing to do is pick one and go with it. So I'm going to try to just get rid of my x's. That's when it's not set up nicely, that's usually the easiest way to do it. So, if I want to get one of these, I want to make a number with opposite signs. Well, I know 5 times 2. I'm going to multiply the entire equation by negative 2. Multiply negative 10. These positive 16y. Multiplying these negative. And if we add here, my 10 is let's go ahead and divide fraction text here to get this reduced if you don't like doing it by hand. It would be 10 over 16, that goes to 5 over 8. Alright, so from here we can plug that in. So I'm just going to use the top one. So I have 10x plus 16 times my y here, so 5 over 8 is equal to 140. That gives me 10x. So in GeoGebra, I would type 16 parentheses 5 divided by parentheses. And again, if you put that inside of your fraction text, you'll get a nice answer here, and it will just come out to 10. We subtract our 10, and I'll get 10x is equal to 130. Divide by 10, and I'll get x is equal to 13. So my answer is this one. Always intrude our x, comma y, so 13, comma 5 over 8. Alright, moving on. Alright, so for this one, a little more work. I'll actually do this one with you guys. So I need to get my x over here. So I have my x and y on the same side. So I would add it. So I'm going to leave my top one the same here. So I have 3x plus 2y equals 8. So when I add it over, then I would have positive 5x. And it's a positive 2y is equal to 12. Now with this one, our x's are different, our y's are different. But I notice the y's are the same number. So what I could do is just multiply that bottom equation by negative 1. So that'll give me, leave my top the same at 3x plus 2y equals 8. And if I do negative 1, it just changes the sign. So I'll have negative 5x minus 2y equals negative 12. Then I can add and get some cancellation. So here, this gives me negative 2x. My y's cancel out, and it's equal to negative 4. Dividing by negative 2 will give me x is equal to positive 2. And let's go ahead and plug in here. I'm using the first one again. So 3 times my x, which is 2, plus 2y equals 8. So that's 6 plus 2y is equal to 8. I subtract 6 from both sides and get 2y is equal to 2. Divide by 2 and get y equals 1. So my answer, x, comma, y. Alright. Let's go ahead and do this one as well. Okay, so I'm looking here. My x's are different, my y's are different. Now, if I just have an x, remember we always have that imaginary or the placeholder of a 1 out front. So there's a couple ways we could do this. We could multiply the bottom by 2. We could do a couple different things to get our y's cancel. But let's say we don't know that by hand. I'm just going to cancel my x's. So I have a 1 and a 5, right? So this means I can multiply the top one by negative 5 to get my x's to cancel. So that'd be negative 5x plus 40y, so negative equals 40. And the bottom I'm going to leave the same because I didn't do anything to it. So when I add my x's cancel, I get 44y is equal to 44. I divide both sides by 44 and get y equals 1. Go ahead and use the second equation here to solve for my x. I'm plug in my 1 for y. I get 5x plus 4 is equal to 4. Subtract, I get 5x is equal to 0. Divide by 5, and I'll get x is equal to 0. So my solution, 0, comma, 1. All right. I'm going to go ahead and skip over to these. This we already solved with elimination. Okay, so now I want to talk about the 3 different outcomes we referenced at the beginning of the video. So when we have these nice linear equations, meaning the variables are the first power, there's nothing squared. What that means is we have 3 different outcomes. One solution, which is what we've seen so far, means the lines intersect exactly at 1 point. No solution means when the lines are parallel, so their slope is the same. Infinitely many solutions means both lines are actually the same line. They just might look a little different in their equation. Skipping over these. Alright. So let's go ahead and solve these next 4 algebraically. So as far as the test goes, unless it directly tells you that you're allowed to use substitution, or graphing, I should say, that means we have to go ahead and solve these things algebraically. All right, so for this one, here's where we'll review a bit of our substitution. So actually, you know what? Let's just stick to elimination. It's a much cleaner method, and now we're going to cover all the tools we need to do it. So here, I need to get my x and y on the same side. So this one already has x and y on the same side. This one does not. So I need to move this. It's a -3, so I would add 3x to both sides. So that would give me 3x plus y is equal to -1. Now if I look, these are the exact same equations. Since they're exactly the same, what that means is I have infinite solutions. Now sometimes we're not going to be able to see that right off the bat. So let's go ahead now and use elimination to solve this, just so we can see what kind of statements also imply infinite solutions. So here, if I wanted to cancel out, right, I would, let's say I'd multiply the bottom one by -1. So when I add these 2, I can cancel out my x, so I'm just going to rewrite this a bit. So my top equation was 3x plus y is equal to -1. My bottom, once I do that, -1 would give me -3x minus y is equal to +1. So I add, my x's cancel, so that means I'm left with 0. -1 and 1 also give me 0. So if I get a statement that's always true, so I get something like x is equal to x, y equals y, 5 equals 5, -50 equals -50. If it's a statement that's true, that's another way to see of infinite solutions. In contrast, if I have a statement that's false, such as 5 is equal to 2, so if I get one number equals another number and it's just not true, what that means is we would have no solutions. Alright, so let's go ahead and work through this one now. So, let's see, my y's are different, x's are different, so let's go ahead and cancel our x. So I have a -2. That means if I multiply the entire top equation by +2, so I'm going to rewrite that down here, I'd get 2x minus 4y equals 10. So multiplying that 1 will give me 2, -4, 10. So now I'm going to go and add these 2 here. So my x's cancel, my y's cancel, so I get a 0. And then I get 12. So this is an example of a false statement. Since 0 is not equal to 12, this is an example where we have no solution. So these lines actually never intersect one another. So these would be parallel lines. So no solution also implies we have parallel lines. All right, let's check out these 2. So here, let's see, cancel my x's. So to get 2 is 4. Let's go ahead and multiply it by -2. So I get -4x minus 2y equals -8. When I add those, I get 0. This gives me -4y equals -8. Cancel. My y's will also not cancel. And then here, we have our -8. I divide both sides by -4 and get y is equal to 2.
Then if I plug back in, so let's use this equation here. So 4x minus 2 equals 0. 4 to both sides. Divide by 4, x equals 1. So this one, nice one solution here. 1, 2 like we've seen before. So again, if you're getting that work down. Alright, let's go ahead over here now. So we're good. My x's and y's are on the same side. Let's see here. So let's say I didn't realize what I could do to get rid of my y's. So let's stick with my x's, right? I know 4 times 3 gives me 12. So if I multiply it by negative 3, I'm going to rewrite that down here. They give me negative 12x plus 3y is equal to negative 15. Then once I add, these cancel, so I get a 0 equals negative 5. That's definitely not a true statement. Therefore, we have no solution. And again, we can think of those as being parallel lines. All right, moving right along here. Okay. All right. So we're not actually going to solve these by graphing. Just real quick, let's kind of talk about what they look like. So in our first scenario here, now that we have non-linear, so meaning we have some parabolic stuff, some x squared type things, we again have 3 scenarios. So the first here would be 2 solutions, meaning it intersects twice. So there's 2 points where that curve hits the line. This cannot happen with 2 linear equations, but it can when we have parabolas, when we have a squared and a linear. We could have no solution, just like before, so we arrive at a false statement because these 2 never touch one another. And lastly, we can have 1 solution. So we have a case where the parabola intersects the line at exactly 1 point. All right. Let's go ahead and skip over some stuff here. All right. So we're going to talk about a couple different methods to solve here. So things to come up with, we're going to touch on a little bit of substitution here. So when we get to these squared or non-linear equations, sometimes substitution is very favorable. So we'll utilize that. We're also going to need to use that quadratic formula. So again, in most math classes, it's an expectation that you have that memorized. I'm also sorry, I just said expectation, really weird there. But for our purposes, you can assume this will be written on the board for this test as well as any others that involve it. So take a moment right now and just make sure you pause the video and write down that quadratic formula on the top of your page. So let's start here. All right, so we notice right off the bat we have one equation that's linear. And then this one is going to be quadratic because it's got that squared x variable. So as we go to solve these, we're going to need to employ a little bit of different methods. So first thing we notice is both equations are solved for y. So to utilize substitution, since both equations already have y by itself, we're thinking about setting these 2 sides equal. So again, y has to be by itself on both sides to employ this method. So here I have 5x plus 12 equals x squared plus, you know what, real quick, erase what you have. Let's always just put our quadratic equation on the left. So the thing with the squared variable, let's put it on the left. You'll understand why. Let's make the work look a bit cleaner. So equals 5x plus 12. Now, to utilize the quadratic formula, I need to get things set equal to 0. So I'm going to move all my variables to the left. So let's start with subtracting 5x. And notice I'm lining it up with my x variable. So that gives me 5x squared minus 3x minus 6. And it's positive 12, so I'm bringing it down. Now to get 0 on my right side, I'm going to subtract 12. So that would give me x squared minus 3x minus 18 is equal to 0. Take a moment now and ensure you have that down. For the sake of space here, I'm actually going to erase mine. But again, you don't want to erase it. You need all the work. Write it up here. So x squared minus 3x minus 18 is equal to 0. All right. So at this point, you might be able to factor this. So let's say we had factoring. If I factored this, this would get me a, and again, well, I'm going to show you both methods, but if I factored, we would end up with something like x minus 6, x plus 3 is equal to 0. But let's say we don't like factoring. We want to go to a way to solve this. We can always go to quadratic formula. So here my a is what's up front. Nothing's there, so it's 1. B is negative 3. C is negative 18. So factoring works sometimes, and if you're quick at it, that's great. If not, I would just go to quadratic form because it'll always be this right. 3 plus or minus square root b squared minus 4ac all over 2 times a. So we've talked before about putting this into GeoGebra without the square root symbol. So if we go ahead and do that, so we have negative 3 squared minus 4 times 1 times negative 18. So I have, now let's go ahead and clear all this out. Oops. Delete. 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 All right, so negative 3 squared minus 4 times 1 times negative 18. So negative 3 squared minus 4 times 1 times negative 18. Good. I get 81. So this will 3 plus or minus 81 over 2. Not even, so it's not divisible by 2. So I start checking the next number. It's divisible by 3. So 3 is one of those primes we've talked about a lot. So 2, 3, 5, 7, 11, 13. 2, 3, 5, and 7 are big ones. So I divide it by 3, and that gives me 27. I check. It's not even, but it's divisible by 3. So 3 and 9. And 9 breaks down to 3. I have all my primes right in that nice pattern we talked about. So I need a pair of numbers to take one out. So I have a pair of 3s, another pair, and nothing left over. So I get, and I lose my square root because I have nothing left in our circle here. 3 times 3. This gives me x equals 3 plus or minus 9 over 2. I'm going to go ahead and erase this. I'll make sure you have this down just for sake of room here. All right, so what we're going to do is actually take this a step further now and actually solve for our solution. So I have x equals 3 plus or minus, so for my first 3 plus 9 over 2. And then for my second one, it'd be 3 minus 9 over 2. So, and the reason we're going to take this step is because this turns out to a nice whole number. If we ever have something left over with a square root, or an I, or anything that's not a whole number essentially, we're just going to go ahead and leave it just how it looks like we have in previous units with the plus or minus. But since we got it down to a whole number, we're going to go ahead and simplify it. So here, if I do the top first, that's why you notice I put parentheses there, so this is important. So 3 plus 9 is 12 divided by 2. Here I get 3 minus 9, that's negative 6 divided by 2. So my x's are going to be, if I divide here, this reduces to 6, that's negative 3. So again, these problems do require a lot of work. So let's go ahead now and find our order. Alright, so we got our 2x values, so now we need our 2y. So I'm just going to plug into the first one because it's linear. So we always want to plug back into our linear equation. And my other equation, y equals times my negative 3. So I simplify it. Plus 12, which is negative 3. So my two solutions are x is equal to 6, comma 42, and x is equal to negative 3, comma negative 3. So those are representative of our two solutions to this equation where it intercepts it twice. Take a moment now and ensure you have all that worked out. All right, let's go ahead and move on here. So again, we have both equations solved for y, so we're going to employ substitution. So this gives me my quadratic, 2x squared minus 4 is equal to 4. So there's a 4 here. So if I go ahead and subtract that 4 over, I get 12x squared minus equal to 0. Now, if we think about our quadratic here, we notice we have an x squared term, but no x term. So this is the same thing as saying I have 2x squared plus 0x minus 8 is equal to 0. So a couple methods of solving here. If you remember our square root property, I would know that I could add actually add 4. So if I want to solve one way, I could add this over, so I get 2x squared is equal to 8. Divide both sides by 2, get x squared is equal to 4. Square root, I get x is equal to positive or negative square root of 4. Break that down and get x is equal to positive or negative 2. But let's say we were bad at this, it was challenging for us. I really like quadratic formula. So I'm going to leave that up for now if you want to copy that down. But let's go back here and do quadratic formula. So we talked about having a 0, so that gives me my a is equal to 2. My b, since it's not there, is 0. And my c is negative 8. So take a moment now, get that down. So pause the video, and then we'll come back to solve. All right. So we go ahead and erase all this now. So we have our a, b, and c here. So that gives me x is equal to the opposite of b. Well, opposite of 0 is still just 0. It's oddly enough the only number in the entire number line that has that property, where its opposite is itself. It's also my daughter's favorite number. So b here is going to be 0 squared minus 4ac all over 2a. So the 0 plus or minus actually goes away. So here I just have plus or minus. And if I did this in GeoGebra, 0 squared minus 4 times 2 times negative 8, which would give me positive 32 all over 4. So we have positive 32 over 4. Now let's see if we can break this down a bit more. 32. So go ahead and break that down, right? So that's 2 and 16, 2 and 8, 2 and 4, 2 and 2. So I have my 2's here, which means I could take out 2 pairs and be left with my square root. Take here. So actually, if I multiplied this, my bad, I did that wrong. This should be 64. So if we break that down, go ahead and correct this a bit here. I'd get 2 and 32. And I'd have 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. So I have 1, 2, 3, 4, 5, 6 2s. So I'm taking out my pairs, which means I could take out 3 of these, which is going to give me 8. So this would give me x is equal to positive or negative. We lost our square root. 8 over 4. And then if I solve this, that would be, let's go ahead and erase this. So pause it if you need to get to work. So I'd have positive 8 over 4 and negative 8 over 4, which give me 2 and negative 2. So we're getting those same answers as we had before. So you'll notice no matter which way you solve this, assuming you don't multiply wrong in your head here, you'll get the exact same answer. So if I plug those in, we have our linear one here with no x's. So what that tells me is no matter what my x is, my y is equal to 4. So I have 2 and 4, because then it's y equals 4 here, kind of a special case. And my other solution would be negative 2 and 4. All right, moving along. So here we have both y equals again, so let's go ahead and start solving. So I have x squared plus x minus 7 is equal to 3x minus 2. I subtract my 3x from both sides, which would give me x squared minus 2x, because remember there's a 1 here, minus 7 is equal to negative 2, because it's minus here. So then I'd add 2 to both sides. I'd get x squared minus 2x minus 5 is equal to 0. This one, no matter how hard you try, won't actually factor. So what that means we have to do is solve using quadratic formula anyway. So I have my a is 1, or x is 1. A is 1, right? So I have b is negative 2, c is negative 5. So opposite b plus or minus square root b squared minus 4ac all over 2a. So as we start simplifying, if I utilize GeoGebra here, be square root of 24 all over 2. So that'd be 2 plus or minus. If we break this down, I'd have it's even, so divisible by 2 and 12. And I divide it again by 2 and 6. And I get 2 and 3. So let's see what we can take out here. Take out a 2, and I'm left with a 2 and a 3. So that'll give me 2 root 6. And last thing we want to check in Machine as we expand our knowledge a bit here is if we can reduce anything. So I notice all 3 of these coefficients are 2. So if I divide everything by 2, that would give me, well, 2 divided by 2 is just 1. And then that goes away, so it's just square root of 6. You know what? For our purposes, we're totally fine here. And since we have really, really ugly solutions here, it's x plus or minus something with a square root, we can just go ahead and leave it just how it looks here. So if it's really ugly, don't worry about plugging in. I'm concerned that you can solve to this point. So other ones, if they came out to whole numbers, we reduced. Here, since we're left with quadratic formula at this point, we're just going to leave it how it looks. All right, let's go ahead and do how many more of these we got. Let me just do a quick check here of what we got left. All right, let's go ahead and do like 2 more of those. No, skip that one. Let's do one more good one, right? Okay, so we have x squared minus x plus 3 is equal to 2x plus 2. I subtract 2x from both sides, giving me x squared minus 3x plus 3 is equal to 2. Subtracting 2 gives me x squared minus 3x plus 1 is equal to 0. So with our quadratic formula again, we have x is equal to the opposite of b plus or minus square root b squared minus 4ac all over 2a. So utilizing GeoGebra here, I'd have 3 plus or minus, that'll give me square root of 5 all over 2. And we see we have a square root, so we know we are done. So again, when we're left with a square root in the quadratic formula, I am totally fine with us leaving the answer as that. All right, move on along here. So these will be left up to optional practice should you so choose to do them. And I would be more than happy to check your answers if you'd like. As well as this one up here. So I'm going to go scroll real slow here so you can kind of get them down if you want. I'm fairly certain these are available in your notes, but again, if they're not, pause the video, write them down, come up to my desk, ask me. I'd be happy to make sure that you try. Let's skip over this. All right. Now we are going to do some linear equation word problems. So you guys actually seen these back in Algebra 1, but we're going to go ahead and go through now and just make sure we have these all down pat. Okay, so we have 1, 2, 3, 4, 5, 6. All right, so we have 6 examples to get through, and that'll conclude these notes. We're actually going to do all these together just to make sure we have a good grasp on them and are prepared for our exams. Okay, so in the fall, the Math Club and the Science Club each created a website. So we have 2 different things we're talking about here. You are the webmaster for both sites. In January, you compare the number of times each site is visited each day. For the Science Club, there are currently 400 daily visits, and the visits are increasing at a rate of 25 daily visits per month. For the Math Club, we have 200 daily visits, and the visits are increasing at a rate of 50 daily visits per month. Write a system of equations to represent the number of daily visits V to each site for T months since January. Okay, so we're thinking about how many visits each month. So let's think about our first one. So let's talk about the Science Club first. Let's call it our S equation and our M equation. So it says V visits. So we're going to start off with our capital V for both. Now for the Science one, it says we have 400 daily visits. So we're starting off with 400. And it's increasing, so that means plus 25, and the word per here means multiply. So it says T months, so we're going to go with 25T. The next one, we says 200 daily visits from the math side and increasing at a rate of 50, so plus 50T. Let's go a step further here and let's say we wanted to solve these. So when these 2 things are going to be equivalent. So I would have them both solve for V, so I could just set them equal. So it would be 400 plus 25T t is equal to 200 plus 50t. So let's say I want to move my t's to the left, so I'd subtract 50 from both sides and get 400 equals minus 25t is equal to 200. I could subtract 400 and get negative 25t is equal to negative 200. And when I would divide by both of these, I would get t is equal to positive, because negative 200 divided by negative 25 gives me a positive 8. So I'd know that after about 8 months, those visits would be equal. Now again, it didn't say to solve, but always good practice. Alright, example 2. We have Karen and Jennifer have summer jobs selling newspaper subscriptions door to door. But their compensation plans are different. Karen earns a base wage of 7 per hour, as well as 2 for every subscription that she sells. Jennifer gets 4 per subscription sold, in addition to a base wage of $5 per hour. Write a system of equations to represent compensation C for selling S subscriptions per H hour, or per hour H. So we'll notice the difference here. Here we had 2 variables. That told me I could set it up like this, where one is equal to something involving the other. This one's giving us 3 variables. So first step, I can always set it up where I have these 2 ideas. So I have Karen, and I have Jennifer. Now, we notice we have a capital C, so that kind of gives us our idea where we start. So we're going to start with C equals something. So for Karen, we said 7 per hour. So H is our hours, so that would be 7H. Well, notice the word per here is used twice in each scenario. And then it says she gets 2 for every subscription S, so plus 2S. Jennifer gets 4 per subscription, so let's go ahead and line them up. We get 4S, and 5 per hour H. So again, 3 variables means our setup's going to look a little bit different. So 2 variables is going to look like this, 4 variables like this. All right, let's go ahead and solve here utilizing some elimination. Just make another color pen. Okay, there we go. So if I multiply the top one by negative 2, I can cancel the bottom one here. So it's going to give me negative 14H minus 2S. Actually, you know what? We're not going to go ahead and solve this one because we actually don't have enough information to. You know what? Let's solve it a bit different way here. Instead of using elimination, we have them both solved for C, but we only have 3 variables, not enough information. So this one actually we can't solve as is. We'd have to figure out, like, when will they make the same amount of money or the same amount of compensation, or if they set these 2 equal. So in this scenario, we're not given enough information to actually go ahead and solve this problem. And obviously on a test, I wouldn't ask you to solve something and have enough information for. This one right here, we're going to leave up to optional practice. So if you want to try this try here about field trips to Great America, feel free to do so now and then come up and check with me, and I'd be happy to tell you if you're right. Otherwise, you may move on with the video. Same thing here with this one. So I'm going to suggest that you guys go ahead and try these now because they're really similar to the first 2 questions. This one will look like our second example, and this one will look like our first. So if you want to go ahead, actually I lied. This is the second example. This is the second one we did. This is the first example. So if you want to go ahead and try those now, you can. And I'd be happy to check your work with you and make sure you're doing them right. If you feel comfortable with them, then you can move on. Alright, so this one we'll notice both of these are asking us to do a little bit more work. Last example here, we'll notice this one's got 2 parts. We're actually end up solving as asked by the equation. So we have Kristen School selling tickets to the musical. On the first day, the school sold 2 adults and 8 students for a total of 120. The school took in 96 on the second day by selling 2 adults and 6. So first, let's go ahead and set up our equations here. So it says X representing the number of adults and Y representing students. So for the first scenario, all right, so for the first one here, we have 2x and 8 students, so 8y is equal to 120. Next one, we sold 2 adults and 6 students for a total of 96. So that's our equation. Now it says, what is the price of each 1 adult ticket and each 1 student ticket? So that means we need to solve here. So if we use some elimination, equation by negative 1 to get the x's to cancel. So I get 2x plus 8y is equal to 120. Then negative 2x minus 6y is equal to negative 96. Combining here, we had these canceled, and I'd get 2y is equal to positive, let's see, 24. Then if we go ahead here and divide, I'd get y is equal to 12. So now to figure out the other side of this, I would take either of my original equations and plug in. So that'd be 2x plus 96 is equal to 120. Subtract 96 from both sides. Dividing, I get x is equal to 12. So here in this scenario, both our student and adult, this is our adult, our x's, and our student here, are $12. Take a moment, ensure you have all this down, and at that point, I would 100% suggest trying to solve this problem, which is really similar to the example we just did, and then check it in with me. So pause the video now and begin this problem. After that, we are all good. So this will conclude the notes for this Unit 6. Make sure you have everything down here, and then feel free to come check everything with me, begin your practice, use that answer key there to make sure those are good. And before you know it, we'll be going ahead and reviewing as a class to take our Unit 6 exam. All right, so we're going to go on with Unit 7 notes here. So let's start off with reviewing our right triangles. So with Pythagorean theorem, basically the longest side, or hypotenuse, always gets its own side equal sign, whereas the two short sides, when we square them and add them, are equal to it. So if I set this first problem up here, I see x is my hypotenuse. It's across from my right angle. So if I square the short two sides here, let's see, that'd be 36 plus 16. Again, GeoGebra will handle these calculations as well. 52. And if I take the square root there, and again, with length, we're always going to be moving in positive. 52, well, that would be 2 and 26. 2 and 13, so our simplified version here, I think I'm up here 2 is due to 2, and I'm left with 13 on the inside. Here we see across from our angle the 11, so I'm squaring up to the short side. Good. 9 is equal to 121. And if we subtract, let's see, so if we take away 40, that gives us 81. It's going to be 72, so taking our square root. If we break that down, we get 2 and 36. Break that down, we get 2 and 18. 2 and 9, 3 and 3, so I can take out a 2 and a 3, and I have a 2 left over. 2 times 3 times square root of 2, so that would be 6 root 2. One more here. So I see my 11's across from that, so it gets its own side. So I have x squared plus, let's think of this in parentheses here, square root of 65 squared equals 11 squared. So x squared plus square root and squared cancel. GeoGebra will attest to that. 1.1, so if we subtract 65, we'll get 56. And then if we square root it and break it down, so that's 2 and 28. Give me 2 and 14. And 2 and 7. So I can take out a pair of 2's, and I'm left with a 2 and 7 on the inside. So that would be x is equal to 2 square root of 14. Alright, moving on down. Okay, here we are using our theorems here. So this is again review, so we're just going to kind of move through these quickly of solving these. So, key idea with 45-degree triangles, the two short sides are the same, and the hypotenuse across from 90 is equal to 2, square root of 2 times x. So here I see what I'm getting is across from a short side. So these are both just x, and this is root 2x. So I know x is equal to 6, so I could go ahead and say this side is 6. And this side would be root 2 times 6, which is 6 root 2. Now this one, and again, these are diagrams that will be on the board when you test, so we're just setting them up from here. So across from my 60, this is root 3x. And then across from my 90 is 2x. Oh, this is 60, this is 30, and that one's just x. So plugging in, if I had 5 here, that'd be 5 root 3. And here, 2 times 5 would give me 10. Let's try these two as well. Okay, so across from my 45, so those are just my x's. And then it's root 2x across from my 90. So I know x is equal to 4 root 3. So if I plug in here, that would be root 2 times 4 root 3. So if we multiply our square roots, we would get 4 square root of 6. So across from my 90 is 2x. Across from my 60 is root 3x. And then across from my 30 would just be x. So here if I solve this, I'll find x is equal to 4. So this would be 4. And this would be 4 root 3. Alright, so at this point, these are going to be left up to optional practice. So I would suggest solving each of these 3 problems and then checking with me to ensure your answers are correct. So pause the video now and practice with these 3 problems. Alright, let's check these 2 examples real quick together, and then the next 3 will be left to optional practice. So if we set up our 45, we know we have x and x. And this is root 2x. So to find my x, I have to divide both sides by the square root. So I get x is equal to 10 over square root 2. To get rid of that in the denominator, we multiply the top and bottom by that square root. So if I multiply the top and bottom by square root 2, on the top I'm left with 10 root 2. On the bottom, square root of 2 times 2, the root 2 is just 2. And I could simplify, well 10 over 2 is just 5, so I get 5 root 2. So that would go in both of these spots. Here, setting up, so across from our 90 is equal to 2x. Across from my 30 is just x. And then here, it's equal to, across from my 60, root 3x. So dividing again, we'd have x is equal to 7 over root 3. Multiplying, I'd get x is equal to 7 root 3 over 3. And those don't reduce, which we could check using fraction text in GeoGebra without typing in the square root. So I'd just do fraction text 7 divided by 3, and it would spit out 7 over 3 again. So if we plug in, this side is just going to be that 7 root 3 over 3, because it's just equal to x. Here it would be 2 times that. So in a calculator, what I would suggest doing in GeoGebra is doing fraction text, 2 times parentheses, 7 divided by 3 parentheses, hitting enter, and you will arrive at 14 over 3. And we keep our square root on the top. At this time, I would suggest doing these 3 problems on your own and then checking with me to ensure your answers are correct. So pause the video now and complete these 3 problems. Alright, moving on to some trig functions here. So we're going to deal with 6 trig functions here. So SOHCAHTOA, what this stands for is sine is opposite over hypotenuse. So we're going to need to memorize these. So SOHCA, adjacent over hypotenuse. And TOA, which is opposite over adjacent. Reciprocals mean we just flip them. So sine and cosecant go together. So I flip it. Cosine and secant, flip it. Tangent, cotangent, we just flip it over. Alright, so what's really important here is how we label that OA and H. The key idea here is we start with what our theta is, or whatever our angle in question is. So if I draw a line directly across from it, that side is always my opposite. So here, if I drew a line across, opposite. If I drew a line directly across, opposite. The next thing I was doing is drawing a line from your right angle. That's always going to be my hypotenuse. So across my right angle, hypotenuse. Across from my right angle, hypotenuse. Those are the 2 we can always label easily. And then what's left, what other side is there, that's just our adjacent. So whichever side we haven't labeled yet becomes our adjacent side. All right. Now we're going to figure out all 6 trig functions from these. We're going to figure out all of our fractions, and if we have any square roots in the bottom, we will need to simplify. So let's go ahead and label first. So across from this angle, if I draw a line straight out, there's my opposite. Across my right angle is my hypotenuse. Here's my adjacent. Across from here, my opposite. Across from the right angle is my hypotenuse. And then here's my adjacent. So in the first example here, we're given all 3 values. So sine, so, that's over h. Ka, a over h. Toa, over a. And my reciprocals, notice they're lined up here. So I flip it, and flip it. Alright, so over h, that's 15 over 17. A over h, that's 8 over 17. Over a, 15 over 8. Flipping them over here. So this is pretty easy when we have just all nice whole numbers. It's pretty easy as well when we don't, just maybe a couple more steps. Alright, so here, we notice first off, we have an opposite side without a value. So to solve for it, we're going to use our Pythagorean theorem. So my 2 short sides, so I'm just going to call this O. Let's put a line, let's put a line through all of our O's, just so we know that they're not zeros. So here I'd have my opposite side squared plus my A squared. So always think of this formula for our specific case here of trig. It's the same as Pythagorean theorem, just rewritten with the variables we use. And again, if you use that O with a line, it won't get mistaken for a 0. So my A squared is 2, and then my hypotenuse there, my A squared is square root of 10 squared. So that gives me 4 is equal to 10. Subtracting, I'd get O squared is equal to 6. And the square root there just gives me square root of 6, which won't break down. So, sine opposite, which we said is square root of 6 over hypotenuse, so square root of 6 over square root of 10. Let's go ahead and write them out first, and we'll simplify if we need to. So A is this. There's my hypotenuse. And O over A. Flipping them. Alright. So I'm going to get a different color pen here just so you can see some simplification. Alright, so first thing I look at. Now, once I've written all of them out, I got to start cleaning some stuff up. So I have a square root of 10 in the bottom, so I'm going to multiply it by top and bottom. So I get the square root of 60 over 10. Here I multiply again by square root of 10 on top and bottom, so I get 2 root 10 over 10. And this one will simplify, so 2 over 10 reduces to 1 over 5, so it's just root 10 over 5. And again, GeoGebra, fraction text, 2 divided by 10 gets us at 1 over 5. We could write the 1 here if we want to, but don't need to. This one's already good, no square root in the bottom. Here, root 6 in the top and bottom. So I'd get square root of 60 over 6. This one's good. This one, our root 6. Checking with our fraction text, we find it simplifies to root 6 or 1 root 6 over 3. So not necessarily harder, just to add a bit more work. Alright, moving on. At this point, you should go ahead and try these 2 problems now, and once they're completed, come check them in with me. So pause the video at this time and begin these 2 problems. Okay, so here we have find the values of the trigonometric function indicated for each angle measured. This is where we're going to go ahead and employ our unit circle. So by having the unit circle, we avoid a little bit of that work we need. So we're actually going to go ahead and just do these utilizing the unit circle. So at this point, you can go ahead and take out your completed unit circle, which we'll have memorized and gotten down past at the beginning of this unit. Once we do that, it makes finding all this a bit easier. So sine 30, when we look at our unit circle, 30 is in order of cosine, comma, sine, so alphabetical. So at 30 degrees, we have the coordinate of square root of 3 over 2, comma 1/2. So sine of 30 is just 1/2. Tangent of 45. Well, tangent is defined as sine over cosine. So that's 45 over 45. So if we plug in from our unit circle, at 45, sine is root 2 over 2. And cosine is also root 2 over 2. Since these are the exact same number on top and bottom, we know they cancel out to just give us 1. Now, cotangent of 60. Well, tangent is sine over cosine. Reciprocal, cosine would be 60, so we flip it. So instead of sine over cosine, it's cosine over sine. Using the unit circle at 60 degrees, we look and we see that cosine here is going to be our first value, which is 1/2. So this is equal to 1/2 over sine at 60 degrees is root 3 over 2. So now these aren't the same number, so we can't just cancel the 1. So to work with these, I would take my top fraction and multiply by the reciprocal. So I flip over the bottom one. Multiplying across, we get 2 over 2 root 3. Our 2's cancel out, so I'm left with 1 over square root of 3. Getting it out of the denominator, we get 1 root 3, or just root 3, over 3. Alright, let's go ahead and do these three together here. So secant of 60, well, let's see. Secant's not on the unit circle, so let's see what I can do instead. I know that secant goes with cosine, so what I'm going to do is rewrite this as 1 over cosine of 60. Utilizing my unit circle, I look at 60 degrees and realize that cosine there is equal to 1/2. So this is 1 over 1/2. Using our reciprocal again, because we have a fraction at the bottom, or GeoGebra because there's no square roots involved. This would be 1 times 2 over 1, which is just 2. Cosecant, well, we know that goes with sine, so this would be 1 over sine of 45. Using our unit circle, we realize that that's going to be root 2 over 2. So the reciprocal yet again. So this is just 2 over root 2. Getting it out of our bottom, as we've done a couple times already, gives me 2 root 2 over 2. Cancels, so I just get square root of 2. And cosine of 30, referencing our unit circle, we'll see that that's just root 3 over 2. Alright. Okay, so now we're going to find all 6 given some information. So key idea here is going to be drawing out our circle. So we need to think about positives, negatives, and all that wonderful stuff. So right here we have that sine is equal to 4 over 9. Well, if we remember our SOHCAHTOA, sine is opposite over hypotenuse. So I think of my formula, right? So I know that O squared plus A squared is equal to H squared. And we don't have an A, because all we know about is sine. So if I plug in here, that's 4 squared, don't know what A squared is equal to 9 squared. So it'll give me 16 plus A squared is equal to 81. And if we subtract 16 from both sides, we get A squared is equal to the square root of 65. So it's not divisible by 2, not divisible by 3. If we try dividing by 5, we'll get 5 and 13. Those don't break down. So A is just going to be that square root of 65 because we've taken our square root. So as I plug in O, we already know here our sine is 4 over 9. Flipping it, cosine is A over H. Tangent, O over A. Flipping here. And flipping here. Now our simplification, right? So we see some square roots in the bottom, so I need to do my check. Good, good, not good. So if I multiply both top and bottom by square root of 65, we arrive here. That won't reduce. We're good here. If I multiply both top and bottom by square root of 65, We're good here. We check in GeoGebra. Doesn't reduce. And this one's good. Alright, so let's think what we know here. I see secant is by cosine. It's the reciprocal, so this is actually h over a. So I don't know my opposite. So if we go ahead and plug in here, and then 17 squared gives me 289. Subtracting 100 gives me 189. So let's see here if we can break this down. So when I take the square root of both sides, I got to check if I can break it down. Not divisible by 2. We check, not by 3. Oh, it is divisible by 3. So I divide it by 3 here, and then I would get, so we factor this thing down here, I'd get 3 and 63. 63 divisible by 3, that gives me 3 and 21. And then 3 and 7. So if we break that down, we see we take out a pair of 3's, and we're left with square root of 21. Because of 7 times 3. Alright, so let's go ahead now. We have our opposite side and write a trig function. So this one is O over H. A over H. O over A. Moving over here, we flip them. Oops, wrote that one wrong. Flipping again. Which makes sense, we already had that one. Then here, it'd be 10 over 3 root 21. Here, square root's not in the bottom. We're good, we're good, we're good. This one we multiply top and bottom by just square root of 21. So on the top I'd have 17 square root of 21. And then I do 3 times 21 on the bottom. The square root of 21 times square root of 21 is 1. So that gives me 17 over 63. And that one is not going to reduce. We're good here. Square root of 21 on top and bottom gives me 10 root 21 over 63 again, and we know that that will not reduce either. So we're good there. At this point, you guys should go ahead and try this problem, show all your work, and then come check it with me to ensure you've got everything down. So please pause the video at this time and complete the following problem. Alright, so good there. Alright, now, this one, here's some steps to solve. So first we're going to kind of use a point to get an idea here. So we're actually going to skip over this part and let's just go right into some example work. Alright, so for these next, we'll do let's see here. We'll do 2 together and leave 1 up to optional practice. So this one is something you're going to do on your own. We'll do these 2 together. So we're given a point and we need to find all 6 trig functions from it. Move on here. We have our 2 points. So first off, we need to think a little bit about where these points might be. So if we look, sorry, it's frozen up. As we're looking, pretty much we know our x's and y's are positive. So x's and y's are positive here. So this is positive xy. To the left, this is negative x, positive y. Down here, everything is negative in quadrant 3. And in quadrant 4, my x is positive, my y is negative. At this point, this should be 100% review, but if you don't know that, please write down the diagram, as we'll be using it. Alright, so here I have my point is at positive 3, positive 4. So, positive 3, positive 4. So if I think about these are all going to be different variations of triangles. So, kind of a general diagram we're going to use here is going to look something like this. So each of our triangles are going to follow this type of bow tie pattern. So if we use that, we know we're in quadrant 1, so my triangle is going to look something like this. Our angles are always going to come from the middle. and then our right angles are here. Let's go ahead, and I'm actually going to draw a better version of this diagram just so we can have that down. I suggest you draw this big somewhere that you have it. So here's our xy's. So here's our triangles. So they're always going to be one of these four for this unit. Whenever we deal with any of these, it'll be one of these. And our angles always come from the middle. And what looks like right angles are right angles. So these are right angles and these. So we'll utilize that to solve our problem. Alright, so here I know that this length is 3, so we can think of this being our 3. And if my height is 4, that means this is 4. So, if we look at our labeling, we have our O. This is my H, which I don't know yet. And then my A is what's left over. So to solve for this, we'd utilize Pythagorean theorem. So I'd have 3 squared plus 4 squared is equal to our H squared. And from solving, we'll realize H is going to be equal to 5. Like our hypotenuse is always going to be a nice positive number. So now that we have those, we can go ahead and set up our different answers. So O over H, that's 4 over 5. A over H is 3 over 5. O over A. And then we do our flips. So nothing too challenging, just a little bit different way of doing the problem. All right, let's do this one here. So we have two negative numbers here. So if I think about that, that means I'm in my bottom quadrant there, so that third quadrant to the left. So we'll be dealing with this triangle. Negative 1 refers to my x value, so that's here. Negative 4 means my y, so that's here. We go ahead and solve this. Make sure when you square your negative numbers, you put parentheses around them, otherwise you'll get the wrong value. We're solving for our h again. Notice every time we have one of these problems, we're always solving for h. So this will be 1 plus 16 is equal to h squared, and we'll get h is equal to the square root of 17. So h, our angle is always in the center, so this is my O, and there's my A. So sine negative 4 over square root of 17, cosine negative 1 over square root of 17. Over A, that would be negative 4 over negative 1. Cosecant, the negative we can always just write on the top, since there's just one of them, it doesn't make a difference. But if you leave it on the bottom, that will suffice for an answer as well. Alright, so let's go ahead and simplify these. So here I have a square root on the bottom, so I multiply on the top and bottom. That'll give me negative 4, square root of 17 over 17. That will not simplify any further. GeoGebra will check it. Here, I'd multiply on top and bottom and get negative square root of 17 over 17. Here, no negatives or square roots, but if we simplify, this is just 4. Here I'm good, good, and this one, good. So at this point, go ahead and try this problem on your own, and once you're complete with it, come check with me to ensure you've done it correctly. Make sure you're using the right triangle. So positive x, negative y, we should be in this location, with a 5 and a negative 7 here. Alright. Moving on. So here we're dealing with a couple different vocab words. Let's go right into examples here. So standard position. Now, if I think about these, each of these is a right angle. So this is 90 degrees, 180, 270, and 360. So writing those in first is always a good starting point when we're asking to sketch where an angle resides. Go ahead and get all those in first. Alright, so for this first one, 120. Well, that's between 90 and 180. So it's going to be somewhere in here. 200 is between 180 and 270, so somewhere in here. And 290 is between 270 and 360, so somewhere in here. And that's about it for those. Alright, coterminal, basically it means we have a kind of an angle that ends in the same spot, just a different number. That comes from the idea that we can keep going around this circle over and over by adding 360 degrees. So if I started at something like 10 degrees, I could keep adding 360 and it would represent the exact same angle. Alright, so coterminal negative 35. Well, if we think about this, instead of going up to get our positives, negative 35 would be somewhere down here. So to figure out what that would be as a positive angle, I would add 360 to it, which would give me 325 degrees. So coterminal angles, we want to find positive angles from that. So if we start with a negative, we're going to add 360. So here I have negative again, so I'm going to add 360. And that'll give me positive 130. Now here we have a positive angle. So instead of adding, I'm going to subtract 360. Because we need all of our answers to be positive numbers between 0 and 360. So 515 minus 360 gives me 155. It's now a positive number between 0 and 360. Here we start with a positive, so we're going to subtract. We get 494. It's not quite small enough yet, so I'm going to subtract 360 again until we arrive at a positive number between 0 and 360. I get to 134, so I'm good there. Alright, so negatives mean add, so we're going to add 360 here, and we will get positive 260. Add 360, because we have another negative, positive 20. Here we're subtracting 360, and we get 335, so that's between 0 and 360. The last one, if we subtract it one time, we get 880, so we're going to minus 360 again. We get 520 minus 360 again, and we'll get to 160. So we can subtract it more than once, as we've seen before. Okay, radians are just another way of doing degrees. So it's just a different measure. We'll talk about how to convert. So, going from degrees to radians. If I go this way, I'm going to take my degrees. So let's go ahead and throw all these over 1. And I want to go to radians. Actually, you know what? Let's make this a bit easier. Alright, so in general, how we go from degrees to radians is we divide by 180. So in GeoGebra here, we want to get a nice reduced fraction, so I'll do the first one, and the left you guys can do the same thing. So we have 30 divided by 180, so we want to use our fraction text as always. So let's do fraction text, 30 divided by 180, that's just 1 over 6. So I have 1 over 6, and we said our second step here is pi goes on top. If I do 45 divided by 180, I'll get 1 over 4. Pi goes on top. 120 divided by 180. GeoGebra gives us 2 over 3. Pi goes on top. And 225 divided by 180. We get 5 over 4. And pi goes on top. So again, that's definitely a formula I'd write down, the divide by 180 pi on top when going from degrees to radians. Going the opposite way here. So for this one, to go from radian to degrees, we're going to multiply by 180 over pi. So let's go ahead and set all those up. So notice it's going the opposite way here. Another formula I'd definitely write down. So one thing we're going to notice here is we have a pi on top and bottom. So they actually are going to cancel out. So on each of these, our pi's cancel, which makes sense because in degree measures, we never have pi involved. So what these simplify to is 3 times 180 over 4, 7 times 180 over 6. There's nothing else. There's just having a 1. So it's 1 times 180 over 2. Here would be 5 times, 5 times 180 over 12. So, if we're in GeoGebra, we're going to type exactly how it looks. So let's get rid of what we have. So we have 3 times 180 over 4, so I'll show one example in here. 3 times 180 over 4. And we get 135 degrees. This one would reduce to 90 degrees. And 7 times 180 over 6 gives us 210 degrees. And lastly, 5 times 180 divided by 12 gives us 75 degrees. So again, those are just formulas to keep handy while working through these problems. Moving on. All right. So, working through these now. This is actually, I believe, our last section here. We'll skip over these reference angles at the end. So let's just go ahead and work through these. So, quadrant signs and trigonometry. A couple ways to think of this. Our first acronym here is all students take calculus. So all students, you know what, we're going to skip this. We're going to do it a better way. Not necessarily a better way. If you've already learned the all students take calculus method, you are more than welcome to use it. I prefer to go ahead and just kind of think through it here. So, our first quadrant is represented up here. So this is Q1. You'll see me use those as opposed to Roman numerals. So this is also just quadrant 1. So it's this. Quadrant 2, otherwise known as this. Quadrant 3, otherwise known as this. And quadrant 4, otherwise known as IV. Alright. So, first thing here, we want to think about what's positive in each. So if we remember our unit circle correctly, all these coordinates are deemed as cosine, comma, sine. So utilizing our unit circle, which we will have on the exam, is we look in the first quadrant, we see cosine and sine are all positive. So that means I have, if we just go in the usual order, so sine, cosine, tangent. And then our other three here, we have cosecant, secant, cotangent. So this is something I would suggest doing as I'm taking a test. I would write all these out. So we're going to identify the positive and negativeness of all three of these just by using a few key ideas. So this is a diagram I would definitely be writing down because it's going to prove incredibly useful as we're going through practice and taking our tests. Okay, so in the first quadrant, if we look at our unit circle, everything, all my coordinates on the outer rim are positive. So I know sine and cosine are positive. These are just the reciprocals. So these are positive, so are these. Now, tangent is defined by sine over cosine. So if I divide two positive numbers, I end up with a positive. If this is positive, this is positive. So you'll notice the signs on these always match with these. Now in quadrant 2, here I have negative cosines and positive sines. So let's think here. Sine is positive, that means cosecant is positive. Cosine's negative, so secant's negative. Tangent is sine over cosine, so a positive divided by a negative is negative. If this is negative, so is this. Quadrant 3, this is where we have all our negatives, so all of our cosine and all of our sine values are negative. So sine and cosine are negative. If these are negative, so are these. Tricky part here, tangent. So if I do sine over cosine, well, negative over negative gives me a positive. If this is positive, so is cotangent. In quadrant 4, our cosines, our x values are all positive, but our sine values, or y values, are all negative. So I have negative sine, positive cosine. Negative means negative, positive means positive. And if I think of my division, a negative and a positive give me negative. So this will be negative as well. Now, using that diagram, we're going to answer these questions. So, first, Sine is greater than 0. That means it's positive. Cosine is less than 0. It's negative. Tangent greater than 0 means positive. Sine less than 0, negative. Tangent less than 0 is negative. Cosine greater than 0, that means positive. So we're going to answer each of these questions individually. So here I am looking at places where sine is positive. That's only 2 quadrants. So if I look, it's positive here and here, negative in here. So that means I'm either in quadrant 1 or 2. So quadrant 1, quadrant 2. But now I want cosine to be negative. So if I look, it's positive here and negative here. So my answer would be quadrant 2. Tangent is positive. So let's see, it's positive here in quadrant 1. And it's positive here in quadrant 3. Now I want sine to be negative. So sine's negative, let's see, it's not here, not here. I know my answers are 1 or 3. So it's not negative here, but it's definitely negative here. Therefore my answer, quadrant 3. Alright, tangent negative. So I see that's in quadrant 2 or quadrant 4. Cosine positive, well, I'm looking at 2 and 4. It's not positive here, but it is here. Therefore my answer, quadrant 4. Use the same strategy and the same diagram to answer the next 3 problems. Once you've completed these, ensure that you check them in with me, and that you're good to go to move on. So pause the video at this time and complete those problems. Right, moving on. Okay, this is going to be our last 4 problems. Like I said, we'll skip over reference angles for the purposes of this unit. Alright, we're going to need some diagrams. We're going to figure out where things are. Alright, so here we're given a lot of things about different degrees or where things are positive. So you're going to use a lot of that diagram from above. Alright, so we're going to do 1 in this one and then 2 in the next one. Okay, so I know sine is 3 over 5. So I got my opposite and my hypotenuse. That's a good start, right? Now, it says I'm between 90 and 180. So if we use that, okay, this is 90, this is 180. So I know I'm somewhere in here. So again, we're dealing with those same 4 triangles we talked about. My angle, oops. So my opposite is 3. So I go to my opposite side, that's a 3. My hypotenuse is 5. Well, it's my right angle, so here's my hypotenuse at 5. I need to find my A. So first I'll do Pythagorean theorem. So O squared plus, oh no, I put a 3 there. A squared equals H squared. So I'd have 3 squared plus A squared, 5 squared. When you solve this, you'd have 9 plus A squared equals 25. You'd subtract it, 16. The square root of 16 is 4. So my A is going to be 4. Now, we're just writing that fractions. So sine over H, cosine A over H, O over A, and we do some flipping. And we're good to go. So you'll notice all these problems are really similar. They just give us slightly different information. Let's go ahead and do this one here. So cosine, I know that's A over H. One quick thing I just forgot to mention and realize now. Looking at where we're at, is this a positive or negative number? If you said negative, you're correct. So since we're in this general area, this should actually be as A is equal to negative 4. So what we're going to do is just change all those 4's to negative. So negative here, negative, negative. So again, just something to think about when we're going to go ahead and do those is make sure we're labeling them correctly based on what quadrant. Since we went to the left here, it's negative. Y is still positive. And again, we can reference those.
So finishing up our 2-part video here, so we found our cosine and adjacent our hypotenuse. Very correct, they're negative here. So as we move through here, we know we're between 270 and 360. So using a few of our diagrams, we know that gives us this triangle. So moving on through, we have our opposite side, which we don't know yet. Our hypotenuse is going to be 13, and our adjacent side here is going to be 5. Now, if we do some find that our adjacent side, or our opposite side here is 12. Since we're down here, we know that our y value, our opposite there, is going to be negative. So setting these up, we have opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then going ahead and flipping these. We are good to go. So nothing too challenging there, just kind of going through. So our last two problems are going to be a tad bit different, but not much harder. So here we're just told to figure out our quadrant based on what this is. So if we use our diagram above, we know that cosine being greater than 0. That narrows us down to either quadrant 1 or quadrant 3. Here we're given a negative, so adjacent over hypotenuse. Now, we know one thing, that hypotenuse, because of the way we find it, can never be negative. So we want to think of this negative being with our top number here. So that means that I need to plot our points. So if I want my adjacent side to be negative, that means I'm going to be to the left. So we're down here somewhere. So I know I'm going to the left negative 3. Now, we said our choices were quadrant 1 or 3. So by default, I have to be in quadrant 2. We also know our hypotenuse is 17. So if we go ahead and solve, we have negative 3 squared, so we have our adjacent and our hypotenuse. And this will be the last one we're actually going to do together here. The left will be up to optional practice. So plus opposite squared, 13 squared. That gives me 9 squared is equal to, let's see here, 29, subtracting, opposite is equal to, let me take this square root of 280. Let's see if we can break that down. So 280 divided by 2. 240 gives me 270. 235. So it's add one pair of 2s. So 5 and 7 in there. So if I multiply those, I get 7. So my opposite side is 2 square root of 70. And we froze up here, give it a second. Yep. So, opposite, hypotenuse, adjacent, hypotenuse. One more quick thing, if we're in quadrant 3, this will also be a negative. Let's go ahead and throw that in there now. And then opposite adjacent. My bad, right at negative 3. That should be a negative 15. So we're actually going to have to redo this problem. Let's go ahead and fix that now. So these are all totally incorrect. Although our method for finding them will be the same. Sorry about that, guys. Everyone makes mistakes. This one, actually just give me some nice number, 8. So this is actually just going to be negative 8, so that simplifies things a tad bit there. So now, so negative 8 over my hypotenuse, adjacent over hypotenuse, and then over A. Real quick, let's simplify this one, so we know that these are both negative, so it's going to be positive, 8 over 15. And then flipping on this end, and we know we get a positive as well, so 15. So that's about it for our notes for this unit. We've covered everything we need to ensure that you have it correct. We're down here at the end. At this point, you need to move on to your practices and make sure you're checking your answer key, asking any other questions. And then we will be moving on to a review and exam for you.
Alright, so we've made it to the end of summer school, and this is our last unit together. So what we're going to do is actually just kind of focus on what was a formal review with a lot of practice questions here. So we have a particular sound wave can be graphed using the following function. So things we want to remember. In general, all of our equations are going to follow a similar path. So everything, let's go ahead and take some side notes here. So on a separate sheet of paper, let's go ahead and write some things down. So we have y equals a sine b x minus h plus k. Then we're going to go ahead and write down y equals a cosine b x minus h plus k. And lastly, we're going to write down y equals a tangent b x minus h plus k. So these are going to be our three different functions we work with. So we're going to work with sine, cosine, and tangent. So in general, we're going to talk about just a few things with each. So the general shape of sine is going to look as follows. What we're going to have here is going to be sine. We're going to think of our acronym being 3 on a line. So in general, what that's going to look like is some graph of sine is going to have 3 points that lie on a straight line together, known as the midline. If a is positive, we're going to go up and then down. If a is negative, we'll still have our 3 on a line, but our first point will be down as opposed to up. Now notice, if I start with my beginning end, the middle point is halfway between. Halfway, halfway. Same thing here. Halfway between, halfway between. That'll make more sense as we graph. Cosine is going to follow a V shape. So if a is positive, we'll start at the top, end at the top. Go all the way down, and then get some points in between. So it's got a little bit of a V to it. If a is negative, we start at the bottom, end at the bottom, top, and are halfway between. Tangent, if a is positive, we're going to have a sort of 3-point pattern here. If it's negative, it'll just kind of be reflected a bit there. And these will all make more sense as we do some examples. Just going to talk about these. So A is what's known as our amplitude. It deals with how tall or how far apart certain points are on a graph, kind of the top and bottom feel to it. Sine, cosine, and tangent, those are just indicators of what our pattern looks like. B is going to deal with the period. So let's get some other colored pens in here. Our period here with sine, so period is equal to 2 pi over b. Cosine, same thing, 2 pi over b, so great notes to have here. And with tangent, it's actually just going to be 1 pi, or just pi over b. So b is really just used to determine what our period is for these functions. Periods refer to how long it is. So one cycle is following one of these patterns, whichever one it may be, depending on which graph we're using. But in general, a period just refers to the length or how far it takes to complete that one pattern or one cycle. H and K deal with our shifts. So H deals with a horizontal shift. It might move our starting points to the left or to the right. And we think opposites because we're inside that grouping symbol, just as we have in previous units. K is a vertical shift. It's outside the grouping symbol. So if it's positive, we move up, negative down. Whereas on the inside, negative means right and positive means left. This will all make more sense as we move through these problems. So let's go ahead and get started here. Problem 1, we have a particular sound wave can be graphed using the function y is equal to 6 sine of 2x. Find the amplitude and period. So amplitude, one thing to notice is amplitude's always positive. So even if it's a negative out front, we still treat it as a positive. So I know my amplitude, or A, is 6. We also know for sine that the period is equal to 2 pi over b. Oh, that's not right. So I could see here my b following that parent function. It's what's in front of the x. It's a 2. So my period is equal to 2 pi over 2. Fraction text in GeoGebra, that's just pi. So my amplitude is 6, period is pi. Very similar problem here. So here we see a negative out front, but we know amplitude is always positive. My period, my b is 8, so it'd be 2 pi over 8. Fraction text, 2 divided by 8 is 1 over 4, so 1 pi over 4. So amplitude is 10, period, 1/4 pi or 1 pi over 4. They mean the same thing. Alright, here it's asking us to write an equation for a translation 3 units down from our parent function y is equal to sine of x. So if we think back here, our parent function, we said k dealt with the up and down. So let's go ahead and write that out. So 3 units down means like k is equal to -3. So I'm looking for sine of x minus 3. Now the trick part here, okay, so we're dealing with either b or d, right? Now inside the grouping symbol, parentheses refers to left and right. So if I want to move up and down, I don't want parentheses. So my answer is D. Here we're looking at cosine. I'm going to go 3 left. So this is definitely an h value, right? Now if I want to move left, I want to think opposite. So that means h is going to look like +3. Remember, left and right are inside the grouping symbol, so I have 2 choices with a +3. This would mean up 3, whereas this means left 3. Moving on to this one here. So we want 3 units down, so that's a k again. And it's down, so we want -3. So going between these two, this would be moving right because it's inside. So we want here. 4 units up, dealing with a k, and regular now. It's outside that grouping symbol, so we want a +4. So it's between A or C. Well, this would be moved left because it's inside. So we want this one. 2 units right means I'm looking at my grouping symbol, right? So I'm inside. And it's inside, so I need opposite, so I want it to be -2. That puts us between choices B and C. This would mean moving down 2. So we know our choice here. Wait. Is that right? If you said yes, you're correct. Because remember, inside the grouping symbol we mean opposite. So this would signify moving right, and this would signify moving left. So 2 units to the right, we're dealing with h again. And that means we're looking for a negative. So let's see here. There she is. That's our answer right there. Because we're moving right, so we think opposite on the inside there for that -2. 5 units right. Negative again. And we're inside a grouping symbol. So we're at choice D. Last one, 2 units down. So down means I'm dealing with a K, and I want to go down, so it's -2. So I'm either D or A, but this would be horizontal movement. That'd be like right 2. So I want A. Alright, what is the period of y is equal to tangent of 2x? Knowing our formulas, we know when dealing with tangent, our default period is pi, or 1 pi over b. Here, if we follow that parent function, we see that our b is 2. So period, pi over 2. Amplitude. Trick question here. Amplitude is always a positive number. So even though it's a -3 out front, my answer here for my A would just be 3. So we're looking at B. Alright, for this question here, we have used the graph of the sine function, y is equal to 2 sine of x, shown below. Now, how many cycles occur in the graph? So we're looking there for our 5 points. So let's see, we have 3 on a line, go up and down, right? So that's 1 cycle, because this represents those 5 points represent 1 cycle. The period, that refers to the length from beginning to end. So if I go from 0 to 2 pi, well, 2 pi minus 0 is just 2 pi. The amplitude refers to the height from the middle to the highest point. So I'm going from 0 to 2, so my amplitude is 2. Alright, so here, a little more complex, but we're good to go. We know what our parent function looks like. So if I think about that, and I suggest writing this out, whenever we're dealing with something that looks complicated, let's try and make it easier. So the amplitude of the function, that's my A, and it's always positive. So if there's just a negative there, it's like having -1.
So my amplitude is 1. Period of the graph. Well, we're dealing with sine, so I know it's equal to 2 pi over b. And if I look here, my b, I just rewrote the same equation. Don't know why I did that. Let's go ahead and put in those variables from the parent function like I discussed. And now we can go ahead and solve. Alright, now that we have our parent function up here, we can quickly identify that b is equal to 4. So our period is 2 pi over 4, which if we use fraction text in GeoGebra reduces to just pi, or 1 pi over 2. Phase shift, that means our h, so it's a horizontal. So since it's negative, we're thinking about moving to the right, and it would be pi over 2. Vertical shift deals with what's on the outside, so it's positive, so going up, 5. Alright, another one here, so let's go ahead again and write down our parent function, which I'm going to write correctly this time instead of just rewriting the equation directly in front of me. Okay, so amplitude, just 4. Period, let's see our b is 3 here, so it's 2 pi over 3, and that doesn't reduce, so we're good there. Phase shift, it's a negative, so I'm looking at moving right again. If it were positive in those parentheses, yep, we'd be moving left. Let's write pi over 2. In vertical shift, well, it's a negative, so I'm looking at going down 6. Okay, here comes a little bit of challenge. So we're actually going to have to graph these. So in general, our graphs are going to start off with a picture like this. So I'm going to go ahead and draw that for this one too here of another sine curve. Alright, so we've discussed what our general shapes looks like, and we know we need 5 points. So let's start. One cycle of sine with an amplitude of 4. So I know my a is 4, and my period are telling me it's 4 pi. Okay, so it doesn't talk anything about a horizontal shift. So I know that I'm starting at 0, 0. So let's go ahead and plot a point there at 0, 0. Now it's ending at 4 pi. That's my period. So I can go ahead to the end here and write 4 pi. Now to figure out the other points, we're going to start with the idea of the middle. So exactly halfway between 0 and 4 would be 2. So it's 2 pi. In a calculator, I could think of doing 4 plus 0, because that's where we're starting at, and dividing it by 2, which would give me a 2, and then we just throw the pi in there. So we never want to put pi into GeoGebra calculator. And we know sine has 3 on a line, so that's where those points would go. Now we see our amplitude here is positive. It doesn't say anything about a reflection. So that means sine starts by going up. So I find the halfway point by doing 2 plus 0, which is 2, divided by 2 is 1. So that's 1 pi. Here, I would find the middle of 2 and 4, which is 3, and then I put my pi, and I would go down. As far as what these heights are, all we need to do is look at our amplitude. So it's 4, so I have 4, and negative 4. And we can go ahead and connect our lines there to get our nice sine graph. Write an equation for the graph. Well, we know our parent function looks like y equals a, so our amplitude is 4, sine, and then we need our, let's see, our b, x minus h plus k. Well, we didn't have any vertical or horizontal shifts, so I'm not going to have those, but I do need to figure out what b is. So I know that the period is equal to 4 pi, and that a period is equal to 2 pi over b. So if I set those two equal, I have 4 pi is equal to 2 pi over b, multiply by b on both sides, which would give me b times 4 pi is equal to 2 pi. Divide both sides by 4 pi. The pi's will cancel, and 2 over 4 reduces to 1/2. So this would be 1/2 x. Alright, moving on. So we know our amplitude's 4, so right off the bat I can say I'm going up to 4 and down to negative 4. Because I don't have any vertical or horizontal shifts. This is my period's pi. So I'm going to start at 0, 0 and end at pi. Let's think of it as 1 pi, right? So if I want to find my middle, and the reason we don't have a reflection here is because we're seeing that assume a is greater than 0, meaning it's positive.
So we don't have to deal with reflections. Alright, now, if I want to find the middle of 0 and 1, I do 0 plus 1, or 1 plus 0, and divide it by 2. With fraction text in GeoGebra, that'd give me 1 over 2, so it's 1 pi over 2. You'll notice the pi's are always in the top. And that's our third point there. We know it's positive, so I know I'm going to go up, and then down over here. But finding the middle, so I do 0 plus 1/2 divided by 2. My fraction text, I'd find 1 pi over 4. And then here I do 1/2 plus 1, and then use my fraction text to find 3 pi over 2. I know I'm going down there. So we connect our dots, and we're good to go. Now, writing the equation, so we have a, which is 4, sine. We don't have a horizontal and vertical, so we don't need to worry about x and h, or h and k. But we still need to find that period. So we know our period's pi, so we set that equal to 2 pi over b, multiply by pi, so I get, or by b I should say, so it's b pi is equal to 2 pi, divide by pi, the pi's will cancel, I get b is equal to 2, so it's 2x. Moving on, we're graphing again here. So this time we have a negative out front. So I'm thinking of a being negative, my amplitude is 2, but I do have a reflection. Period, let's see. Okay, so that's equal to 2 pi, and our b here is 4. So that's just going to be pi over 2. So let's see for our graph here. Alright, we know we're going, we don't see any horizontal or vertical, so we're starting at 0, 0. I know my height's going to be 2 and negative 2, or my amplitude. So we want to end at pi over 2. So doing some fractions here, it's 1 pi over 2, right? So to find the middle, I would do adding them, so 1/2 plus 0 divided by 2, that gives me pi over 4. Now to find the middle over here, I would do 1/4, so parenthesis 1 divided by 4, parenthesis plus 0, that gives me 1/4 divided by 2, gives me 1/8. And then here, doing 1/4 plus 1/2, and we find the middle of that, we'd get 3 pi over 8. So my end, my middle, and now what that negative out front does for us is instead of going up first, we just go down first. And instead of going down here, we go up here. And we have our graph of our equation. We're not going to worry about finding the y-intercepts. Alright, cosine, right? We're also not going to worry about finding the x-intercepts or the range. We just want to graph this thing. So let's see, I have nothing out front, so my a is equal to 1. I don't have a b, so that's my period. That's like having just a b of 1. So my period is going to be 2 pi. I don't have a k, but I do have an h. So, since it's 3 pi over 2, and it's negative there, we want to think of moving right 3 pi over 2. Alright, so let's get started here. We need our 5 points for cosine, so let's go ahead and start off. Now, sine had 3 on a line. Cosine, we said, had that nice V shape. So it's a positive out front, so we know we're going to start at the top, and our a is just 1, so we're going to start up here. Then wherever our period ends, so at 2 pi, we're also starting at the top. Now, to get the third point, we're still thinking of the middle, but it gives us a V shape. So the middle of 0 and 2, we would find out is 1. And we're going to be down at our bottom, so at -1. So this is starting with our triangle, and we're going to make that V shape out of it. So finding the middle of 0 and 1 here would be pi over 2. So we're going to go here. And then here, we'd find the middle of those and get 3 pi over 2. And our point would be here. Now, the only catch with this one is we want to move right. So what we actually have to do here is do a bit of a phase shift. So to figure out how far to move, let's see. To get to 3 pi over 2, I'm making 1, 2, 3 jumps. So let's go ahead and extend our number line. So I need at least 3 more, right? So I'm noticing each one of these jumps represents a distance of pi over 2, or 1/2. So if I did 2 plus 1/2, I'd get, with my fraction text, 5 pi over 2, 3 pi, or 3 pi over 1, and then 7 pi over 2. So to get my final graph, all I need to do is shift those points over 1, 2, 3 jumps. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And that'll give us our cosine graph there. We're actually going to go ahead and skip over graphing tangent, so let's not worry about that. Actually, I take that back. Let's go ahead and graph tangent, just in case we decide to test on that. Alright, so let's go over here. Alright, so tangent, a little bit different. So we have nothing out front, so we know our a is 1. Our period by default for tangent is just pi over b. And we see our b here is that 4, so thinking back to our parent function. Now, in general, tangent's going to look a tad bit different than other graphs. So, I go to the right and to the left with this one. So to find those points, it's half of my period. So if I did pi over 4 and divided it by 2, that's going to give me 1 pi, or just pi over 8. So on the right side, I'm at positive pi over 8. Left side, negative pi over 8. Now we know our amplitude's 1, so I put a 1 and a negative 1. So I start in the middle, up and right. Oh, sorry about that. We need to get a point first here. So to find the middle of these two, I do 0 and pi over 8. So 0 plus 1 over 8, fraction text, divided by 2, I'd get pi over 16. And over here, negative pi over 16. So we go up and right, down and left, connect our dots with a smooth curve. Good to go. Alright, our last 3 questions here. We're writing equations. So we're dealing with cosine. We'll do all 3 of these together. So let's start with some y equals, right? Alright, so it says I have an amplitude of 2, amplitude of negative 3, amplitude of negative 5. So we know they always start with their amplitudes. Let's go ahead and throw those in. And we're doing all cosines, it appears, so we can go ahead and write cosine. Now it just gives us amplitude and period, no vertical or horizontal shifts. So for the first one, we have a period of 4 pi. So we have 4 pi, and we need to figure out our b, so it's 2 pi over b. For our second one here, we have 6 pi, 2 pi over b. And the last one, 4 pi again, 2 pi over b. So when I solve these, I'd multiply by b on both sides. So this next step here would be b times 4 pi, b times 6 pi, and b times 4 pi again. These are equal to what's left on that side, so 2 pi, 2 pi, and 2 pi. Then I would divide both sides here. So I'd divide by 4 pi on both sides. My pi's would cancel. I'm going to follow that same step for each reason. 2 over 4 reduces to 1/2. Here, pi's cancel. 2 over 6 reduces to 1/3. Here, the pi's cancel. 2 over 4 reduces to 1/2. So our equations are b, 1/2, 1/3, half, and just our variable of x. So that's for all 3 of those. I know this was a short unit, so if you need extra help on stuff, make sure we ask, make sure we're getting our help. At this point, we will go into our review as a class, go through it, and then we'll get through this exam and start preparing for our Semester 2 final exam. Ensure you have all these notes written down. That way you are in the best case to work through the review and prepare for your exam for Unit 8.